Good
Hi
morning. Hello everyone. So we are at live here in RoboCup 2025.
Proudly from Salvador, Bahia, Brazil.
Yes, and we are very happy to be here with you guys today. It's gonna be an amazing event, right, Sofia?
Yeah, it's gonna be amazing. I'm Sofia,
I am Fernanda.
and will be with us through the event to share with you everything that's happening here.
Everything, like we're not gonna miss a thing. And today we'll be here all day long, and we'll be all week long with you guys.
Yeah, we're gonna have special guests.
Special guest is gonna be really, really awesome, right?
Yeah, and we have to thank our sponsors for
Yes.
making this happening. And we are very proud to be here. We have amazing competitors, and we are so excited,
So
for
excited.
everything. Let's see an overview of the event.
Yes, let's see it. So now I'm here with the representative of humanoid adult that we are going to see right now. So please present yourself. Like what is your name, and tell me more about the league itself, please.
So hello everyone, good morning. My name is Satoshi. I'm from with Android's team. I compete in the major league, the soccer major league. I'm actually from the kid-sized humanoid league, but today I'm going to present you about the adult-sized humanoid league.
Oh, that's awesome. That's awesome. So in seconds we are going to see it. Just right now, we are watching it. So, can you please tell me more about the rules of this competition and how are the robots of it?
All right. So, as I said, this is the soccer major league, more specifically the humanoid one, which is subdivided into 2 categories. This one that we're seeing is the adult side, which has like big, taller robots, the rules actually say that they must have like from 1 to 2 meters of height. So yeah, they can get pretty big.
Pretty big.
As you can see, we have 3 players playing for each side of the camp. Right now, those are the first matches, so we're not exactly seeing one team against each other. It's more like all teams against each other. Each side is composed of 2 teams actually right now.
Oh, that's awesome. And I want you to answer me. What is the main challenges of it? Like, it's more a hardware challenge, it's more a software. I mean, we see they programming and they adjust. And what do you think it's more difficult to, and what you need to do to win the game?
Oh wow. It's hard to say whether if it's the software or the hardware which is the toughest part. I'd say maybe both. Yeah, both have its own challenges, and both are definitely really hard, especially for the humanoid ones because we have to meet like lots of criteria. The humanoid, as its own name says, must simulate the way a human would play soccer. So, for example, the height. There are height restrictions, there are limb size restrictions, there are mass restrictions, that are, well, even camera placement positions because humans have eyes on their heads and so the
Yeah.
robots must have.
Oh, so the robot can like see the ball just like us humans see. How can you explain me how this works?
Oh yeah. Oh, so mainly there's a camera attached to the robot's
Oh,
head.
nice.
And with the image that the robot captures, most teams probably use like a neural network, artificial intelligence,
Artificial
to translate that
intelligence.
image into information. They usually see specific points of the camp, and with that they
They do a mapping, right, of the the field.
that's right. And with that information, they can choose what to do, when to follow the ball, where to go, and stuff like that.
This is awesome, and they do this autonomously, right?
Yes. The rules say that they have
To
be
be.
autonomous. Yeah.
Oh, that's very nice. So we can see that is a cable, right, in the red robot, but they are only when the ball is not running, you know.
Oh
Is
yeah,
that right?
that's right. Right now they're probably it's probably the halftime pause, so they're probably getting ready for the second set.
It's just like on soccer, we can see when we have this halftime, maybe the team is talking and
Oh, they're
we see
definitely-
this configuration, right?
Yeah, right.
That's really awesome. So in the field, we have how many robots? It's 3, 4. Do we have a goalkeeper? How this
Yes.
works? Because they are big and they are kind of slow a little bit because of this height. How this works?
Well, so about the number of robots on the field when playing, each side may have up to 3 robots at a time, and it's not a requirement, but each team can have a goalkeeper.
Nice.
But because in this case we have only 3 players playing, the best strategy probably is to make 3 alternated functions. So like sometimes they're attacking, sometimes they're defending, and wow.
Awesome. So, do you think? I mean, seeing these robots, they seem very similar to each other, but of course they have differences. But are all robots like that, or have you seen different robots and different hardwares? Can you explain more? About your experience in the league.
Okay. So in the adult size one, you can see that most of them are kind of similar, and well, that's most probably because, especially in the adult size one, the complexity is like quite high, and so because of all those specific criteria, they end up like looking similar, right? In the kid size one, you might see some more nuances, some more different ones, but because of the rules, they it always end up looking kinda like the same. I don't like to say the same
Yeah,
because
definitely not the same, but kind of similar.
Yeah.
And I want to know if you know the teams, how many teams are competing this year, and what team was the winner of last year competitions? Do you know something about that?
Oh yeah, right. So right now at the adult size, we have 5 teams competing. To be more
5 teams.
specific, like 3 teams from China, one from the United States, and one from Korea. Yeah. And well, about the winners, I'm from the kid size one,
All
so
right.
I know that talking about the kid size one, last year's winners were the CT Brains team from Japan, which unfortunately is not competing this year.
Oh, really? And I just heard that the team from China is very, very strong as well. So we are hope to see really, really nice things going on. And just for people who are watching from home, no, this is a game. Like the main objective is just like a game, just like a soccer game. Is that right?
Yeah, that's right. The objective is really similar to the actual soccer that humans play.
Right.
The goal is to to score the most goals, and if there's a tie, we go to penalties, which
Oh,
work
yeah.
just like the real soccer one.
That was about to ask you, like, how do penalties work, and how they mark them, like how the referees know when a robot do a penalty. How can we know that? I mean, what is a penalty in the soccer? Can you explain for us?
Oh yeah, sure.
Like in robot soccer, of course, like in the humanoid.
Oh right. So the penalties were quite similar to the real soccer ones. They happen when some faults, some mistakes are committed during the game, like yeah. And the most common cause of penalties is when, like, at the end of the game there's a tie, and so then each team has up to 5 shots to the goal, just like real soccer.
Really?
And, yeah.
That's awesome. That's awesome. And I saw like some robots going in the same direction, like going to meet each other. And this is a fault. I mean, what can configure it as a fault?
Oh yeah, right. So in this case, when you see like two robots from opposite teams colliding,
Yeah, colliding.
that's actually no, I wouldn't say a fault. It's actually quite common actually to for that to
Really?
happen. Yeah, robots usually fall all the time, but in the adult size specifically, this year there has been a change in the rules. So now humans can't be on the field when the game's happening. Last year it was possible. And so this year they're a little more cautious about fallings and collisions with robots because they're really, really expensive and we don't want any damages that, wow.
Yeah, yeah.
That is
So,
terrible.
this, of course, and we just had a little technical pause, and this is very normal, right? Because, as you said, they are big robots. They are really, it's very, very hard to manage all that. So now the game is going, right?
Right.
The game is going, so we have 4 robots in the field, or 5.
Oh, so we can see like 5 robots, 3 from the blue team and other 2 in the red team. And as you can notice, the red team robots are different because,
Yes.
as I said, those first rounds we have like every team competing against every team. More specifically, 2 teams in each side of the camp. So probably one robot is from one team and one is from another.
Oh, that's really fun, you know. But can you explain me a little bit more about it? Like, they are on the same team, but can you explain me more? Just this part. Like, I have 2 robots with the red. They are from the same team or not? How this works?
Oh well, so this is just happening because this is the first day of
The
the
first,
competition. Those are the
yes.
first rounds. So it's like those are the games that will how can I say? Probably the next days are gonna be like eliminatory ones. Then it's gonna be one team against each other. But those first days are to like select which team is going to compete against each other on the next
okay.
days.
Okay, I got it. Very, very interesting, like how things works. And as we can see, we had a fall. Unfortunately, yes, we had a fall, but I think everything is alright.
Oh yeah,
Maybe a substitution, right?
yeah. This is called a pickup.
Oh, a pickup.
Yeah, when a robot falls down and it's incapable of getting up, like it gets stuck on a fence or maybe something happened just for any reason, the team from the robots that fell down may call a pickup, which is like they call someone from the team called a handler, and this handler can go into the field and take the robot back.
All right. So I see that the robots are outside the field. This is a rule, like, and we have a time counting just for like the robot falls. So 30 seconds, you need to pick up the robot. Do you have something like that in the rules?
Not exactly a time limit, but when you call a pickup, you gotta pick your robot as soon as possible.
All right.
Yeah. And you said that though you were standing outside of the camp, right? And
Yes.
yeah. That's because both robots were probably picked up, and when they re-enter the game, they must start from one of the sides outside of the line of the field.
Oh, that's awesome. So when they do a pickup, so you pick up the robot and you need to go outside the field in the
Yes,
yes,
that's right.
you know, I'm so sorry. English. So this is a sidekick, right?
Yes.
Like, oh, we are seeing. This is awesome. Like, and this ball. This ball, it's a heavy ball, it's a light ball. What is the size of the ball? I mean, I think it's really big. Looks like the real ball we see in soccer, you know?
Yeah, that's right. The adult size, they play with the size of the ball is the same one as the real soccer ones.
Yeah, definitely. And I would like to know about the event itself. I mean, you're probably here these 2 days that we have to the computer. So, what are your expectations, and what do you think about the event right now? Like, what are your feeling about the event?
Oh well, this is actually the first time that I take part in RoboCup.
Really?
Yeah,
That's
that's right.
awesome.
So far it's been like a great experience. There's been like just 2 days,
2
but
days, yeah.
being able to like see teams from all around the world working towards similar objectives, how can I say, developing similar.
Technologies and trying to. They have the same goal, right?
Yeah, that's right. That's right. And it's really awesome to see how how things are going with everyone, all teams around the world, you know?
Yes.
Yeah, but to be honest, well, as I said, as a competing member, the last days have been really tough.
Really tough.
Yeah.
I can imagine. I mean, here we have a lot of people from all around the world, so it's very funny because you don't know what is the language that the person will talk to you. So you're like, good morning, bom dia. Hola. So it's very funny. And I really think people are very excited. We can see that we have a lot of people here watching, right?
Yeah.
This is very some, and today was the first opening day for visitants. So that's why we have a lot of people watching. So we have a lot of kids from school watching it. So, but the event itself started 2 days ago. Can you explain for me, like, what the team were doing 2 days ago when the event started?
Okay. Those last days were what we call like a warm up, and
Right.
well, during those days we like fine-tune a robot, so we seek for little bugs and try to correct them. We try to fix little mistakes and maybe finish developing some features for the robot. But mostly those are final adjustments for the beginning of the games, right?
Right. So today is the big day, right?
Yeah, today is the beginning of
Today is the beginning of amazing competition, and we have a lot of things going on. Like we have humanoid that we are seeing, we have flying robots, we have a lot of things, and this is awesome. And probably now we are going to see the flying robots, and I thank you so much for participating. And that's it. You are a competitor, right? But in the humanoid adult or in other league?
No. I'm actually a competitor from the kid-sized.
Kid size.
Yeah, which is also a humanoid soccer one, but with robots of smaller height.
Oh, okay. So thank you so much for your participation, and it was awesome talking to you and watching this game with you. Okay.
Oh, thank you.
Thank you so much. So now we are seeing the humanoid, and now we are going to see flying robots. This is a competition that started in Brazil, beginning in Brazil, and I already have someone to talk a little bit more about the league and the competition itself. And we are just adjusting technical adjustments. And the flying robots, basically, we have a lot of drones, and it's very, very difficult to manage it, and you will know and you will understand. So in a few minutes we are going to see flying robots. We're just setting everything up.
Hi guys. Hi guys, we're back with Thiago. He's the chair of Flying Robots Demo. Firstly, Thiago, can you present yourself?
Hello, my name is Thiago. I'm a professor of robotics from Universidade Federal do Paraíba. I work with robotics for more than 15 years, 20 years. I started first with ground robots. My PhD actually used one of the RoboCup robots, the middle-sized league robots. But later in my career, I started to research on drones, flying vehicles, and that's it. I've been working with them since 2018, sort of.
Great. So flying robots, it's such a great thing because it's a new category. It's a demo. And what does it mean to be a demo in RoboCup?
So the competition to become a real league, we need first to start as a demo. So in a couple of years, probably 2-3 years, after doing a demo in several countries, we start as an official league. Because the demo league is to see if this league will actually gather people trying to solve the challenges that are within the league. So that's why this is the first year that we are doing in the International RoboCup this demo. We are trying to push it to see if we can do this demo as well in next year in South Korea. So let's see how things go.
Yeah, so great. Can you explain a bit more of how flying robots work?
So we have 4 phases, one each day. So today we are doing the first phase. This year, as the first demo in the International World Cup, we only had 4 teams, 3 Brazilian teams, 1 Australia team. Now, one of the Brazilian teams is setting up in the judge table to try to do some tests for the first phase. So what happens is that in the first phase, the drones, they must take off from the coast base, which is in the corner in the background of the image that you can see, must do a surveillance around the arena, try to identify all possible landing bases. These landing bases are these blue squares with yellow crosses and circles. So we have a total of 6 bases. There is one on top of the confined space in the background. You cannot see the 6th base, but you can see the 2 suspended bases and 3 on the floor. So the drone has to visually notice where each one of them are. After noticing, it must choose the order which it will visit, and by visiting the landing base, we are actually saying that the drone must land and take off from each base. All landing pads must be within the square. It cannot like land 3 landing pads inside and 1 outside. That's why we have actually the suspended landing base. All of them are mobile, so before trying, they are mixed, and they actually don't know where they are. That's why the drone has to go the surveillance and identify visually where they are.
So we don't have a standard platform, as it's not the same. The place where the drones, that the size of it, the arena, you know?
Yeah, the size of it is. It's 1 by 1 meter. The suspended bases can be either 1 meter high, like these 2, but the top of the confined space is 1.5 meters high. So I can put one of the landing bases that are on the ground on top of the confined space, which actually there is one there. But this is not previously known. Otherwise, people would just code the position on the drone. This is unknown a priori, and the drone must actually fly and identify visually where each base is. And by that, how do we know it, identify it? By visiting or landing in each base and taking off from each base.
Got it. And there's a person inside it. What's this person doing there?
Okay, we allow for 1 person of each team to go inside, place the drone, turn it on, disarm it actually, because there is a switch, a safety button to arm or disarm it. It means that when you arm the drone will be allowed to move its propellers. This is a safety measure because you have to disarm it to touch the drone, otherwise it's unsafe. Another thing is all the persons that go inside must use EPI, protection equipment, IPE, individual protection equipment, which means a helmet, goggles. You have to use a shirt that covers your skin to avoid accidents. Because, for example, these bigger drones that you saw them placing, they have carbon fiber propellers. And this can cut fingers, you know, so it's kind of dangerous. So.
Got it. Tell us more about the drones. Are they the same? How they work?
The only restrictions that we have is the size and the weight of the drones. So they can be either bigger drones, like at maximum 50 centimeters, half a meters between propellers. It's a standard, we call X500, actually it's 500 millimeters. And these drones can be used in phase 1 and phase 2. We have another type of drones. The restrictions for phase 3 and 4, they must be smaller, maximum 0.33 meters or 330 millimeters long to do phase 3 and 4. On phase 2, which uses the same bigger drone, they must take off from. There will be 3 landing bases on top of the confined space with packages. Kind of small gray package, the same one that we use to carry batteries, for example. The drone must take off from the coastal base, surveillance the terrain to find 3 landing bases where they are. It must return to get each package and deliver on the correspondent delivery place. So this is visually identifying. Then do a travel salesman problem to see where it must go first. Then pick up, land, pick up with a claw the package, take off, land in the other one, deliver, take off, go to the second one, land, pick up the package, and so on and so forth until the third one. So this requires much more precision landing. This requires a well mechatronic design of the claw. So this is a much bigger problem.
Talking about it, what happens if the drone falls?
Well, it depends. So imagine that on phase 1, you get like 20 points for each base landed. It means this 120 points. If the drones goes back autonomously, it doubles the points. So it means 240. So imagine that the drone comes, lands on not 6 but 3 bases and crashes. 3 bases means 60 points. So, but he crashes, so he doesn't go back. So he gets these 60 points. He doesn't lose the 60 points. He just don't finish the other ones and doesn't double it. So the bigger the challenge, the worse it gets. In this competition, we can use either standard drones like DJI or Tello, that's closed manufacturer, or each team can build their own drones. So it's open. You just need to follow the requirements. So some of the teams have manufactured drones like DJI or Tello. On phase 3, this is more common because it's a human-robot interaction. The operator must do gestures to control the drones to land in the bases, and the phase 4, it must go through the confined space. And to go through the confined space, it must be small. So.
This year, what do we have? What changes do we have?
This year, okay. So let me go back a little bit, talking about history of this competition. This competition in Brazil started in 2018. 2018 was the first demo, the Brazilian demo. We only have an arena, one team. In 2019, the competition started officially in Brazil. It was still called a demo, but later on became a real league in Brazil. So from 2019, we had the first competition. 20 and 21, with the pandemic, went to virtual competition. But since 2019, we had like several teams, like 8 to 10. In 2022, came back person in São Paulo, but the construction wasn't ideal. But even though we had like 8 teams, in 2023 was the first real competition, was here in Salvador. We had like 18 teams applying, only 11 were able to compete. Several teams could fly already because the technology here was already matured. Last year in Goiânia, we had much more teams using open hardware, building their own drones and flying their own drones. They were much better flying. So from last year to this year, what we changed was to make phase 1 a little bit harder, because the suspended bases were not mobile. They were fixed. Now they are mobile, movable. Phase 2 we had like 5 packages with April tags. We just put 3, but we don't have April tags anymore. So this kind of changes a little bit. Phase 3, the human-robot interaction is the same. And there was a phase 4 for barcode identification. We take it off because some of the teams were already identifying was only a vision problem, not a robotics problem. So we changed that for the confined space. So in this World Cup, this confined space is the first year that we have this. And this phase will also be in the Nationals of Brazil in the end of the year.
It's gonna be amazing, I'm sure. Let me ask you, the rules, you talked about the rules. Do you have any handbook? Does it change a lot or only once a year?
Only once a year. We have a rule book in Portuguese and in English. So even in Brazil, people from abroad can participate. We can receive teams from abroad. We have the rules in English as well. Actually, this is an invitation. If you want to come to Brazil, the competition on Brazilian Open is going to be in November, but the registrations are already open. Of course, the fee is not the same. It's in Brazilian real, so it's a little bit cheaper. But we are open to receive international teams as well. Usually we have like 23 people from teams from Brazil applying, but only 12 are selected. Due to the space, for one arena we can only handle like 11, 12 teams. And we won't do another arena because it takes too much space, you know, the arena. And that's it.
Why nothing is happening there right now?
Yeah, so as I said, this year is the first year that we have a demo in World Cup. So for example, the 3 best teams in Brazil, they didn't come for competing this year. So it's normal that when you don't have a very good team, they often have problems with localization, with flying, with the drones itself. So what happens is probably the team got some malfunctions yesterday on the warm-up. They could not fly. So you see the drone there, the drone is there. So they are probably trying to solve some issue on communication, on indoor localization, that appears when they just turn on. Look, I'm not able to command a drone, so they try to investigate. So they have 30 minutes to do 3 attempts. But if they want to test it, from the 30 minutes, they want to test the drone during 20 minutes, and 10 minutes they use for the only one tentative, they can do that. So during the half an hour, they can test whatever they want, or they can use the slot not to compete, just to test it. So it's hard to see. It's not a very dynamic competition like soccer, you know. It's more slower. People takes a lot of tests because this is hard. This is not easy. Like soccer robots are really standard nowadays, but especially the ones that has wheels, not the humanoids. But this competition is really state of the art. It's really hard to do it, and it takes a lot of issues to solve in order to put the drone to fly.
What are the expectations for this year?
The expectations in not a short term is it's like that, but in couple of years we're going to see a lot of people flying and doing some really nice stuff. But the idea is that every time that you see that a phase becomes easy, we kind of pushes to become harder. Yeah. So because that's the fun, not much to see the drone fly, but to see people overcome challenges, you know. So last year was we always have this, for example, this phase 2 of package delivery. Nobody succeeded to get the package, only to identify the package. Last year was the first time one team, mine, succeeded, but we only succeeded to get one package and deliver one package to see how hard it is, you know. So that's the fun of the stuff, you know, overcome the challenge. So it took like 2 years to overcome on the third year the challenge.
So, who are these guys who are making it happen? Who are the teams who are having all this trouble?
So we have a team from here, from Bahia. We have a team from Mato Grosso do Sul. And now there is a team from Goiás that's participating. I believe it's from your group.
Yeah, our state.
They are there, the Pequi Mechanic. And we have also an international team from Australia. The Australian team is the first time they are competing in this league, so usually the first year of a team is troublesome. They come to learn, they come to test, they come to see other teams. But for the first time that they're participating, they have a really nice drone. They just need to tune their code, per se, you know.
Great. How are the schedule for the rest of the week?
So the schedule is we have only 4 teams. We are doing only on the morning. So this morning is phase 1, tomorrow morning phase 2, Saturday morning phase 3. But on phase 4, from all 4 teams, we only have 2 participating. The other 2 said they don't have drones to do it. So we moved that to Saturday, the end of the evening, the end of the afternoon. So like 6 o'clock on Friday, we have the phase 4, and then we finish the competition.
Great. Hope we get there well. And how this technology affects our society? How can we make this useful? How can we use this?
So what happens is that phase 1, sometimes you have to land in difficult places, and you have to identify, the drone has to identify by itself the place to land, not always giving the coordinates, but he has to find itself, especially when he loses communication. So the phase 1 is for that. Phase 2, there are some companies that does package delivery, but they get the package manually. So there is a human that goes there, put the package on the drone, and the drone goes and deploy it, and takes it off manually as well. The idea is to do this autonomously. Getting the package and delivering the package, no human, you know. Phase 4 is just to emulate the same behaviors that we have. For example, when you're traveling by plane, there is a human trying to taxi the airplane, right? So the idea is to do the same with drones, creating artificial intelligence and vision algorithms to help visually command the drone, especially to land and to taxi it. And phase 4, actually there are some companies, but the drones are teleoperated to do monitoring of confined space, especially in industry or mining places where you don't have GPS, where it's dark, where there's a lot of dust, or in disaster, like we have a house that was crashed and you have confined space. You cannot put humans there, so you use drones. And sometimes the drones loses communication, so to allow it to be autonomous on confined spaces is a really nice challenge.
Yeah, it's gonna be such an amazing thing for society, right? I really want to thank you, Thiago. We came to the end of the interview. You want to invite people?
Yes, please. Please come to see these during these mornings, all the phases, okay? As I said, it's not as dynamic as the soccer, but it's nice to see people try to overcome the challenge. And if you want to come to Brazil, please come on November on the Brazilian Open competition. You're going to see some things really nice.
Thank you, guys. Now we're going to be with our sponsors. See you soon.
Toda ideia nasce pequena, em uma sala silenciosa, num papel rabiscado, num sonho entre colegas. Assim nasceu o CEIA, não como estrutura, mas como desejo. Desejo de transformar ideias em impacto, ciência em solução, tecnologia em futuro. Em 5 anos, fomos muito além do que imaginamos. Criamos tecnologias, formamos talentos, aproximamos empresas e universidades. O futuro já começou. Ele está nas ideias que ainda nem surgiram, nas conexões que ainda vão acontecer, nos desafios que estamos prontos para resolver. E se o passado nos trouxe até aqui, é porque nunca estivemos sozinhos. E o que vem pela frente? Mais ciência, mais impacto, mais gente. CEIA, 5 anos de inteligência que transforma.
Agora, funcionou. Ok. Tem
A Petrobras é líder na transição energética justa.
Porque a nossa energia já nasceu para abastecer o país.
Uma transição energética justa tem que criar oportunidades para que todos se desenvolvam.
Justa para o meu corre.
E abraçar novas formas de energia?
Também a transição energética justa. Ela tem que ser justa para todos.
Justa para cada brasileiro.
Justa para você.
Petrobras. O Brasil é a nossa energia.
Welcome back. We're here with Timothy. Can you present yourself to us?
Yes, hello. I am Dr. Timothy Wiley. I am from RMIT University in Melbourne, Australia, and I'm also one of the executives for the Soccer Standard Platform League, also known as the Soccer SPL.
Right. Can you tell us more about your league?
Yes, so in our league, every team has exactly the same robot. This year we are using the Aldebaran Now V6, or version 6 of this platform. The competition in our league is a software-based one. Every team has the same robot, and it's all who can write the best software to play soccer without any human interaction. So, of course, this being RoboCup, all of the teams, it's an entirely autonomous competition. It's all about the AI, the capacity of our robots to play soccer. So yes, there's absolutely no human interaction involved. Well, the only human interaction is the referee.
Great. And the competition is happening right now? When did it start?
Our league started, of course, RoboCup started back in 1996.
I'm talking about the competition today.
Yes. So this league started around 2009, 2010 with the first version of the Aldebaran humanoid robot that you can see here. So we've been running this league now since then until this year, and we are looking to see what the future brings.
Great. The competition is happening right now. Can you tell us what's happening there?
Yes, so at the moment the teams are preparing to commence the game. So they'll be doing their final tests, doing final calibrations. So we can see one of the teams here, they'll have a number of robots positioned on the field, probably looking for the lines, probably looking at the lighting of what's going on, probably looking at how they can see, making sure the robots are in the right position before the start of the game.
Great. And how many time do they have to do it?
Well, there'll be a fixed time where this game's going to be commencing. So this is... okay, so we'll probably see this game commencing in maybe 10-15 minutes or so from now, because the way that our league works is we run 2 games at a time. So we have one team playing on one field, and it looks like we can actually see them in the background of the screenshot at the moment. They play their first half. Each half goes for 10 minutes. Then we'll be swapping to this field, and we'll be seeing a 10-minute half on this field, and they'll take a 10-minute half-time break, play the other one, and come back here.
And we have many of these competitions happening at the same time. Is that right?
Yes, so we have 12 teams in our competition for this year. We have 5 fields, so the one that you can see down here, and if you're live on site, we've even actually got a field outside in the public area, because we like to play with natural light. So we want to... The whole point of RoboCup, as I'm sure you've heard many times, is that by the mid-20th century, a team of humanoid robots will play the FIFA World Champions. So to move towards this, every league wants to advance each year to improve the soccer gameplay and improve the capability of the robots. We have a purely software league, so we change our rule set to make it harder and harder every year. About 5 or 6 years ago, we introduced an outdoor field. So you can see the indoor field at the moment. It's inside the convention centre with all fluorescent lighting. But we also have an outdoor field where it's out in the bright sun with light coming into it, like you would have in a human, I won't say real, this is real soccer, but in a human soccer competition.
The grass, is it real grass, or synthetic? And is the field the same size?
We play on synthetic AstroTurf, so it's about 6 millimeters long. This is what you can see on the field here. It's a bit easier for the robots to work. So the robots, they're very capable, right? You'll see them in a bit, see them running around, but they're not as good as humans. yet. Some leagues are working on this. So we play on AstroTurf. It's a little bit safer for the robots to walk on, a little bit more consistent for the robots to walk on, but all of our fields are the same. So the field dimensions are about 6 meters wide by 10 meters long, approximately. And all of the fields are exactly the same size because it's a standard platform. The field markings are similar to what you will see in human soccer. A few things are a little bit different, of course. We also have our goals that are a little bit constructed a little bit differently to you might see from a human soccer. But many of the rules that you will see when the game gets underway have a lot of similarities to human soccer.
Got it. Where are the teams from?
So our 12 teams for this year are from around the world. We have a number of teams from Europe, some German teams. We've got a team from Ireland. We have 2 teams from Australia. I lead one of them. We have another team from from UNSW in Sydney. We have a couple of US teams. Unfortunately, some of the local teams weren't able to join us this year, and we can now see we're starting to see the game get underway.
Great.
So these 2 teams, the team in red are the reigning champions. They are Be Human from Germany, and they have won the competition consecutively since, I think, 2017, with the exception of COVID. The team in green is RoboCup from Ireland. And the game is just underway. So,
Oh my god. Do you get nervous?
do I get when I watch my team play? Absolutely. It's like it is real sport. So a lot of similar things that you'll see in human soccer. So you've got to have 2 robots touch the ball before you're allowed to score. So we saw RoboCup in green kick the ball backwards to their team member so that they could meet this rule, right? You've got to coordinate with all of the robots. And we see the team in red, which is Be Human. They're very, very good. As I said, they've won the last since about 2017. And there's a lot of coordinated play. So hopefully this will be a really close game, really interesting game. At the moment, so the red team is running towards the right-hand side of the screen. The green team is running towards... Well, I got to remember how this is flipped on.
I'm getting
this live
nervous
stream.
already with this competition.
Yes.
The only way are the goals, the points that they make, or do you have another way to?
No, so much
count
like human soccer, most goals wins.
Oh my god! And what's the regular amount of goals?
It can depend on the game. So much like in human soccer, you've got some stronger teams, you've got some weaker teams. So my team played about half an hour ago. We had a 0-0 draw. So 20 minutes of soccer, much like humans, very close back and forth, 0-0 draw. Some will win 1-0. Sometimes you might get a little bit of a large goal difference, so a 6-0, a 7-0. It can depend on the year and depend on the quality of the team.
Got it. So if a robot breaks, how does the team proceed to recover or to get another robot?
So the couple of things we just saw. So if the robots fall over, they have to get back up by themselves. The only human interaction is the referee. And you can see one of the referees in the black and white shirt in the background there. That's the only interaction allowed. In fact, this year, we introduced a rule where if there's a penalty, a foul, or there's a free kick, you have to look at the referee to see who's got the free kick. So that's the human interaction. But otherwise, if the robots fall down, they've got to get back up by themselves. And we're not allowed to interact with them. If a robot breaks, so it's something goes wrong with the hardware, then they're allowed to be removed from the field, and we have a substitute robot. So much like human soccer, we've got subs.
Yeah. Does the game... Who's playing?
So to recap, the red team is the reigning world champions in our league from Be Human in Germany. The green team are from RoboCup in Ireland, who won Division 2 of our league a couple of years ago, and have so that they have some quite. So now we see that's a deliberate pass. So you have to be able to pass in our game, and So, Be Human in red just scored, and so we'll now go to a kickoff. So, it looks like
What's happening?
we have a timeout called. So I can't quite see the scoreboard at the moment. You can see it in the background. We have a little bit of a scoreboard that tells us what's happening in the game and that the participants around the field can see, all of the spectators can see. I think we're going into a timeout. So each team has one timeout per game. They can be, I think they're 10 minutes. So you're allowed to call that at any break or any pause in the gameplay. Maybe something's wrong with the robots, maybe something's a bit wrong with the software. Teams need to make a little bit of a change. So we'll be taking a bit of a break.
Oh my gosh. We're gonna see the next field now.
So we'll see what happens. I'm not down in the hall to see what the referees are going to decide. Maybe we'll start with this next, the ref might decide to start with this next game, or we'll resume the half. We'll have to wait and see. It's much like real sport, right? But,
my heart is not ready for this.
your heart's ready. Yeah.
I get nervous. I think I'm even more nervous with robots.
Well, that's fantastic. So one of our objectives here, right, we are research is a big deal for us, right? But this is also about showcasing what we can do with AI, what we can do with our technology. So it's great to see so many kids in the auditoriums here, so many people walking around. Our league has one of the best humanoid soccer play. We play 7v7 robots, so 7 robots on each team from... I'll start that again. 7 robots from each team on the field, 14 total robots in total. So we've got a lot of... It looks a lot like human soccer. It is very exciting. The games between the top teams are always really intense, so you're right to be cheering. I should ask you who you're cheering for.
I'm presenting this. I cannot have
You're
a team.
completely impartial, yes.
Impartial. I have no opinions, right? We can talk later.
If there was a Brazilian team, though.
Oh, I will be cheering for them. I'm sorry.
Absolutely.
I'm so Brazilian.
Well, there's no Australian teams playing at the moment, so otherwise you'd be seeing me be very excited towards them. No, it's great to be. We're so pleased to be able to showcase this, and have so many people come down and be excited by our games. So send all the kids down to the halls, have a look at the robots playing as they're going.
Yeah. What you're thinking? What you're about the event? Are you liking it?
So it's always a pleasure to come back. My first RoboCup was in 2010 when we held this in Singapore. So I've been involved for quite a long time, but every year you come back right around the world. It's always amazing. It's a great place to visit. So one of the team that I was involved in back in 2014, this makes me look old. I think it was João Pessoa. I'm not sure if I pronounced.
João Pessoa, yeah.
That's where it was last time. It was held in Brazil.
Yeah.
I came out here after the competition for a bit of a holiday. It was fantastic to see. So it's always very exciting to be back to Brazil, experience the culture, experience the venues. Of course, play very good soccer.
And what about Salvador? What you're thinking?
Fortunately, it's rained a little bit while I've been here, but. It's been very fantastic to walk around the beaches. I grew up in Sydney, Australia. I live 10 minutes from 3 beaches.
Oh.
So it's been fantastic to go out. I come from a family of sailors. It's been a fantastic city to go around. Great food.
Great people.
Lovely people to talk to. Yes,
okay.
yeah, very friendly. There's always so
Thank
many
you.
people have been very friendly. Yeah.
Oh.
It's been fantastic to come and visit.
Come back always.
But of course, we're here for the robots and here
Yeah.
for the soccer. And we're also here, so many of these teams are students. Right? So I'm a staff member, I'm a lecturer, but the vast majority of the competitors in the teams will be undergraduate, masters, or PhD students. And a lot of our teams use this as a means to teach our students what it's like to do real-world robotics. So there's a lot of learning that goes on, there's a lot of experience that's gained, a lot of valuable skills that the students develop in... It's very different to come and pitch your software, bless you, to pitch your software against another team. You've never competed against them before, well, you've not since the last year you were here, or a new team. That's very different to sitting in the lab, and doing some small scale tests. So this real world experience, this real world competition really shows you just where your software, just where your hardware development is at.
And the develops of the teams are usually close. They come the year they have. They usually get the same development, same level.
So every year the competition gets harder. So each year the teams that come back every year, you've got to adapt to the new rules. We're actually starting to see the next game get underway here. So we'll see what's happening in a moment. But every year the rules get harder and harder, so you've got to change your software, you've got to get better at what's happening. So this year we introduced a rule where you've got to look at the referee to see whose free kick it is. So the referee will put up a hand signal, or maybe I should do it so you can see it on camera. They'll put up a hand signal and you've got to see what the referee did and say, all right, you know whose free kick it is, so that you don't get penalised for kicking the ball incorrectly. We're about to see the referee start the game here. You'll see the referee put their two hands up in the air. That will tell the robots, here we go. Oh, one moment, here we go. That's telling the robots the game's underway. So we introduced that rule last year. So you can now see that the robots have seen the signal and they are walking into the field.
Who are these teams?
Ah, yes. So I'm trying to take a little bit of a close look from the jerseys. Give me one moment. I will just check our schedule so I don't get this wrong. My apologies. I've
No
live
problem.
live output being what it is.
Yeah.
I didn't quite remember. So we have two teams here. The team on the close end of the camera in the dark grey. This is SPQR from Italy, and the team in orange on the other side of the field is WizTech United from the US. And they're actually a combined team of two universities, Wisconsin University and Austin, Texas.
How do you decide which team is going against another?
So we play a Swiss system. We can see the robots getting back up again after they fell down. So we play a Swiss system league. All 12 teams are in the one league. You are ranked based upon your performance in the previous years, and then the results out of the first round will go into the Swiss tournament bracket for the second, third, and so on until we get to the finals.
Got it. What's happening there?
Oh, right, yes. So we've seen the kickoff in play. So you can see one of the robots is having a bit of a hard time. Hang on, hold on.
Ooh.
Ah! I clapped. So we've had a goal scored there from SPQR. And now they're going back to reset for the half. So once the goal's scored, ball kicks that you go to reset for kickoff again. So the ball gets back to the referee. All the robots have to walk back to their halves positions, much like you would with human soccer. You've got a goal. So this is 7v7, but sometimes teams don't always have all seven robots on the field at the same time. But you will have a goalkeeper. The goalkeeper is allowed to wear a different colour. Sometimes they do, sometimes they don't. So you can see at the moment the robots coming back down this end of the field, repositioning for kickoff. We do have a rule, much like human soccer, where if you are the receiver of the kickoff, you're not allowed to enter the centre circle until 15 seconds after the whistle's blown. Now, I'm not sure if they can hear this online, I'll have to be told, but the refs, you're about to see it, the ref will start the half with a whistle, so you've also got to listen to the whistle. So we're quite, we're not too far, we're getting close to the human soccer. You tell me, how close do you think this is to human soccer?
Oh, if I was playing soccer, they are like 100% better than me. But professional soccer, yeah.
We're got a bit to go.
Yeah.
Well, we've got 25-ish years to get there. And I'm sure that coming up on the stream you'll be seeing, so there are different sizes and different humanoid robot competitions. We have all the same platform and we're a smaller size. You'll be seeing coming up, no doubt, throughout the day, the Humanoid League with their kid-size and teen-size robots, so some of the ones that are getting close to the size of an adult. They can be quite exciting and quite interesting to watch.
Yeah, Timothy, I would like to ask you, what's the main challenge this year for the teams? What they are most worried about?
Well, clearly the main challenge is to play the best soccer. That's the same answer every year. So this year, the big challenges we have are in these new rules that we've introduced around the referee. So that's completely new for the teams this year. So that's a big challenge to learn how to do. These robots, and when I go and speak to many people, like yourself, Sophia, the computers in these robots have less processing power than your mobile phone. So they're very low-powered systems. The camera's much worse than in a standard smartphone. So it's like putting a webcam on a shaky platform with a slow, underpowered computer, and you have to do everything that a human would have to do to play soccer. So you've got to look for the ball, you've got to figure out where you are on the field, you've got to coordinate with your teammates, you've got to play soccer, goalkeepers will dive, all of this happening on a very low-powered system. So one of our biggest challenges is how do we do all of this very computationally efficiently?
And do the robots change throughout the years?
In our league, no. So we're a standard platform. That means every team has exactly the same robot, and we keep the same robot for a number of years. We've had the now V6 platform since 2017, 2018. So our Deborah who made this were updating it year on year. But in the future, we're expecting, we'll go to another platform as well as we're working closer towards the 2050 goal of RoboCup. So keep an eye on this league. In the future, you might start seeing us playing with some new generations of robots.
Great. And why did you choose the league, everybody choose this robot to be?
Why did we choose this platform? So many years ago, we put out a call asking for good quality humanoid robots, and Aldebaran, or SoftBank, who bought them out, and for a few years it was URG, many companies, have been very, very supportive to our team. They provide us a good a deal for participating in RoboCup, because we also promote this technology. We push these robots to their limits. We are doing stuff with these robots that no one else does. They walk, we get them to walk as fast as anybody else does. The vision is pushed to its limits. The getting up from falling down, we push the absolute edge of what these robots are capable of doing. And our Deborah and SoftBank have been very good over many years. Oh, we saw the robot dive! I think the robot, the goalie's dived, but the ball wasn't coming towards the goalie. But, sometimes robots make mistakes. So yes, I'll just finish my thought. They've been very good in updating the hardware for us and the software over many years, but we are getting to the limits of what these robots are capable of. So we'll be looking to change in the upcoming years.
Great.
So are you excited? How excited you are at the moment?
Really excited. It got really close. Like, it's the second time.
Yeah, so we saw the ball go all the way down to the WizTech end of the field, and then the goalie kicked it back. And so this is what the teams are like. Evenly matched teams that will be very back and forth. So this is a hard position. The ball was right up on the goal. I think they just scored. Yes. Well done.
Goal.
The ball's got to go all the way across the line. It's hard to tell from this angle.
And the robot has a limit to goal. Like, it can go really close from the platform there to make the goal.
Oh yeah. Well, I mean, you've got to walk. Yeah, you can. So the robots are allowed to go anywhere on the green carpet.
Oh.
Basically. If they try to walk off the green carpet, then they get removed for a penalty. But they're allowed to go anywhere on the surface of the green carpet. What we just saw there was a robot. We talked earlier about there being a hardware failure. Yeah. So one of the robots fell over and looked like it was a bit broken. So it's been taken off the field, and we can see one of the assistant referees putting a new substitute robot onto the side of the field, ready to come back in for the start of the next kickoff.
Great.
And we'll wait for the whistle. Oh, we hear the whistle. Well, the whistle's underway, and maybe the robots didn't quite hear it. It is very loud in the halls. Yeah. It can be a little hard to hear the whistle at times. Okay, sorry, go on.
Having people close is something new, or is something that happens because of the visual aspects, the sound. Is it like this every year?
It's like this every year. So this is part of the challenge, right? We want this to be like humans playing soccer, as close as we can, with these platforms like humans playing soccer in the real world. So do you play soccer? I should have asked this at the start. No,
not at all.
Well, I know many.
Not at all.
Sorry, neither do I. I play cricket, but I'm Australian, so go figure. However, like many people who play soccer, you play in an outdoor area. You don't get to control what that looks like. People stand on the side of the field all the time. That's part of the challenge. So we like having participants. We like seeing the crowd come in. We can see a few of the crowd in the background there in the yellow and white shirts. So we do put barriers up so they don't come onto the fields, but we're really keen to have people come and... what's happened? I think.
There.
I think the robot's getting stuck on the goalpost. This is a hard game, right? So another way to think of this, and you might want to try this when we next come up. Well, we'll see if there's a goal scored. But I'll teach you what it's like to try and play soccer as these robots are seeing. No! Or we might see a call. So there is a rule in that you're not allowed to push a robot over. So much like you're not allowed to slide tackle and that in human soccer, you're not allowed to push another robot over, and you can get a penalty foul. So we're very close there, I think, to seeing a penalty kick. But maybe the referee was nice. Looked like he got pushed from the back there. This might be close to a goal happening here now. It's a bit hard to see because the ball is being a bit obscured behind all the other robots, but there we go, another goal scored. So while they're maybe the wrong robot kicked it. Okay.
No.
So there we mentioned this before. We have a rule where you've got to coordinate with other robots. So for a goal to be scored, at least 2 robots from the same team have to play the ball. So walk up and properly kick and touch the ball. If you don't do that, the goal's not counted.
Oh, so sad.
Yeah.
If you have...
well, we want to encourage, much like humans, right? We want to encourage gameplay between the robots. So it looks like half-time. So that was the end of the first half of WizTech vs SBQR. So, while we're waiting for the next half to set back up, if maybe we can have ourselves on screen, I'll teach you what it's like for robots to play soccer.
We're coming to the end.
Oh, we're coming to... Never mind. Oh, well, never mind. Maybe next time. Maybe next time.
Love to have you here, Timothy.
Yes, thank you very much.
Thank you very much.
It's been a pleasure, and we'll talk again soon, I hope.
Yeah, cheering for you.
Thank you very much.
Now we're calling.
Toda ideia nasce pequena. Em uma sala silenciosa, num papel rabiscado, num sonho entre colegas. Assim nasceu o CEIA. Não como estrutura, mas como desejo. Desejo de transformar ideias em impacto, ciência em solução, tecnologia em futuro. Em 5 anos, fomos muito além do que imaginamos. Criamos tecnologias, formamos talentos, aproximamos empresas e universidades. O futuro já começou. Ele está nas ideias que ainda nem surgiram, nas conexões que ainda vão acontecer. nos desafios que estamos prontos para resolver. E se o passado nos trouxe até aqui, é porque nunca estivemos sozinhos. E o que vem pela frente? Mais ciência, mais impacto, mais gente. CEIA, 5 anos de inteligência que transforma.
Justa, nosso presente é uma energia justa pra cada um dos brasileiros. Justa, essa energia é a gente que faz. Justa, porque é bom pra todo mundo. Fazer melhor é fazer junto. A gente sempre pode fazer mais.
A transição energética justa é aquela que chega na vida de cada brasileiro, com menos emissões, com projetos sociais, ambientais e sempre pensando no desenvolvimento sustentável do país.
Justa, nosso presente é uma energia justa para o Brasil dos brasileiros. Justa, essa energia é a gente que faz.
A Petrobras é líder na transição energética justa. Justa para todos, justa para você.
Petrobras, o Brasil é a nossa energia.
Justa.
Guys, so we are back again, and now with the SSL League. So I'm here with João, and we are going to watch Small Size League together.
Yeah.
So, João, it's very nice to have you here to comment about the league with us. So please tell me more about yourself and your history in RoboCup.
Okay, so I've been participating in the SSL since 2017. I was actually a former participant with the Robo IMI team. It's a Brazilian team from Rio de
Awesome.
Janeiro, but they didn't come this year, unfortunately. Now I'm participating as a Robo team participant and also helping with the organization, local organization and technical committee. Now we have our match actually from Robo team
Really?
against the Zoom Leagues team from China. And our team is from the Federal University of Pernambuco, from the Informatics Center.
That's
from
awesome.
We have like 20, I think 10 or 12 people right now at the field preparing for the game. When I left the field, I was helping them, and they were like preparing everything for the game, for the match. I hope we do fine. I didn't see the last preparations. We were having like some issues yesterday, and we were trying to fix, but it's part of the competition, you know.
Yeah.
Every game we have like make more preparation, and every year try to make more stuff and to develop our team to get better. But sometimes some things go wrong, some
Just
things go
happens, right?
Yeah, it's part of the research of the learning process, and we make mistakes and we fix it during the competition, and it's part of the process, you know.
I think that's the magic of RoboCup, you know.
Yes.
Like we are doing everything. This started 2 days ago, right? So it was the
Warm-up.
test warm up.
Warm-up
Yes, that's
phase.
the warm up phase. So, as you say, you guys are always trying to improve the robots and the communication. So I would like you to explain for people who are watching a little bit about the league, like some basic rules and the size of the field. Once some people when they say small size league, they think they are really, really small and with the small field. Can you tell me more about the league, please?
Okay, so here in the RoboCup we have many leagues about different parts of robot soccer, you know, because the goal of the major goal of RoboCup is to have I think it's 2050.
Yes,
they want to
2050.
have like a humanoid team with autonomous robots to play against humans. But
And to win.
Yeah, and to win. Yes, winning is important too. But to achieve that, they have like many leagues to solve different parts of this challenge, you know. So we have like more humanoid leagues to develop humanoid robots. We just saw the game from the SPL where they have more standard humanoid robots where they can make some between developing a humanoid robot and also the strategy for these humanoid robots. And the small size league is focused on strategy and AI and fast pacing game. So we have a more dynamic match. But for that, we just try we have a more simplified robot. So it's a wheeled robot. We usually have 4 wheels on them. And the robots, they are not fully autonomous. They receive commands from an external computer. So we have a system called SSL Vision, where the SSL Vision has some cameras above the field. And these cameras are used to capture images from the field And using the SSL vision, we can estimate the positions of the robots, of the ball, the dimensions of the field. We configure everything. We make this whole setup before the match and the competition begins. And with this information, the computers from each team receives the positions of the robots, and their AI is supposed to process it and decision what the robots will do. So after that, we just press play and
Press
everything.
plays.
Yeah, and everything is automatic. And we also have an automatic referee. So
Really?
yeah. So
That's
there are
awesome.
some referees there just to assist. You can see these guys in green shirts, green jackets around the field. They are the referees, but they shouldn't. If everything goes right, they shouldn't help much. The automatic
yeah.
referee will do almost everything, and also the ball placement. I think they will begin in a few seconds, but the automatic referee will choose what is the next stage of the game, and the ball needs to be placed at the place the next stage will be played. So the robots also do that. They do the automatic ball placing, and I think we'll start now with the Zoom Leagues kickoff. So
It's so fast. Like I just saw the ball, you know. This must be very, very hard to do the software. But I'm really curious about the hardware because it looks very similar as well as we saw in some humanoid competitions. And I would like you to explain how this hardware made, you know.
Okay, so the hardware is open like for the teams to do whatever they want, but we just have some restrictions about the size of the robot. So they have to be up to 15 centimeters tall and 18 centimeters of diameter. They can't pass that. We have a check before the competition starts. The OCs check every robot from the teams. And this is, I think, it's the only restriction for them. But we have kind of a standard project. Not that everyone is equal, but we follow some. I mean, the SSL exists for I think more than 20 years. So teams have already found the best way to do it. You know. So.
Why you to try different?
Yeah, so we try to keep evolving the project using past knowledge from the other teams, you know.
Definitely.
So if you look at, they look very similar, the robots, but every robot is a bit different.
Yeah, every robot of each team is definitely unique.
Yeah.
And I want you to tell me, as a competitor and as a participant since 2017, right?
Yeah, 2017 was the first time.
How do you think that? How are you feeling about RoboCup 2025? Like, what are your expectations and what have you seen by now?
Yeah, so for me, to be honest, I didn't have much time to go around the RoboCup so far because I was working so hard. But
I got it.
Yeah, I will sure do it at some point. I probably after this game. But from the infrastructure, I've been liking it so much because I think at least for our league, we had like some things prepared in advance, you know, compared to other years, and everything's working fine. We have great illumination, great infrastructure, was a good setup. It was an easy setup for us. We didn't have much trouble. So it's been very good to us for this RoboCup. The team that helped us on the setup and the mounting phase for the fields and all the infrastructure was very good. And here the event center, I think it's a great place to make these kind of competitions.
Yes.
We have a good infrastructure, so especially for illumination, these robots are all these systems that use cameras and
are sensitive to illumination.
They're very sensitive to illumination. As you can see, in the place we are here, you can see there's the guys can't see it, but there's a field right here for the SPL. They have like a technical challenge for illumination. They will play here with natural illumination.
It's very, very hard, I guess.
It's really hard for them. So having good illumination is
It's the key.
yeah, it's very important for all the leagues, and we have this here, so it's great. It's been great for the competition so far.
And I want to know how is the vibe of the other competitors? Like, is that everyone is serious, everyone is worried, or people are nice and happy? I mean, how are you feeling this year?
Yeah, so here in RoboCup, I think people are very passionate about what they're doing, you know, and everyone like. As we are competitors, so we want to win. in the
Yeah,
end.
definitely.
But we help each other a lot, I think.
Oh, that's very nice.
If you go to other people's table and ask how they solved a specific problem, because we all have kind of the same problems, you know.
Yeah.
So if you go to other tables and try to talk to other people from other teams, even though they are competing against you, they will say, "Oh, we did this, we did that, we
We
searched
tried
this thing."
that.
Yeah. So we help each other a lot, and
That's
that's one of the magics of RoboCup. I think people are passionate, but they're still open to talk about everything they do, and yeah, give this information so that everyone can develop and evolve together. You know.
Yeah, I think this is what research and innovative is about. You know,
Yeah.
it's about talking to each other, passing information. So that's awesome. And now, I want you to explain a little bit what is happening right now in the game.
Okay, so I think our robot just placed the ball for some kind of free kick. So our robots from RoboCine are the ones using the white hue, the light hue, and the
right.
Zoom Leaks, the Chinese team, is the one using dark. So we can differentiate them with that. Actually, this is a new improvement of our league, because before, the way we usually differentiate the teams is with the yellow and blue colors. You can see like above the robot there are some
Yes.
colors. These colors are used to represent each robot and each team.
In the system?
Yeah, in the SSL Vision system.
Oh, nice.
But it's really hard for the audience to see those
To see.
colors.
Definitely.
So we decided to make teams use black and white, not black and white, but dark and light hools to protect the robot. So it's easier for the audience and also for the referees to differentiate the robots. So we can see now RoboCine, which is our team, has the white ones, and the Zoom Leaks has the black ones. So I think it's pretty better to differentiate.
Yeah.
It's the first match
Really?
I'm watching with this new implementation
New
from the
setup.
league. So I really like it.
Yeah, it's very nice to watch because you can see definitely there are two teams,
Yeah.
and you can differentiate very, very easily. And in competitions, normally we have the strongest teams, or the
Yeah.
teams that everyone is like, oh my god, they are awesome. I don't want to play with them, you know, just because they are too strong and too good at it. And of course, everyone that is in these competitions are very, very good at
Yeah.
it. But we have the strongest. And do you know? Can you tell me what, in your opinion, of course, are the strongest teams? Can be your team, okay?
Yeah.
You can tell me that.
So yeah, I think RoboCine is the best. But
Oh, okay.
unfortunately, we lost last year. We not lost. We got a good position. We got 4th place in the
that's
Div
nice.
A. But in our league, the Tigers Mannheim, which is a German team, they are the best team. They got 1st place in the past, I think, 4 or 5 years. They've been
5
winning.
years.
They've been winning since 2019, I think, or 2019.
They got history.
Yeah, they got history. But that's it. I mean, you gotta have time. It's a pretty hard project, and the other teams as well. I mean, a major difficulty we have in our leagues. I think in all leagues you have this difficulty, is that most of the students are undergraduate students.
Yes.
So when they graduate, they leave the
Leave.
team, and we kind of lose some of the knowledge in this process. Not all of it, but it's hard to maintain everything at the same performance for much years. I think Tigers has been doing this for evolving and maintaining the project for I think more than
Long
10 years
time.
because they're pretty good at it, and they're also maintaining some of their key members in the team, so they keep developing it and making it better and better. But yeah, this is part of the process as well. Our team is kind of new compared to them. We've been participating in this league only since 2019. So we've been trying to get there and step by step,
Yeah.
every year trying to get better.
To improve and do new things, right?
Yes.
Try to implement something new and
Yeah.
try to get them.
And this also that's also a part of the process when we talked about the teams talking about what they do and their solutions for the problems.
Yeah.
So we talk a lot with the Tigers guys about how they solved each problem. This other team that it's playing against us right now, this Unleash, they are Chinese, and they are also a team that's been participating for many years. They've won, I think, 3 or 4 times the competition.
Oh, that's very nice.
Yeah, they're very good as well. But as I said, they had I think in the 2 years before, they had this thing where most of their most experienced students leave the university, and they try.
That's hard.
They have new students, so they're still great. They got 2nd place last year. They won against us by 6-1.
Really?
Yeah, but
as you said, it's part of the process,
yeah,
right?
yeah, it's part of the process. We have to understand that and put our expectations at the wrong spot. Don't create unnecessary expectations. We just gotta keep going and improving at each year.
Yeah,
that's
definitely.
our main goal.
Yeah, and I think you guys have fun in the game as well. Of course it's too difficult. You spend a lot of hours trying to improve, nights and nights, wake up. But do you think how do you think you can manage it, the stress? I mean, I think being a competitor is very, very stressful.
Yeah,
but
sure.
I know that you have ways to try to relax. And how do you manage that stressful situations?
Yeah, it's really stressful participating in the competitions, especially when things go wrong.
Yes.
But yeah, I mean I think it's more experience, it's nowadays I don't do much I can talk for myself, but in this case I don't implement much things on the software, on the hardware. We leave it more for the undergraduate students, and we keep more a position of trying to leading them and orientating them. So me and there's another guy from our team, Lucas, we try to keep this position. Yeah, so we pay attention. Hey guys, we need to sleep because we need to we need to wake up early to come early. We try to organize them and keep them all this stress controlled, because we have more experience than the undergraduate students. We have more time participating in these competitions. So yeah, this is our responsibility in the team, and also we help solving problems as well, technical problems, but we mostly leave it for them, and we try to wants to go. We try to leave for them the hard work, and we just keep the organization. And I think this is to control the stress. I think this is important. You gotta have someone in the backstage
you can count on, right?
Yeah, you can count on, and that this person is keeping everything. These people are keeping everything organized and okay, what we're gonna do next? When we're gonna pause? When we're gonna lunch? Because if you don't talk to them, if I don't buy food for them, they keep working all day long.
Right.
Yeah, and that's not what we want.
Yeah, we want a healthy competitors, right?
So these people, they are working. I've been there, so I know it. Because they are working they are so concentrated in their work that they forget.
They forget to lunch, to sleep, to eat.
Yeah, so the most experienced part of the team, we try to keep them, just keep them on trail, like, okay, guys, let's eat right now,
That's
let's sleep,
it.
let's take a pause, and let's talk, let's stop. Okay, this gone wrong. This is not going to work. Stop this. Let's do other
Let's
stuff.
write,
Focus
yeah.
on other problem,
That's awesome.
I think this is there's not a solution,
Yeah,
but we can try to
definitely.
mitigate the stress
stress.
with this,
Yeah, this is very, very, very important because this should be, and this is, a good competition, an awesome event. And if you are stressed, you cannot live.
Yeah.
Yeah, you cannot participate, you cannot talk probably. So it's very, very important. And I want you to tell me, it's a doubt that I have, a question that I have. And in this game, we have penalties, we have faults, and
Yeah.
like the soccer we see on TV.
Yeah. So I mean, almost every rule we have in soccer we have here, like falls. Most we have falls for robot crashes. So if two robots crash in too high velocity, it's considered a fall. If the ball leaves the field, we have like leaving goal line. So the only difference is that I think the main difference is that all falls here become direct kicks. So sometimes,
Right.
you can directly kick to the goal, but you have like the soccer game. We have the ball leaving the field. We have crashes. We have penalty. In our game specifically, the penalties are shootouts. There are some kinds of soccer that use the shootout.
Yeah.
In our case, we use shootouts, where the ball gets placed 6 meters from the goal, and it's like a 1v1.
Yeah.
And but we only have 10 seconds to score. So you gotta be really fast and
my God.
decisive on what you're doing, on what you wanna do.
What strategy do you
yeah.
use, right?
Yeah, it's pretty hard to score a shootout, to be honest. But the shootout happens when we have like playoff stage and the match is tight, and we go to shootouts, or when we have the defensive team touches the ball inside the defense area, the goalkeeper area, because one rule that we have in the SSL is that only the goalkeeper is supposed to touch the ball inside the area.
Oh,
So
that's awesome.
you will see that defensive robots and attacking robots will not enter the goalkeeper
area.
Yeah, they can enter it, but if they touch the ball inside it, it's a major fall. So it's not good.
It's not good. We don't want that.
Yeah, so to not risk at all, we don't let our robots get inside
Get
the area.
inside. Okay.
Yeah, I think the game is going. It looks like a timeout or something right now.
So that's awesome. I want to thank you for participation. It was a really great talk, and I think everyone enjoyed. And that's it. Thank you for your participation.
Okay.
And now we are going to a small break. So we are going only 1 hour, and we will be back. I'm so sorry. At 1 p.m. here in Brazil.
Okay.
So thank you very much for participation. It was a very good talk.
Okay,
Thank you
thank
so
you.
much. See you in 1 hour. Bye bye.
Bye bye.
Hi everyone. Now let's get to know a little bit better about At Home League.
Hello.
So I'm here with Fagner Pimentel. Let's come in.
Welcome to the At Home Arena.
So Fagner, please tell me a little bit more about At Home League.
Well, this is one of the most interesting league in here in the competition because we have domestic robots. The robots should take a lot of tasks in this domestic area, so like take up the garbage, to out, make dishes, grab objects to the people. I think the most expectation of this competition is because we will have robots that's training here. For tomorrow, the robot will be in your house. So this is a very good thing.
Definitely. And tell me more about your expectations about the whole event.
Well, the whole event today is the first day, so the team are in the warm-up days. They are mapping the arena, take pictures of the objects to the robots, identify all the objects. In next days, we'll start all the tasks, and the final in the last day.
Okay, thank you so much for receiving us.
Hi guys, today I'm here with...
Hello, my name is Martin Löser, I'm from Germany, and I'm basically currently head ref of this league and also in the technical committee of this league. I'm part of the team SWAT from University of Applied Science in Würzburg-Schweinfurt. And the general concept of our league is basically that we have a transportation task from workstation A to workstation B. So basically all tasks contain that. And on top, you change the difficulty level. So you add, for example, obstacles that were not known before. You add parts that are not part of the normal part set, like as decoys. Or you add basically different backgrounds. So currently the arena is very white and there is not much color.
Yeah.
But for example, there can be like aluminium foil. And you have to detect the silver part on top of the aluminium foil. And that makes the difficulty levels then, and you just increase the level from competition task to competition task till the final.
Okay, and what are some expectations for you for the event?
Always a nice community, so hopefully it will be a nice community event again, and we all learn from each other and can help also each other to gather new knowledge, because it's a big part of this event, that we build a community and try to reach the current goals basically of the rule book, and also then in the future years can extend the rule books to new and more complex tasks, because hopefully at some point all the teams have solved the easier tasks. And yeah, we are currently, to be honest, world champions. So hopefully
Congratulations.
that it'll be again, but we will see.
Hi, could you present yourself to us?
Yes, my name is Thiago. I'm a professor of robotics in the Universidade Federal da Paraíba and also local chair and exec of this demo league, which already happens in Brazil for some years, but now is the first time we are doing a demo in RoboCup.
What are the biggest challenges of your league?
This league is for autonomous drones. They are not teleoperated. The pilots is just to ensure safety, but all the drones must localize themselves and fly autonomously to perform 4 different tasks. The first task is they have to land on all these bases autonomously, recognize them because they don't know where they are, and they have to land and take off from each one of them. The second one, they have to do a package transportation delivery. The third task, they should also land on the base, but now commanded by gestures of humans. There is a human operator from each team that's doing some gestures, and the drone should recognize those gestures and interpret that as a command. And the fourth one, they should go through this labyrinth. It's a confined space where they should enter from one side, leave the other side, recognizing some paper tags.
Seems way too much. And what are your expectations for this event?
We already have some years in the nationals, and the nationals teams are able to perform like 80% of the tasks. So it's kind of hard because this is state of the art. I don't know how these teams are going to perform because at least the Brazilian team, they are not the first places on the nationals, but let's see how they handle it. Let's hope that they can do a really good job this year.
Thank you so much, Thiago. Hi guys, we're here with
Trent.
Hi, Tran. Can you tell us what's your league?
So my league is the Humanoid League, which is the robots that we get to control the hardware. So we get to choose which parts go on and how they go together, and then we build our own robots so that they can compete in the competition. And specifically, we're limited to human-like sensors. So we can't put anything that a human wouldn't have, which, you know, has been fun from time to time when we can't put things like compasses on our robots and lasers, but the constraints make it very, very rewarding.
Seems way too complicated. What are your challenges in your league?
There's a lot of challenges that have cropped up in this league over time. One of which is that, especially recently, the pace of technology growth has been explosive, which has been really great for our league. But it also means that a lot of teams have to spend a lot of time, you know, learning new techniques and learning new things, which is really great, especially since most of the people who are in these competitions are students. So it's a great opportunity for them to learn. But yeah, the rate of technology growth has been explosive recently. So
It's amazing how things are really going way too fast. So what are your expectations for this event?
I'm actually really excited about this one because the first RoboCup I ever went to was actually the last time this was in Brazil, which I think was in 2013, a long time ago. So it's really interesting for me to see, coming back here to Brazil again, how much has changed in those last 12, 13 years, just how much the robots have changed and grown. You've got, back when those robots were playing all those years ago, the goalposts were yellow, there was just green carpet, so there wasn't grass. The soccer ball was just an orange ball as well. So, and then seeing that from the robots going on that environment all the way to now where they're playing on proper grass with proper goalposts, and many teams doing team play and walking, and it's just been really exciting to see the growth of the teams and growth of the league as a whole just over these last decade.
Amazing, thanks. Thank you for the interview. I wish you luck.
Thank you.
Hello. Can you tell me a little bit more about yourself? What's your name and what league are you responsible for?
Hey everybody, I'm Oscar and I'm currently in the Onstage League, which is a league that I used to participate in as well. And I'm very thankful to be back here and being judged in the competition this year, which is in Brazil.
Awesome. And can you tell us a little bit more about the league and what are the main challenges of it?
Yeah, of course. On stage, differently than the other junior category leagues, it doesn't provide you with any challenge besides elaborating a performance as long as you stay inside the stage. And staying inside, you can basically do anything, such as a theatrical piece or a robotic showcase. And by designing your performance, you come up with your own challenges and your own technical difficulties that you will try to solve it, which is the interesting part of Onstage.
Definitely. And can you tell me more about your expectations of the whole event?
Oh yes, I'm waiting to see a lot of innovations here this year, specifically because an international competition here in a big venue and also a lot of teams coming all around the world.
Hello everyone. So please tell me more about yourself. Tell me your name and what league do you represent?
Hi, I'm Tom. I'm from the executive committee, but I was working with the Rescue League, which we can see the fields over here. Yeah, working with this over the past few years and now overseeing more of the leagues.
Awesome. Can you tell me a little bit more about the leagues and what are the main challenges of it?
Sure. Over here we can see the fields for Rescue Line and Rescue Maze. These are two of the main parts of the Rescue Challenge. We also have Rescue Simulation, where we put the maze also in the computer in a simulated environment. Yeah, but over here the robots need to follow the line and then collect victims, which are like silver and black balls, and then put them to a safe spot. So this is like a disaster scenario. And over here in the maze, the robots need to orient themselves in the maze fully autonomously, find victims on the wall, and then drop them rescue kits so they can help themselves and can be rescued later.
Oh, perfect. And can you tell me a little bit more about your expectations of the event.
In this event, we'll have the best teams from all over the world coming together here in Salvador, Brazil. Competing for in the different leagues for the championship. And we're gonna see a lot of innovation, I believe, with the new challenges. We're evolving the rules every year and seeing the teams responding to that with new creative ideas.
Thank you so much.
Hi guys, today we're with
Daniel.
What you do, Daniel?
I'm in the TC of the Logistics League, and I'm also with Team Car Logistics from Germany.
So can you tell us a little bit more about your league?
Right, so the Logistics League is all about modeling a manufacturing scenario where robots build orders on demand. So it's a bit like this modern idea of mass customization, where we try to optimize the utilization of machines to produce lots of varieties of different products.
Cool. And what are some expectations for you from the event?
Well, I hope for a good competition and to see some nice fights, I guess. Nice battles.
Okay,
Yeah.
thank you.
Hello, I am Marco Simões. I am the General Chair of RoboCup 2025. We are here in the Salvador Convention Center preparing everything to start the competitions from July 17. We hope you to watch in our live stream and have lots of fun with the most amazing competitions of robotics and artificial intelligence.
Hello, I am Reinaldo Bianchi. I'm one of the general organizers of the RoboCup competition, and we invite you to watch the competition in streaming. We're going to have several games, humanoid robot games, soccer challenge, rescue challenges, domestic tasks for the robots to be doing, and it will all be streamed. We wait for you to watch our competition. Thank you.
Hello, please tell me more about yourself. What's your name and what league do you represent?
My name is Adam Jacoff. I am from the National Institute of Standards and Technology, and this is the RoboCup Rescue League.
Awesome. Can you tell me a little bit more about the league and what are the main challenges of it?
So, as the Rescue League, we're the ones on site that are working with emergency responders. So this is firefighters, police, anyone who's going into really hazardous situations and need to do so from a remote standoff. So the robots in our paddock, you'll notice, are very mobile, legged, wheels, tracks, independent flippers, manipulators, and we use all of these test lanes to make sure that their mobility is ready for the complex worlds of the emergency responders.
Awesome, awesome. And I mean, what are your expectations about the event itself?
So every year, our teams as a group have really improved the state of the science for robots in general. We see already some robots here, early arrivals, that are going to break new paradigms for us. And those are going to be the legged robots with wheels. You'll see their feet are wheels. And so they'll be doing climbing tasks like that one over there. Things that we haven't seen in the league ever before.
Awesome. Thank you very much.
Hi everyone, I'm here with
Amy Iguchi.
Nice to meet you. So can you tell us a little bit more about RMIC?
So RMLC is Rapidly Manufactured Robot Challenge. This is very new challenge if you look at the entire RoboCup. Actually, as a matter of fact, we did the first demo in the last competition in Brazil in 2014.
Okay.
Yeah. So those little fields, apparatus, is the challenge. And then those are all test methods that first responders actually use. So we're actually responding to the needs of the first responders. This is actually a real thing. It's part of the inter-rescue competition.
Okay.
But we have a smaller challenges, which is good enough for even high school students to start participating in the major rescue league. And this year we are using new test methods. So everything is not everything. Some of the methods are very new this year. So I'm expecting the teams to come up with very interesting, innovative challenge way of solving the challenges, and looking forward to see the solution.
The arenas are pretty amazing. Not gonna lie.
Yeah, it's very complicated. Yeah.
What are some expectations from you for the events?
All the robots are 3D printed, and then they actually design the robot, and depending on the test method that they want to actually solve. So it's not like everybody has to do all the challenges. So they can pick and choose which one the best one to get more points. They can choose remote operation, teleoperation, using the remote control, or autonomous mode. So very interesting to see which strategies the teams actually use to get the points.
Thank you so much.
Hello, please tell me a little bit more about yourself and what league do you represent?
Hi, I'm Will, and I'm the Junior Soccer Chair, so I manage both the Lightweight League and the Open League for the soccer divisions. The soccer divisions are a 2 versus 2 robotics competition where the teams will build their own 2 robots to verse another team's 2 robots, and we have a big tournament between all the different countries of the world, which is really awesome to see everyone come together for soccer. We have, again, 2 leagues, one being Lightweight League, where they use like an infrared ball, which is very easy to see for the robots using like little sensors like in your TV remotes. And Open League uses a orange ball that they use like cameras to detect. And we're slowly moving towards like a more realistic soccer game, using kind of eyes for the robots, and then drive motors to try and, play soccer like the big major leagues do.
Awesome. Can you tell me a little bit more? What are the main challenges of this league?
So some of the main challenges are obviously because it's a team versus another team, you're obviously battling it out for a soccer game, right? And so you're trying to always one-up each other in each competition. So every new year we see all these new technologies. So, year on year, we see all these new innovations trickle down to the teams. It's really cool seeing, high school students using crazy new technology that's just coming out.
And tell me more about your expectations of the event.
So I'm really keen to see what teams are coming out with now. We've got things like generative AI that is used for text-based applications, but also in AI, there's a lot of vision-based applications that we're starting to see a lot more teams use now. In addition, there's a lot more sensors coming onto the market, and a lot of the prices of a lot of edge computers coming down. So there's this really new kind of availability for so many different teams to afford all this crazy new technology, which is really shaking things up.
Thank you very much for your participation.
Hi guys, I'm Sophia, and today I'm here with
Gabriel.
Gabriel. What's the league that you represent here?
So here we have 2D simulation soccer. So it's a league about simulated soccer on multi-agent system. So the agents play soccer on a simulated server.
And what are the main challenges of your league?
So we don't have physical problems since the league is all simulated. So we need to focus even more on algorithms and how our strategy works. So we need to implement AI algorithms and enhance even more our strategies to make the team and the agents play even better.
Doesn't seem easy. And what are your expectations for this event?
So we have a lot of teams competing this year. So we have 10 teams. So with this competition, we expect that people can network themselves and also enhance even more their team codes, their source codes. So we have a evolution, a development of the league as the entire leagues seems to work. So we are expecting good relationships and everything else. Yeah,
it's gonna be huge. Thank you, Gabriel. Wish you luck, and we see you soon. Hi guys, we're here in RoboCup 2025 with
Alan.
He's from the league and the technical commission from the league.
Well, I'm from the 3D Simulation League,
And here we have humanoid robots, and they will have to play soccer, and which is kind of funny because in RoboCup, a lot of leagues will have to play soccer, and we use this kind of approach, so we are able to develop our technologies, and those technologies, they can be transferred to real life problems, so we can solve them in new ways.
Way too cool. Right. And what are the biggest challenges of your league?
Well, we imagine kind of a futuristic robot, so we don't have this kind of robots available here physically. We have robots that are more complex, they have more joints, and they resemble better the human body. So and our challenge here is they have to learn how to coordinate themselves, they have to learn new skills, they have to learn how to move in correct ways, and as they resemble the human body, they have more challenges than the other leagues that are the physical ones.
What are your expectations for this event?
My expectations are that we learn a lot, we share a lot of experiences here, and hopefully my team will win.
For sure. Thank you, Alan. We wish you the best.
Hello, please tell me more about you. What's your name and what league do you represent?
I am Emiel Steerneman. I'm from the Netherlands and I represent the small size league.
Oh, awesome. Can you tell me a little bit more about the league and what are the main challenges of it?
So we at the small size league compete with very small robots. We might actually see a few of them there on the table. And what we do is we have one central computer that controls all of these robots. And we have our fields here. There are cameras above the fields. The robots have color codes on top of them, and then the camera sees the robots. That goes towards the computer, and then the computer decides for all the robots on the field what to do.
Oh, that's awesome. And let me ask you, what are your main expectations of this event?
I am looking forward personally to lots of Brazilian food, definitely.
Yes.
And because now we're also very close to different leagues like Humanoid. I'm looking forward to those, see what they can do. And of course, just lots of fun and lots of interesting new things.
Thank you so much for your participation. Hello, tell me more about you. What's your name and what league do you represent?
My name is Dr. Timothy Wiley. I'm from Melbourne, Australia, and I am one of the 3 executives of the Soccer Standard Platform League.
Awesome. Can you tell me a little bit more about the league and what are the main challenges of it?
Sure. In the Standard Platform League for soccer, every team has the same robot, and we are using the Aldebaran Now version 6. The challenge of our league is software-based. We ask our teams to write the best soccer to play 5v5 or 7v7 soccer. And it is all about the teams who can write the best code. And these robots are fully autonomous, so there is no human interaction. They play soccer all by themselves.
Oh, awesome. And tell me more about your expectations of the event.
I have been attending RoboCup for about 15 years, so I'm very excited to be here and see what we can bring to Brazil. We're hoping to have a fantastic competition with our 12 teams, and we're looking to see some fantastic soccer, some very strong results, and enjoy ourselves while we are in this wonderful country.
Awesome. Thank you very much.
Thank you.
Hi guys, I'm Sophia. We're back here with Fagner. Hi Fagner.
Hello.
um, we're gonna see now the task, a video of the receptionist task. Let's see. It's a quick video.
So the person will stand in front of the robot. The robot need to ask him from its name and favorite drinks, and the person guide the robot guide the person to a place where the can take the drink and offer a seat to this person. After a moment, the robot will take another person to the party and ask again their name and the favorite drink. So the robot repeats the same process and offer a new seat to this person in the party. You ask again the favorite drink, the name, get the drink for this person, and offer a seat. And the robot needs to look to this person, needed to point in the correct way the seat in the sofa inside the arena, and then the task is completed. In this time, the person may change the seat, so the robot need to know where each one is in, and remember that, and look again.
That's it, guys. Hope you understood. Fagner, you have more than 10 years of experience, is that right?
Yeah. I'm starting this competition at home specifically in 2014. So yeah, it's 11 years about this competition. But I started in the RoboCup at 2010.
Whoa. And from 2014 to nowadays, what's the biggest change?
Well, we have a lot of changes in
Such a
this
difficult
time.
question.
Yeah, because we have a lot of tasks to the robot to resolve, and in 2014 was when the competition was here in Brazil. We had less complex tasks, something like RoboZoo. So the robots needed to talk to the people and get more attention possible to get a vote for the audience, and they win these tasks. but there is a lot of other tasks. Um, 2 years ago, we have 19 tasks in this competition, but was a lot of tasks. We
Couldn't
could
manage.
Yeah, we could manage this, but there is a great ones. And today we have only 8 tasks, and now we will have in the receptionist tasks. This one we're talking
Yes,
about. Né? So we have here the referees waiting for one team. I think is the F-boat for University FURG, Federal University in the Rio Grande, a Brazilian team, I think, because I see one person there about this team. But I think this is waiting for this next team.
Right. Is one team at a time, or do
Yeah.
you have many fields?
Yeah, it's one team at a time. So we take 6 minutes in these tasks for each team. After that, we will go to another team.
So the robots are the same or the different? Do you have any standards for them? How they
yeah,
should
we-
look like or weigh?
We have two kinds of leagues here. So the OPL is a robot made by the team, or you can buy one too. It's okay, but a lot of teams made your own robot. So each robot is different. One other is most different. And you have another league that is the SPL, that you have the same robot is in the other arena. So I think you will not see this robot now. This is the RoboFei team, a Brazilian team too, from the Central University of Fei. I think is starting this task now.
So nobody should be in the field for the test to begin, or someone is there, the referee.
Yeah, only the referee. Sometimes we need assistance of one of the team members, but I think this task is not allowed to have anyone. Only the referees.
I saw.
One time the robot starts the procedure, we cannot tote the robot anymore. The team is not allowed to tote. So this task is starting now. The robot is going to the start point and probably waiting for the first guest.
Real people.
Yeah, it's real people. So we have a volunteer. This is our first guest. We already have one person in the arena. This is the guest of the host of the house, and waiting for guests. And this is the first guest. I'm not hearing what the robot is talking, but probably is asking the name of the person, or probably ask it to the person do something to the robot to remember him.
I saw the robot has kind of a face. Why?
Yeah. Some robots there's a face. This is one that have one face. This face changes along the time, but it is only a tablet, iPad, something like that, to put the face. There's other robots that have a physical face, with a mouth and eyes, but that depends the team.
Got it. One question: how do we evaluate the robot? How do we know who won?
Okay, so like I said, we had 8 tasks in this year, 4 tasks in the first stage. So today we have 2 tasks of the first stage. Tomorrow we'll have another 2 tests. Um, and who take the more points win. And the last day we will have the final with the 2 or 3 best robots.
But only one, the team has only one robot, and this robot has to do all the tests. The same robot, or no?
Yeah, most of the team has only one robot, but is allowed to have 2.
Oh, got it.
Sometimes we have a team with 2, but most of
The same robot for everything.
yeah.
Great.
So
Amazing.
I think the RoboFay don't talk with the guests and they finish this part. And now we have another robot starting the tasks.
And what did happen with that last team? They didn't get the points, or they will have? Will they have another chance?
I don't hear what the robot talk, so I don't know if the robot talk wrong with the person, or if the person is not hearing the robot.
Got it.
Probably the team makes some mistakes in the start of the robot, and they don't talk with the guest, and they finish this try for this team. And now the second team is starting the task, probably in some couple of seconds. The robot's going to the start position that is in front of the door and wait for a new guest.
What about the kind of field? How do we call it? The space.
In the field.
Yeah, the house,
The
right?
house, yeah.
Is it always the same? It changes.
Yeah, it's not always the same, but it's always a house, also an environment with some sofa, TV, and some objects. But every year we change a little bit this house. So one year we have a TV in one point, in another year TV in another point. Sometimes we can change the size of the arena, but it's always home environment. And this year we have 3 arenas, so one for the OPL teams, that is that one, where we have teams that make your own robots. We have another arena to the DSPL teams, that's standards ones. In the third arena for tests, so the teams can use free. I don't know what's happening with the second team.
They also
Probably they made a mistake too when he starting the robots. So we're going to the third team. So it's the same process. He will start in the robot will go to start position in front of the door and waiting for a new guest.
Can you tell us a bit about the teams this year? How many teams do we have? Where are they from?
Yeah, we have 18 teams, 14 for OPL, that's happening now, and 4 of the SPL category. Yeah, and we have teams of all around the world. Mostly this year is from here, Brazil, because it's close,
It's
no?
home. We're at home.
It's everyone at home, so it's more easy to this team come here to Salvador. So yeah, the most of some teams is from here, Brazil, but we have Mexico, Japan, China, Germany, Italy.
So everybody's communicating in English.
Yeah. You need to communicate in English. Well, I don't know what happened to this robot too. The team member pushed the button of the robot. That means this is an emergency button. So every time we push this button, the robots need to stop everything. So the team member push the button and removing the robots of the arena. So let's go to another team. As I
Next
say,
one.
we have 14 teams and they have two tries. If you have more time, we can make a third try.
Talking a bit about rules, what did change from last year to this one?
Okay. I think for the last year, for this one, we have not much change. Well, there is some tasks that not exist anymore. We remove it and we put another one task, a very new one. So we have give me a hand as a new task for this year. The robots needed to take a bag with a lot of objects and take an object of this bag and give to the human. So the robot need to access the human to organize things. But this is a very difficult one because the robot need to recognize objects inside the bag, take a correct bag in this mess, and give it to the person in a correct way. This is a very difficult one.
And how people ask the robot to take something, like they actually ask with voice, or they press a button?
Yeah, normally it's by voice. So all the robots have a microphone and speech, and the referee asks to the robot talking in the microphone. The robots need to understand what the referee say and recognize it and take the object. But we have in the rule book the possibilities to use those X machines. So the team should use QR codes or something to pass this information by QR code. So this is allowed, and the team will be penalized if it not make a correct interaction by voice, for example.
Oh God, I'm already nervous watching everything. It doesn't seem to be working.
Yeah, no teams do nothing until now. Let's see the another one.
Is it normal that at first it doesn't work, or it's something that's happening only?
It's normal. Some teams cannot do anything at all. Some teams have bad luck in the initialization, and some teams make everything good. This is a team from Italy. Let's see if they will. So they will start again. Start now.
It's going.
They push the button to start the robot. We are waiting.
Is that some time, some seconds for it to start?
30 seconds.
30 seconds.
Probably the robot is saying something, but we cannot hear now.
But it should go straight to the door.
Yeah, they go straight to the door and wait to the guests. Oh, they didn't happen to. Let's see another robot. As I say, we have 14 robots, so I think some of those robots will get it.
For today, the only task will be the receptionist. Will have others.
No, now is the receptionist, and at 5:30 we will have the storing grocers. So the robots need to recognize objects in the arena, take these objects in a table in the arena, and put these objects in the shelves in the right positions. So we have some place that is designated to each type of object, and these robots needed to put all objects in the correct place. Let's see another team.
They're so different.
Yeah, in the OPL, this is a very great characteristic. Each team has a unique robot, and the most part of time the team made these robots from zero, from scratch. And this is very good. We can see this robot is one make from zero.
Also, Wagner, you're a teacher. You teach them guys how to do it.
Oh yeah, I'm a teacher in the Fei University Center. We have engineering of robots there in the university. I'm a teacher of robotics, manipulation, navigation of the robots, interactions of humans and robots. So we have a lot of disciplines in your university. I'm also working with the at home since 14 as a
Were you a competitor?
a competitor, yeah.
Oh.
In 2014, in 2014 I was only in the organization, but in 15 that was my first participation as a competitor.
Great, so you know what they're feeling.
Yeah. I think most of these people, this guy is very nervous now.
Yeah.
Just because it's the first task of the day of the competition, so everything needs to be okay, but it's not okay. I think the robot is talking to the person, probably asking his name, and
He answered.
he answered. I think it's João. I see the
Hear his
lips.
mouth.
Yeah.
Great. Oh, it's João. It's for sure
Ask
João.
again for his name. So the robot is talking to the guest. Let's see if the robot will ask for the favorite drink.
Yeah.
Ask to follow him to the ask again his name.
Yes, again. And well, I have some questions. The host was at the couch. She's not.
Probably
anymore?
he's in another
place.
chair. Yeah.
Oh.
We have some place. A sofa with two places and two another sofas, and probably the person is in one of them. Because we can change this person. The robot need to recognize where this person is sitting. Okay, the robot is going to some place, but where is the guest? Oops. Okay. The robot almost fall.
Yeah. Well, but okay, it didn't work first time for many of them. Will they have another chance?
Yes.
For this task?
Yes. If you not complete this task, we're going to the end of the queue, so you can try again.
Oh, great. How many chances do they have?
Yeah, 2 chances, but if you have more time, we can try a 31. Probably we'll have more time because the team is not doing anything in the first try. So I think we will have a 30 try.
But wait, the robot didn't answer the first time, right? But can they change the code like this fast for it to work in a second time, a second change?
Well, sometimes we make miracles.
Under
in this
pressure.
time, under pressure, yeah. and you see some problem and get hurry to fix it.
Oh.
It's very common. Oh, I see what's happening. I see what goes wrong. I can fix it.
And how many people is each team have? Do we have any
Well, this is this
like
came.
5?
We have teams with 4 people, 3
10.
people, 5, 9, 10, 12. I think
Okay.
the team that have most people is 12 in
Okay.
these years.
Mhm.
But we have another years with much more participants in the same team.
Oh, great. About and what do we expect for next year, Fagner?
Well, next year we will be in
South Korea, right?
South Korea, yeah. we plan some change probably for next year, but we are discussing
Yeah,
this yet.
we have to see you in this case. You have to see you guys have to see what happens this year to change the rules.
Yeah,
It's based on what happens this year. Yeah. or
Yeah,
no?
yeah, because we can find some problems and need to put this in the rule book to this problem not happen again. We can make it some improvements to make the league better each years. We have some plans to have humanoid robots for the next years. So this is a big change for our league, and we expecting very much this happen.
Great.
So I think we will have another robot. I don't know if you.
Oh, these two guys. Who are these two? One is the referee, the other one.
We have 2 referees in each arena. So one to see if everything is going okay, another to take notes like the time, if you see something wrong too, the scores. So we have always 2 person in the arena. So one with the stopwatcher and another to take the scores. Let's see another team. I think this is a good one. I think this robot will do something.
Actually, as the local chair, what do you do?
Everything.
A lot of work.
Everything and a little bit more.
Since last year in Eindhoven, we had a lot of work as a local chair. So we need to talk to the OCs, talk to the TCs, make everything good, check if the arena is good, check if the furniture of the arena is good too, buy objects. So we have to go to
Solve problems.
we have to go to supermarket to buy some snacks and drinks to make this thing happen. So I think this is Tidy Boy teams. I saw these teams made something in this task, so I think they will be
It's
okay.
gonna work.
Yeah.
Yeah.
But this is a good one. Let's see. I think the referee is talking with the volunteer. Probably this is the second try for all the teams, and they are giving new information, new instructions to the volunteers.
But who completes the task have a second chance.
The SPL League is happening right by our side, so people are really exciting.
Probably some robots made a goal.
Yeah.
They have another chance to improve.
Yeah. As I say, probably this is the second chance of all the robots. And if you have more time, I think we will have. There will be a third chance. Oh, the robots. I don't know what's happening. They take the robots off the front of the door. Yeah, problem is in the waiting for the second try. The referee is taking some notes.
João is waiting.
Let's see. Oh, the robot come back.
and I see they have like a crowd there. Does it make a difference for the robot?
Yeah, it's make difference, but the robot should to handle it.
Yeah,
Because
it's expected.
Yeah, we expected to have people around the arena, and the robot and the team know about that. The robot only needs to recognize people inside the arena. If you have someone outside, it's allowed, and the robot should ignore these people. Well, the robot is in front of the door. We will see the first guest. I think the robot is asking his name. She
Patricia.
answered. Patricia. Oh, Patricia is the name of our guest. The robot made the second question about the favorite drink, and the volunteer response. Oh, ask again. She said no. Probably the robot asked if the favorite drink is correct. The robot hears something and asks
confirmation.
Yeah, it's a confirmation. Is that one you said? And the volunteer say no. No, it's okay.
Is she talking in English or Portuguese?
Yes, in English.
Oh.
So now the robot is guiding the person
She's handing her there.
to the place with the drinks.
Oh, that's amazing.
There is a drinks. And the robot will indicate which drink is of this person.
Well, he asked her favorite drink, but she has to say she has to answer one of these ones.
Yeah, one of these ones. The volunteer know which drinks we have.
Oh, but the robot, we have to say to the robot before, or if only she says milk, he will search for the milk.
Yeah, the robot know which drinks we have in the arena beforehand.
Got it.
And now the robot will indicate this favorite drink to
I'm
the
impressed.
person.
Really impressed. I've never seen.
Maybe this robot tried to take the drink. I don't know. Let's see. Or just indicates to the person take it, and after that the robot will guide this person to a seat. Well, they should not take a drink. Probably they have some mistake. The robot asks to the person go in front of them and offer a seat for this person. Okay, now the robot go back to the front door to wait to the second guest.
The robot keeps the information to bring drinks for everyone at the same time. Is that right or no?
Yeah, they skip this information. Probably they will get the drink after. But now he's recognizing the second guest, asking for his name. In some time, the guest could change this position, so the robot should recognize where this is now. robot is making a confirmation.
And we have a set time for all this to happen.
Yeah, 6 minutes.
6 minutes.
6 minutes. The team had to complete this task.
For 2 guests.
For 2 guests, yeah.
Oh, great.
It's a little time.
Yeah.
So.
And what about for the standard platform league? I heard that Timothy told me that the cameras are not the best, the software not the best. What about those robots?
Yeah, this is OPL team, so they use whatever he wants. Since the robot can enter in the arena, it's allowed to use any kind of hardware, software. Most of the teams develop your own software. So yeah, it's allowed to use anything. No, he's.
Yeah, I saw some robots with personal computers. I saw some. This one has a cell phone.
Yeah.
But they work fully autonomously.
Fully autonomous, yeah. There is no one controlling those robots. I don't know if you see, but the volunteer changed the place. So the robot should recognize this and offer a new seat to these guests. And let's see if the robot will take the drinks.
I wish we had a count. I wish we knew the time left.
Now the robot is presenting each guest to another.
Oh.
Oh, the volunteer
So
is
polite.
impressed. Finish.
It's working.
Very impressive.
Great. Beautiful.
Even the volunteer was impressed. Probably he stalked something. He stalked this favorite drink. He remember where the volunteer was.
But now it's over, or no?
It's over, yeah. And I think they made almost everything.
Yeah.
I'm not sure about the take the favorite drink. But the robot looked to the person talking, introduce both guests probably. I don't hear, but probably introduce it. They tell the position of favorite drinks. So I think the robots don't need to take the drink, just tell where it is. So when they come in front of the drinks, they saw the drinks and tell to the people where it is. And show the guests around, offer free seating in two tries with 2 guests. So I think everything's gone. Everything was good.
Which
with this team?
Which team was this? Do you know?
This one that finished now was Tide Boy.
From.
Let me see.
Well, I have a special question.
Tide Boys is from South Korea.
Oh, they came from far. Which part do you think is the hardest for the robot to do?
Well, that's a good question. Yeah, we have the navigation that most of people think this is a completed problem because we have a lot of solution today about the navigation. But here at home, we still have some issues with navigation, mainly because we have people and we need to
manage it
with people. Yeah, but it's not I don't think it's the hard one. We have the perception of the people, objects, understanding the environment, take decisions. So it's so many areas to the robots handle it. I think that the perception and make decisions is one of the most hard today.
Yeah, because what if a person asks something or tries to say something to the robot like, "Hi, oh, you're so smart." The robot, how will the robot react? Can we predict it? Do we know? Each one is different.
Yeah, the robot can do that. But for these tasks here, the robot is expecting some set of answers and questions. For example, in these tasks, the robot is expecting that people say his name, his favorite drink, look to the robot. In another task, the robot should ask for what is the object where I can take a bag, for example. So the robot is expecting some kind of information. In the future, and of course, out of the arena, we can make a robot that can recognize a lot of questions and answer it. We have now a lot of technology that can help us with this issue.
Great. What about image analysis? How
About
image?
image.
Yeah, how the robot cameras, they recognize objects.
Yeah, in this league, as I said, the robots can use the hardware and the software that you want. So we can use a simple camera or a very good one. We have teams that use normal camera, and we have teams that use a 3D camera. 3D camera, yeah,
Whoa,
because
great.
they take the colors and the distance of the things in this camera. So the robot can see an object, recognize this object, and tell how far this object is with
Amazing.
this camera.
No, everything that surround them. Amazing. So Fagner, we came to the end.
Okay.
It was really great. Thank you. I'm still nervous for the
Well,
guys.
I don't know if we will have another no, the team
Yeah.
just left the arena.
Yeah.
But probably we will have a third
Now-
time because the first one was very fast.
Yeah.
And this is the second try, and we will have a third one probably.
Now we are going to the rescue.
Okay, thank
For
you so
the
much
league.
for
Thank
this
you.
transmission.
Thank you guys. Hope you enjoyed it, and we're gonna have other days of it. Many things are going to happen. Thank you.
Thank you. Bye bye.
Hi everyone! So we are back again now with the Rescue League. So I'm here with
Adam Jacob from the
Adam
National
Jacob.
Institute of Standards and Technology.
Awesome. So Adam, can you please talk a little bit more about the league? What are the main challenges and main rules?
So the RoboCup Rescue Robot League is working with and for emergency responders of all types. So our arenas and our rules are all set up to help emergency responders understand what the state of the science of robotics is that
Awesome.
might help them, and to guide the researchers toward those applications that can be solved. So what you'll see is the most aggressive terrains in all of RoboCup, very flexible so that we can make them rather easy or very hard. All of them approaching reality, but not quite as hard as the actual emergency response scenarios.
Yeah, definitely. And as we can see, we are watching now some of the challenges here, and I really like this robot. I think it's very different from what I'm
different.
used to see, you know?
It's new, actually. So this robot is with the legs, 4 legs, quadruped, but with wheels as feet, is just an extraordinary improvement in mobility. Here you see, this is a terrain that has been in RoboCup for years.
Definitely. This is a terrain, and I mean, it's. Can you explain me a little bit what we have inside these white tubes?
Okay, so this is just one of 10 lanes that the robots need to deal with. This one it's called pallets and pipes. The pipes roll freely, so when you bring a tracked robot or fixed-wheeled robot to this terrain, they need to change their shape to surmount the obstacles.
Oh,
So
awesome.
This is 10 years ago. This is what made robots start putting flippers on the front and rear of their robot. Flippers being the change in shape you need. This robot's doing it a completely different way. Don't be fooled. This hasn't been around very long. This is like
Really?
literally months that this robot's been available. But you can see how easy it is. So I can tell you from previous competitions and other competitions, this robot could climb 4, 5, maybe even 6 pipe levels.
Really?
Climb.
And this is not easy at all.
Never happened before.
Never happened before. And I mean, this is very, very nice. So we see how the teams are improving themselves, like improving the solutions, right?
Okay, so you see when this robot is even struggling at all, it's because of the payload that's on its back. So RoboCup Rescue is focused on 3 things: mobility, dexterity, so that's a stowed manipulator arm on its back. That manipulator arm does all the tasks that you see, the white pipes in the near field and the far field. Those are dexterity tasks. And then the center part of its back payload is the computer, the brain, the thing that it needs to do these things autonomously.
So this is autonomously.
Not necessarily right now, and this doesn't look to be autonomous right now. This is remote operation.
Okay.
Where they're facing away from the arena, so the operator can't see anything more than his cameras are showing him. So it's as if you're inside the building, but the operator is outside the building.
And can you tell us about the importance of this for the society, and how do your experience with that? Like, I mean, how can it help, like, fight fires or, do you know, in disasters? How can it be used?
So there's a lot of various levels of complexity and difficulty in all of these hazardous. But we're on the hazardous end of the spectrum. So when emergency responders are going in, these robots need to go where they shouldn't be, where it's really unsafe for even the responder to go in. A semi-collapsed structure, say. There may be victims inside, but until you know that there are victims inside, you want to send robot after robot after robot to map the area, to find the victims, maybe deliver some supplies water, food, radio, and start talking to them and keep their spirits up. And then when you know all that, then the responders are going to go in and do the rescuing. right? The
Definitely.
rescuing will be humans.
You'll be humans, yeah, yeah. It's very important to tell that because some people really think that okay, this is robots are going to be in the place of humans, like do the what a human will do. But
Well-
no, I think maybe
Well, so let's
let's talk
be
about it.
careful because
Oh yeah.
there are times when absolutely you're trying to replace the human, like when you're dealing with unknown packages or potential explosives and things
Dangerous
like that.
places.
Yeah, that
dangerous.
you're actually trying to replace the humans. It's just when you're talking about saving a victim, it's very complicated.
Yeah.
And so you want to, you want to do so safely, and the humans know how to do it, but we don't want to risk them.
Risk them.
A secondary shock from an earthquake might bring the whole building down. So unless there's reason to go in, then they ought to not put themselves in danger unnecessarily.
Yeah, that's a great point of view, and I think it's really the meaning of this league, right? So, have some restrictions that the robots need to follow, like size or way to how they move.
So the size is dictated by the scale of the test lanes. So what you'll see here is a general guarantee of almost 120 centimeters, 4 feet in lateral clearance. So that's a certain
awesome.
size robot.
Yeah.
But then there are smaller scales in the rapidly manufactured robot league, which is our junior, the next level down from us. They're half scale, 60 centimeters or 2 foot clearance, and then they actually have a 30 centimeter 1 foot clearance version. So all these test methods scale down to very, very small.
Oh, okay.
And if you're talking about the smallest of small robots, which are typically high schools getting involved in rescue, those robots are 3D printed. It's not easier because it's smaller, and a lot of times it's actually harder.
Harder. I got it.
And they're disposable. Those robots can go into a hazard and not need to come back out because they're so inexpensive relative to others.
To others, yeah. I mean, this robot seems like this is a.
Well, you would think that looks like it should be expensive. Part of this advent in technology is that that's not actually that expensive
Really?
relative to robots we've seen in the league. That is actually a rather inexpensive robot.
And this is a mechanic hand, like.
So this is the arm now that it's going to try to do the tasks. The arm. So the way the trial breaks down in RoboCup Rescue is the first 10 minutes of a 20-minute trial is all mobility. So you just watched it do 10 laps back and forth. Show us you can get 100 meters into the building. And then the next 10 minutes is now you're downrange. There's things for you to do to score points. So they have to blend the notion of I need to be mobile. That's why it's stowed so well. And now it's deployed. Will it reach? We don't know. Maybe not.
Maybe. So.
It's a small arm.
So you said that the robots need to complete tasks. So can you explain me more about it? Like what tasks, what kind of tasks?
Yep. All right. So again, RoboCup Rescue is about 3 things. We need you to do mobility,
Yeah.
and there's 10 lanes of mobility. In those same lanes, there's dexterity. Dexterity is all about non-contact inspection. That's what it was just trying to do there. Look in the pipes.
Looking.
And those pipes are all oriented in different directions. So we're forcing those robots to have inverse kinematics, solved inverse kinematics, enough joints, and easy controls from the remote operator, or preferably fully autonomous dexterity. So here, this robot maybe right now decided it couldn't reach from where it was. Now it's up close, and now it's going to try again.
So he is like looking what's inside the tube?
Inside the pipes are visual acuity first. Then there's like a gauge to read, which a remote operator can do both. When it's autonomous, we make them read QR codes, which is the same thing when you have to get close enough for your phone.
So you can scan it?
Yeah. So it works the same way.
Yeah.
Or we put in partial images to recognize, like a hazmat label, but only the amount of the hazmat label that fits in there.
In there. So
As if you were looking inside a bag. and you saw part of a hazmat label in shadow.
And you need to be able to correctly recognize it.
The system
The
needs to be able to.
system
The
needs to be
robot
able-
needs to recognize it.
Yeah.
So a little bit of image processing. So that part of image processing is pretty solved. Carrying it on a robot is what we're insisting upon.
Yeah,
So they
like
don't need to develop the vision processing.
Yeah.
They need to apply it in a mobile robot.
they need to this processing need to be optimized enough to run in a small robot.
Yep. That's just the first task. You see, that's the left side where he's approached. In the near right, you see an omnidirectional hole, roughly speaking. That's a threaded hole in the lower
Yeah.
right-hand corner of the screen. That's now a touch task. So you have to touch or insert a tool into those holes at all those orientations. This is why it has to be solved inverse kinematics, or you can't possibly
You cannot.
do it.
Yeah, that's so interesting. And I, just like a personal question, but it's because it's a doubt that I have. I have already worked with a robot that looked like this, not with the heels, right? And one problem that we have is the battery. Like, we have just like 1 hour of battery or less. And in your experience, and what have you seen in the competition, how is this? Do you know this issue for them? How they manage it?
In the competition, we're trying to focus on certain things and trying to neutralize other things.
Yeah.
So we're focused
Separate
on
things.
mobility, dexterity, and
Yeah,
mapping, 3D mapping,
okay.
which we'll talk about. But in a timed trial that does not affect the endurance of the robot. So the time trial is shorter than the endurance of a typical robot.
Oh, yes.
Because battery technology is a different deal. Someone else needs to solve that problem.
I got it. So it's steps, right?
But that's not to say we're not showing that payload. Now that robot is carrying a certain weight. I think it's 5 kilograms or so for that arm. So that affects the battery endurance. So at some point it affects the mobility too. So we pay attention to all that. So understand that what you're looking at are standard test methods that
I
we
got it.
develop at NIST, and they get standardized throughout the world, disseminated throughout the world, standardized through ASTM. And there are endurance tests. There are radio comms tests. But we don't try to implement them during RoboCup. We try to neutralize them in our roles.
Oh, I got it. Just like a kind of controlled place.
We work on the
and
things that our paddock are talented at doing,
Yeah.
which is robotics.
Robotics. Awesome.
Now,
And
I mentioned radios, but we're actually working on the radio spectrum more than I'm saying. We have, if you see them dangling a cable to the robot, that is the communications cable. We have them have a communications cable. You can see the blue cable going off.
I saw it.
That's because it's attached to our box, which takes their radio and crunches down the bandwidth, or applies a recipe for packet loss that we can implement across everybody. So that's how the remote teleop teams, it feels like you're in a building with bad radio comms.
Oh, that's
But we do it
awesome.
artificially through the line. And that's forcing teleop teams to become autonomous. Because there are times when you need to be autonomous just to
You
get
need to
to
take decisions, right?
a
The
radio
robot.
comms dropout zone.
Yeah.
I need to get from here to there. And then I have radio again. So
Yeah.
so if you think about our lane is a radio comms dropout zone, and we can turn the dial on how dropout that radio is.
And I just got curious, how all of this was thought, like, I know how it was implemented, but who is the person of the team and how they thought, okay, let's do this way with these challenges and this difficulty, let's see if the robot can do these things. I mean, this is so interesting and so intelligent, you know?
Okay, so if you ask the teams in the paddock, who's the dastardly person that puts them through all these terrible
Yeah.
things, they pretty much
That's
point
what I
to me
mean.
with that. And so sometimes I say, I've heard your name. And I say, well, was there an expletive on both sides of it? But the point is that these teams may be swearing at me at the beginning of the week, but by
Yeah.
the end of the week, they're doing all the tasks. Because
Yeah.
this is a development session for teams. This is not a show and tell. This is a figure it out,
Figure it out.
and get better and better. By the end of the week, we can turn the difficulty on all these tests up by the finals. It won't look anything like this anymore. Really impressive.
Really?
World-beating capabilities by the end of the week. This is the preliminaries. This is the first morning of the preliminaries. Everything's in its easiest
Really?
configuration. Right? Oh, yeah.
So we are not. This is not a competition where you just stop improving your robot and then you're
Oh, no.
going and show it to the world. It's like okay,
They won't survive.
let's see if you can survive, right?
So this is the idea, right? So there's a whole team of people at NIST, and there's a whole team of people like in RoboCup Rescue.
Yeah.
For 25 years, RoboCup Rescue has been doing this, turning the dial a little harder every year.
Every year. So
And as soon as someone in the paddock solves the problem, that gives us permission as a league to move forward. Because we expect the winners of every competition to share how they did it.
Yeah.
We have great stories about how robots 10 years ago, 15 years ago, solved our mapping maze for the most part with a little
Right.
bit of terrain and the algorithms to produce correct maps, and then they shared it with all the teams.
All the teams, yeah.
So the teams that weren't good at mapping, that's not their expertise, got to wear a mapping system developed in the league, and we're all moving forward faster.
I think this is awesome. Like, we don't have something that is a secret technology of each team. This is something that I would like you to talk about. How are the teams participating, communicating? How is the vibe,
So-
of the place?
I'm not exactly sure why it has worked out so well in RoboCup Rescue, but what I can tell you is I think it's something about the domain that we see it as a league of teams against the disaster, as opposed to
Oh.
against each other. So we have a
That's
very,
awesome.
very collegial group of teams that help each other fix problems. I got stories already. By day one, we had teams helping teams to compete against each other, because it's not really about you versus me. It's about I demonstrated that capability better. You saw it. Now you know, and this is how to convince engineers that their idea wasn't the best idea.
Yeah.
Because you need to show it work a different way, and they say, "Yep, that was
Okay,
better."
okay, I got it.
So we're
Try it.
selling bets every day in there, and they're adapting and morphing. And honestly, the most magical thing about RoboCup Rescue over those 25 years, it wasn't the competitions. It was the camps that we held 6 months later or mid-year, where the winners won the right to present all of their secrets to the whole paddock. And I've watched teams,
That's
and
awesome.
there's no competition at that. It's just a
Yeah.
workshop. I've watched teams tear apart their robot to show us the insides, and they said, "Oh, you put springs on the inside rear flippers, so you don't have to control them so accurately going upstairs." That's brilliant. That's an innovation. Everyone adopts it, and we move forward.
And move forward. I think it's exactly what you said. I mean, feels like everyone is step by step improving them, not only themselves, but sharing the information.
Yeah.
And so the league, as a whole league, can move forward.
Can move forward.
And
it's very hard to be good at all of the things we're asking you to be good at.
Definitely.
So we need to get teams across countries, even outside of
Yeah.
your own university and across countries, working together on these things.
And how many participants there are? How many teams
Well, that's a
are?
good question. I think I have 15 teams here right now.
15.
And I think a couple of them are still in transit or trying to come.
Oh,
Didn't quite make
yeah.
it. Generally, we have 20 or so. This is maybe the furthest people are asked to go from around the world, so it might be a few fewer. But there's always 200 people in a paddock, and there are, teams of 10 people, teams of 15 people.
So we have a lot of people
Yeah.
here from all around the world.
Yeah,
Right?
yeah.
this is awesome because maybe some country can be very good at some technology and another be very good in another. So that's it. You have this step by step, as you said, moving forward, and this is the magic of it, right? So
here you see the guy
yeah.
looking at his interface, right?
I would like you to explain it, please.
So he can't see what the robot's doing. He is out of sight. Preferably can't hear what the robot's doing. Yeah, it's got to be remote operation. Your system has to give you all of your situational awareness.
I got it.
So multiple cameras, so you maybe have a hint of depth perception, but where you put your cameras to perform that task right there.
Oh my God.
That task is a pretty precise peg and hold task while there's a complex terrain. And all he could do is look at his images. So that's what they figure out.
He's not seeing anything that is happening.
Can't
only
see the robot
these
directly, just
cameras.
through his interface.
Oh, and it makes sense because in the
They're inside
real
a
life
building.
situation, you can control.
Yeah,
As you said, the radio, it's gonna be not that good. So
we play with all those pieces of the puzzle. All right, what's inside that box? The cameraman probably doesn't know to look inside, but what's inside? He's putting a hot pack in right now. A hot pack is a thermal signature.
Yeah.
So these robots are expected to identify a series of signals that would be a human. So there's sound in there, there's motion, beyond the thermal signature. There is a proximity sensor, visual acuity, obviously the QR code. All those sensors need to be on his tooltip. He's looking down in a directed inspection. Let's just say you're in a collapsed structure and you see something through the floorboards and you're looking down in there. There's somebody in there. They were in a closet. They survived.
Yeah.
You see the heat source.
The heat.
You can establish communications
movement.
because you can listen and you can talk. All that is going through that system. You see he's zooming in on the motion sensor right now. And the system needs to track the motion, right? There's some things we make the system do, which is tracking motion, because actually the system should be better at that than the remote operator.
That's awesome. I mean, I don't even know what to say right now. I'm really impressed.
There's a lot going on.
Really,
A lot going on.
And I've already seen all the infrastructure.
Yeah.
The structure
The
of
test
it.
lanes, yeah.
Yeah. I think it was yesterday or on the first day, but right now it's just everything was tough to simulate reality.
So this is all approaching reality in a stepwise but repeatable way. So the trick about the standard test methods, those standard test methods are the interface between the emergency responders that I've met here and their robots who maybe are coming here to practice in that arena, right? So we invite the local responders to come with their robots. And it becomes a bi-directional kind of demonstration. Tomorrow, I know we have hooked up a helicopter is going to be flying out here.
Really?
And responders are going to be rappelling out of it. And they're asking me, can we take any of the robots from the paddock? And I'm like, no. That's where we have to stop. However, there are things we can do.
Yeah.
What I mostly want to do is make sure they understand how they can use these tests, because they will be in Brazil forevermore. Right? So academics can use them. Any bomb squad can use them. Any fire department that has robots can use them.
It. I mean, this is something that I really... Everything that we see here has a meaning, as the main objective, the main goal, of the RoboCup soccer league was to win a human team, a team with humans.
Yep.
And this rescue league is just awesome. And can you explain me just a little bit? Do you have a time for doing that? Or as you said, just steps?
So, you mean, do we have like a 2050 goal concept?
Yeah, okay, you need to do it, but you need to do it fast.
Oh, no,
or
good point,
no?
good point. No. Fast. So fast is a hard thing to neutralize. So people like to turn what we're doing into a race. But really, it's not a race.
No.
You need to methodically move through the environment. There are certain features, not in this lane, but every other lane on both sides, that will fall down. They're magnetized. They'll fall down if you move through the environment
Too fast.
in an uncontrolled way, too
Yeah.
fast. You hit a wall, boom. So there's
Oh,
penalties
okay.
for that.
So there's a safety involved, right?
It's about fine motor control. It's robotics 101.
Yeah.
It's you don't just put a bull in a china shop because it's remote, because it's an unstable environment. You need to
Yeah.
move through it in a very particular way, very purposeful, and efficiently. So
Efficiently.
sometimes slow is actually faster in the end. Slow forward motion and steady forward motion is better, both for the remote operators and for progress.
Yeah.
So the remote operators, think of it this way: when you're driving a big truck,
A big truck.
and you're about to turn a corner, that that driver doesn't really eyeball the corner more than once.
Yeah.
He drives past it, he goes 1, 2, 3 count, and then starts turning his wheel and keeps going. So he's using time as a very major part of his navigation through that world.
I got it.
But if you stop and stop
And stop.
then you need to recalculate the distance to the corner every time, and nobody has that level of knowledge. The robots can have that level of knowledge because they have a 3D scanner going in every direction. So that's why the autonomy should work better than the remote operator.
Yeah.
And we're starting to prove
Definitely.
that that's the case.
Okay, so the robot that we just saw, it's not autonomous?
So it's autonomous at times. Sometimes things are just too hard for it.
Oh, I got it.
Okay, so
Yeah.
where the autonomy stops, the teleop begins.
Begins. I got
So
it.
we just inflate the scoring for autonomous success 4-1 over remote teleop success. So if you do a teleop, it shows that the robot's capable. You get 1 point. If it can do it autonomously, it gets 4 points.
That's awesome.
So we incentivize them to at least try. And if they fail, if it gets stuck, they can always back out and control it manually.
So always has a plan B, you know.
Plan B.
It's
And
okay.
then and it's by repetition. So every repetition they can start fresh.
That's awesome.
Like they're not fixing anything, they're not touching the robot, it's still downrange, but they have another chance to try to make their autonomy work.
Awesome. And one thing we have, like in soccer, we have a team that wins for like 5 years. In a, like 5 years. So in the rescue, I know it seems like it's not about the competition, as I said, but do you have like a team or two that always win, or at least that always do the best, are close? Yeah, like they are always they bring new technologies every year. Do you have something like that?
So we're asking so much of our teams in terms of mobility, dexterity, and mapping.
And mapping.
And then autonomously doing all those things, that at some point it's an integration problem too. So what's interesting is there are some teams from Thailand who didn't make it here. Some of the teams that always show up didn't make it here. And they have been winning because they took the mapping from the German team, who was best in class mapping. And we give awards for best in class mapping, best in class dexterity, and best in class mobility. So we can tell them they're on the right path and point everyone in the paddock to a new way of doing one of those 3 ways, so that if they're lacking in mobility, they know where to go look. So as payback, the Thai teams, who were mechanically sound, took the design invented by the Japanese teams to do the mobility, and they optimized it across 100 teams in Thailand. Just Thailand had 100 teams.
Teams of
100
it.
teams, all doing it almost the same way. And that way was invented by the Japanese, who did it right the first time. It got improved because of that kind of exercise. So the Thai team took Japanese mobility and German mapping and implemented it well with dexterity that no one was doing particularly well, added just a hint of autonomy, and then they were winning.
And then the awesome.
So coming out of here,
Awesome.
we're going to learn lessons like the system you just saw. That is now our version of a standard platform. So a lot of RoboCup leagues have this notion of a standard platform.
Yeah.
Okay. I don't really love the term standard because I, of course, work at the National Institute of Standards and Technology, and it means something specific.
Yeah.
But in this case, it's a common robot that several teams in the paddock can all have. So they have the same mobility, and they're working on the higher level of autonomy, or the higher level of mapping, or the higher level of manipulation, but they have the same mobility, so they can compare and contrast. We can measure them against each other a little tighter, and they can collaborate much more closely.
So the main difficult and the main challenge of it is the software, right?
That's how you
the
isolate software.
strategy,
Yeah, exactly.
because the hardware is the same.
Hardware is the same for those teams.
For
Now,
those teams,
we always
yeah.
have an open league. You're welcome to bring anything you can think of mechanically into that world. Happy. They'll always be compared against everyone else. But then there could be a bracket of quadrupeds with wheels that are all wearing the same dexterity and extra computer, so the same payload, and now we're talking software only.
Okay, that's really awesome. I really thank you for the participation and for teaching us all of that. It was really nice to have you. So thank you so much for your
Make
participation.
sure you come down for the semifinals and the finals. Everything will look completely different.
For sure, I will do that, and we'll try to show everything for you guys that couldn't come here. And if you're here in Salvador, you need to see it. You need to see it alive, right?
Yep.
This is really something.
All are welcome. If you have a robot, bring it.
Bring it. We want to see it. Thank you so much, Adam.
Okay, pleasure.
Hi guys.
We're back again.
We're together.
Together this time.
We're here to talk a little bit more about RoboCup itself, right?
Yeah, we had a long talk and awesome talks with leagues representatives. So we just had humanoid, right? Flying robots, SPL, SSL, at home. I mean, and the day is
it's only starting.
It's only the beginning.
Yeah.
It's only the first day. So we are very excited. So now we need to talk a little more about the event itself, right?
Fernanda, till when we're gonna be here? The transmission. When is the transmission going to end?
When the transmission is going to end?
Yeah.
Only Sunday, right?
Yeah.
So we have like
4 days.
4
Today
days.
is the first day.
The first day here. And we already saw so many
so
things,
many
you know.
leagues, talk to so
things.
many people. Yeah.
It's just so excited to see everything. I mean, I'm kind of wordless, like speechless. Sorry,
Yeah.
I'm kind of speechless because it's so incredible.
Yeah, and seeing everything here, like so many people, so many different people. I was talking to my friends that we don't know from which nationality people we are from. Like we have people from all around the world. Actually, we have people from 40 countries.
40 countries.
40 countries. Yeah.
I mean, it's very, very funny for us because we are Brazilian.
Yeah.
So we are used to come here and say bom dia.
Bom
right?
dia.
Bom dia, boa tarde. That is good morning, good evening, good afternoon. And here, when we are talking to someone, we need to be like,
Yeah, the standard is say good morning.
Yeah.
And then
Yeah.
after some time we realize the people
Yeah.
this person is Brazilian too.
yeah, I think first thing, look at the name.
Yeah.
Because we Brazilian, we have some names that it's very Brazilian name.
Yeah, it's very
right?
common. They are very common here.
But if you look at the name and you're not sure, good morning. Like, hello.
What about people who are making this event happen?
How many or who?
If you would predict.
We have the information here, but I'm not going to look at it.
Yeah,
Okay.
yeah. Oh,
Okay.
you didn't read it.
No.
Great.
Yeah. Okay. So how many volunteers
do
we
we
have
have?
here? Okay, this is the biggest event I've ever seen. I think maybe I don't know. Maybe 500. I don't know.
More people.
More than
people.
5. Really?
700.
700 volunteers
700
here.
volunteers. 700
So
people
awesome.
to make this whole thing happen. People everywhere trying to make everything work.
Just exactly as
it should be.
It should be, yeah. And that's awesome. That's awesome. And it's very interesting because all the volunteers, we are kind of volunteers as
Yeah.
well,
Yeah.
you know? So all the volunteers have this shirt, this purple shirt, this beautiful shirt.
Yeah.
And we can see they everywhere.
Yeah.
They
They're
are
just
really a
running
lot.
from one side to another. every
Yeah.
time.
And if we need anything, if someone needs anything, just ask a volunteer. They will help you.
Yeah.
And one thing I want you to tell me this time is, okay, I'm here in Brazil and I'm here in Salvador, but I don't know if I can enter in the event. You know, I don't know if I can come here and see things happening. Can I?
Actually, you should. You must.
You
It's all free. Just come
Like
and see the competition.
100% free?
100% free.
That's
Just
awesome,
come on in.
guys.
You're fully, totally, completely invited.
Yeah, I mean, if I can speak Portuguese for just a minute, maybe for people who's in Brazil, pessoal, vem participar.
Vem.
Tá muito
incrível.
legal. We just said, people, come here.
Just come.
You
It's amazing.
need to see what we are seeing. Like every moment that we stop, like the lunch break we had. Yeah. Okay.
Yeah. Many people here.
Only 1 minute, Barbara? Okay. I'm so sorry. I'm so sorry for that. It's just the first day, so hot information came here.
Yeah.
Hot news here.
What did you receive?
Well, actually, we were saying for people that are here in Brazil to come see it because it's awesome. But if you're not here,
If you're seeing us,
if you're seeing
you're
us,
here with us.
you're here with us, you can comment in Twitch or YouTube that we are trying and probably we're gonna work to show comments here.
Yeah.
So we are not only read, but we are gonna show, so you can show your support for our team.
You can participate.
You can
with
participate,
us.
yeah, and we'll really love this interaction with you guys because what we see it's a camera, and we will love to know more about you guys. Really.
Yeah, tell us who you are, why you're watching, what do
Yeah.
you know about RoboCup, what do you like?
What do you
about
like?
What would you like to see here?
Yeah, maybe what if you have a question, a technical question, we can.
Yeah.
And you know,
We have people to answer
all
anything.
questions. Yeah. And it would be very very nice if we can have this interaction, and if we can talk, right?
Yeah.
Together.
Fernanda, another thing.
Another.
Many things.
A lot of questions today.
Well, it's so great to have a RoboCup in Brazil.
In Brazil, in our country.
It's such a pleasure.
Such a pleasure. Like as we already said, we are Brazilian,
Yeah.
so we are very proud of our country, and I'm very happy to be here.
Yeah. In our
Very
teams,
happy.
we have many great teams. We're
Yeah.
doing an amazing job.
Yeah,
Yeah.
we have it.
The last time RoboCup was here was in 2014.
Really?
2014.
Like more than 10
more than 10
years ago.
Yeah, and it's cool to
Can
see.
you imagine
that-
it?
No, not at all. And it's great to see because many of chairs, some of the participants were here in Brazil in 2014 and came back this year. It was in João Pessoa, Paraíba.
Awesome.
An amazing city.
Amazing.
And they were here and they're here again 11 years later.
Yes.
And so much has changed since
Yeah.
then. So much.
Like not only the RoboCup, but the leagues, the
Yeah.
participants, the dynamics, the technologies,
The rules.
the rules, new leagues, new rules. Everything is different.
Everything changed a lot. It's something
Yeah.
that we saw with our participants, our guests here,
Yeah.
that they have new rules to improve, to make things even better every year. I saw a guy in an interview said that we have turf, and we didn't used to have turf.
Really?
And for robots, it's good. We're getting even closer to what a soccer play should
A
be
soccer,
with
yeah.
humans, right? And everything is changing. People are really making it happen. It's
Yeah.
so good to see. We see people from the teams working all day long.
All day
they
long,
are
like
on their tables and
they are living with coffee. Like you need to have a coffee on your side here, and or as we call cafezinho, right?
Cafezinho.
Yeah, and it's very very interesting to see. Like as I was talking with the SSL representative, and he was saying, I need to tell my team to eat. I need to tell my team to sleep. But I think it's everyone so excited and want to talk with a lot of people here, want to do this interaction. It's a very immersive event.
For sure.
Like you don't want if you come here, you don't want to go out. You
Yeah.
don't want to like I
It's
want to
an
live here.
amazing opportunity.
If I
So-
could, I would sleep here.
Yeah. If
Really.
you have the opportunity to come here, just come.
Just come. You will not regret it. Definitely.
Thanks, guys.
Production. That's it.
I think we're going to our next. Hi guys, now we're back here to present logistics. We are here with
Till. Hi.
Hi Till. Can you tell us a bit about you?
Sure. So I used to be actually a participant in the Logistics League until 2020. Now I'm the executive, so I'm the organizer of the competition, doing the more boring things, but I used to actually work on the robots. And I'm a postdoc in Germany, in Aachen, a university in Germany. Yeah.
Where are you coming from?
Also from Germany, originally.
Oh, great, great. What is logistics about?
Yeah, so the main idea of the Logistics League is that we have some smart factories. So we have a bunch of machines, but so each of these machines can do a step in some production. So you can imagine we are manufacturing a car, for example, and if you put together a car, you have many steps that you need to do, and traditionally this is all in sequence, but now in a more modern factory, in a smart factory, they are no longer in sequence, but instead robots actually have to operate the machines. So what the robots will need to do is transport the car pieces from one machine to the other, and then actually tell the machine which step it needs to do.
Great. Amazing. Yeah, actually we can see.
Yeah.
And can you explain us what's happening there?
Yeah, so we're currently still in preparation of the game, so we can see the machines here in the front. And so these machines, they're static and they're also they're not smart. They just do what they're told to do. And in a second, we will probably also see the robots that move around, and the robots are actually the smart components of the game, and the robots are actually the teams, while these factory machines, these are just part of the playing field, so to say.
Amazing. What about the teams? Do you know how many teams do we have?
Yeah, so this year we only have 3 teams, unfortunately, because 3 other teams that usually participate couldn't come this year. So we're going to see in this game that is going to start in a second, we're going to see the team Car Logistics from Germany, and we were also supposed to see Team Pumas, but unfortunately their robot completely broke. They had a problem with a small engine, and they couldn't really fix this in time, so hopefully we'll see them in the upcoming days. But now we're just going to see 1 team participating here.
Okay, and what does a team with a robot has to do to win?
Yeah, great question. So we can actually see a robot here right now. So you can see those kind of round-shaped robots that can move around, and at the top you can also see that they have a gripper, so basically a robotic arm, and the robot will move to one machine and pick up a workpiece from the machine and then move to the next machine and feed it into the machine. And the tricky bit here is that they don't actually follow a fixed schedule, because only during the game the robots will be told which product to manufacture. So again, coming back to the car example, so the robots will be told which color the car should have, whether it should have a sunroof and so on. And then the robots themselves need to decide which manufacturing steps they need to do to actually produce that car that was requested. So in hopefully a minute or 2 when the game starts, I think it will actually start in 4 minutes, we will see the robots first moving into the field, and initially they don't really know anything at all about the environment. They don't even know where those machines are, so they will first need to find the machines and then start working with them.
Great. I'm seeing they all seem the same. Is that right?
Yeah, they really look alike, but actually every station has a different purpose. So the first station that we will see and use is called the base station, which provides like one base piece of the product, and then in the next step additional rings will be put on top of that. So you can see in the very front, you may notice this machine with the orange and green rings in the machine. So this is one of those ring stations. So the station will put multiple of those rings on the product, and then we have another station that puts a cap onto the product, and then this is finished. And once it is finished, it needs to be delivered to like a gate where it can be picked up by the customer.
Oh God. When this league was created? When was this league created?
It started in 2012, but back then it looked very differently, and all the robots actually moved on the ground, and we didn't have those machines at all. So it was completely a virtual production, so to say. And then these machines were added, I think, in 2014 or 15, I'm not sure anymore. And yeah, since then, a lot of changes have happened, but we have always been using these machines that we can see in the picture.
Great. Do we have different rules this year? New rules?
So one change that we did this year is to actually move away from the standardized robot platform and allow more diversity in the robots. So until last year, basically every team had to use this Robotino base that this team, Car Logistics, is actually still using. But in principle, teams can now use any robot that they want to use. Apart from that, this year we haven't seen a lot of changes, but we're actually planning to do a lot of things in the upcoming years to make this a more complete smart manufacturing scenario.
Great. Do we have stages?
Yes. So in the first stage, the robots move around and try to find where these production machines are, and then in the next stage, in the main production step, the robots can actually use the machines to produce the product that was requested.
Great, amazing. Those three teams that you mentioned, where are they from?
So we have Caro Logistics from Germany, we have Pumas from Mexico, and Baby Tigers from Japan.
Oh, very diverse.
Yes, it is. Yes, and usually we also have some teams that have been active for a very long time. So Team Grips, for example, I think they participated in the competition since 2012, and they are from Austria. We also have a Swiss team and a French team that usually participate. Unfortunately, this year they don't. Oh, and then now we can actually see the game is starting finally. So we can see the robots moving into the field and first kind of just moving around to see what's going on. So the robot just looks at what stations it can find so it can later use those stations to manufacture the products. And now it's looking at it's trying to actually find out which station it is. And as you said, it's actually quite difficult to distinguish those stations. So I guess it's taking a closer look now. And then it will continue. So what we can see now, which is actually interesting, is how the robot is built up. So at the very bottom, we can see this Fasto Robotino robot, which used to be the standard platform in this league, but everything above this, so basically starting from the red piece, everything is custom built. So every team has their own robot arm, for example, and we've actually seen great developments over the years. So some teams have a different arm every year, and I think the design that kind of now is the result, or like what the teams are using now. This is really very good in doing these manipulation things that we hopefully see in a second. So I'm not exactly sure what's going on. It's probably still exploring and trying to find out how the field is set up.
Right. Only one team is going to participate there?
In this game, yes.
Yeah, right.
So let's see what happens in a second. And just maybe coming back to like the general robotics tasks that we need to do here. So we have the like very common things, like the robot needs to move around, it needs to avoid obstacles, it needs to, for example, move around these machines, but also it shouldn't hit any other robots. In particular, it shouldn't hit the opponent's robots because then the robot gets penalized. But this is just like basic navigation, and for this, if you in a second, maybe we can see again the close-up that we've seen before. You can see the type of sensors that the robot uses to understand its environment. Apart from this, one major step here is actually picking up the work pieces and putting them down. But this is also something that we've seen in other leagues, for example, at home. I think what's very special about the logistics league is that this is actually finding the right actions to do to produce the requested product is actually very complicated. So it involves up to 60, 70 steps. And only if you do all of them, you actually score points. So it's a very long sequence of things that you need to do right. And also it's not the same sequence every time. So it actually requires a lot of reasoning to understand, okay, they requested a red base and an orange ring. This orange ring needs these extra pieces to be used. So the robot first needs to move to a different machine, fetch those pieces, feed them into the machines, and so on and so on.
If a robot skips some step, is it possible that it's still working fine, or everything is kind of messed up?
So in most cases, actually, if one step in this long sequence goes wrong, then the whole production failed. Then, for example, you would use a green ring instead of an orange ring, and then the team would score 0 points because it didn't deliver the product that was requested. And you can imagine if you order a red car, but now your car is black, then you're not going to be satisfied.
No,
so you're
not
not
at
going to
all.
pay. So this is scenario that we have.
Got it. So are these machines being used somewhere in logistics, in factories?
So the production itself here is kind of a toy production that we do. So you can see here in the picture, if you look closely, you can see these round cylinder-shaped pieces that the robot is currently picking up. And these are, of course, not something that you would actually buy, because we kind of abstracted away this product thing. But actually, the technology that's behind this, in particular this reasoning, can be used in many smart factories, or like, for example, in a car manufacturing car factory. This is also not exactly maybe this technique is used, but similar techniques.
Got it.
And another example would be, and that's actually where many former participants of the competition work, is logistics scenarios. For example, at Amazon, you can imagine they need to move around thousands and thousands of packages, and this is not done by humans anymore, but instead completely automated using robots. And this is a very similar setup, but the robot needs to move around and need to decide which package needs to go where, so it can reach the customer in time. So the difference to that is here we're actually doing production, not only transportation.
A question. How about battery? Does it have a large battery? Do they have to recharge it frequently?
Yeah, that's a very interesting question, because it actually used to be a big problem for a very long time. But with the battery technology that has advanced so much over the recent years, I would say batteries are not a huge issue anymore. And we actually, now the robots all have hot plug batteries, so they have multiple batteries in the robot, and you can take out one battery and put in a new one while the robot is actually moving around. So so the robot can just continue working, and we change the battery on the fly, basically. This is not allowed during the game, in the competition, because the robot's supposed to act completely autonomously, but in principle that would be possible.
So cool, so cool. So when you were a participant, it wasn't like that?
No, then we had huge issues
One
with
more
the battery,
problem.
actually, yes. Yeah.
Oh, what's happening there?
So I think it's trying to put one of the work pieces into the machine. We'll see in a second. I'm not sure what it's currently thinking about. Maybe it's trying to find out exactly where the machine is. Or actually it looks like it's picking up one piece from this shelf. So you can spot this shelf in like behind the robot, and this is kind of, well, a shelf like you can imagine in your factory where you store all the parts, and the robot needs to pick up one of these parts so it can use it to produce the car that we've been talking about.
Cool.
But it seems like it's having problems. I'm not sure, so I can't really see into like the robot's mind what's going on. But it seems it's like
you're a
stuck
friend of them
bit. Yes.
already. So, how many time do the teams have? to complete.
Oh, okay. So
the
so
circuit?
the game is 20 minutes. So they have 20 minutes to produce as much as possible. And actually, one of the challenges is that they get a lot of requests, and they can never fulfill all the requests. So the robots themselves need to decide, okay, which of the orders am I actually gonna try to fulfill, and which ones am I going to ignore? And the challenging thing here is that so the human participants, they are not allowed to interfere in any way. So they can't tell the robot, okay, don't do this, don't
You wanna
do
help
that
your robots
instead.
and you're just like, no.
So the robot needs to decide completely by itself which orders are promising. So it also needs to estimate like how fast it can produce something. Does it have enough time to finish in time, and so on and so forth. So we
Great.
finally see some action again. And yeah, so we can see it's kind of difficult to spot. So this is something that's kind of funny about this league, because there are so many machines and so on. It's kind
Yeah.
of difficult to spot what exactly is going on. So this robot, the second robot in green that we've just seen, is still trying to find its way into the game, while the first one is actually already working hard, or trying to work hard. So I guess as usual in these competitions, today is the first day, so it's always getting started and fixing all the small issues.
Putting all together.
Yeah. It's a bit challenging. And as I described, since we have this very long production chain, you can imagine that every step needs to be tuned quite a lot, so it actually works at the end. So it actually takes a time until the robot gets
Do you
going.
guys sleep during the competitions? Not during, but like at night. You use the night to sleep.
It depends on how well it goes, but yeah, sleep is an issue, I guess. So I guess sometimes we are constrained by, sometimes at 10 o'clock at night, the venue would tell us, okay, now is enough.
Yeah.
It's time to go home.
Bye,
time to
guys.
sleep. And usually that's a good idea if that happens. But yeah, sometimes they would just let us work through the whole night, and then if you keep coding until 3 in the morning, then the result is usually so bad that it would have been better if you didn't do anything.
If you stop it before,
Yes.
it would be better.
Yes.
Oh, and when I think we have a competition today. We're gonna have 3 competitions, one each day, or no?
Oh no,
Or-
we have multiple. So today, I think this is the 3rd game today.
Oh.
So there are multiple games every day. It also depends on the number of teams. So since we only have 3 teams this year, the schedule is actually very nice and easy. But usually we try to do 10 games or more per day to just so every team has enough time to actually play.
some hours of the day.
Yes.
Whoa.
So now we can, I think this is a nice perspective, so hopefully we can see, no we can't,
Oh.
decided to do something different. So it's very difficult to understand what it's even trying to do. So I think what it's currently doing is actually fulfilling something, but without knowing like the internals of the robot, it's very difficult to follow and understand.
Yeah, it got me thinking, like, if you don't tell me exactly what I'm meant to do, I would do it completely wrong.
Yeah.
I would mistake everything.
Yeah, that is true. And so we actually, over the years, as a competition, we also put a lot of work into visualizing what's going on. So spectators can understand what's going on. But even us as teams, it's sometimes difficult. So if I watch a different team, it's very difficult to understand what exactly are they trying to do. So it's very helpful if they actually have some visualization that tells me, okay, this is the intent of the robot's action. So even just this is the product that it's trying to manufacture at the moment.
Got it. usually the product that they're trying to manufacture is the same, is almost the same.
Yeah.
How does this work?
That's a great question. So it is always built in the same way that we have these base pieces, and then we have a number of rings on top of it, and then a cap. But the colors in the order may be different, and the color of the cap may be different, the number of rings may be different, and so on. So it's really, if you come back to this car example, every car has 4 wheels, it has an engine, it has a roof, and so on. But every single thing can be customized.
Yeah.
So you may have different sized wheels, or you want a very big engine, or maybe an electric engine, and maybe you want to have a sunroof, and so on. And so all these customizations are also part here. So every product is kind of unique. That's why they need to do reasoning on the fly and decide on the fly what they need to do, because you cannot hard code every possible sequence, then you will have so much code this will not work. So the robot at the bottom really seems to be stuck a bit, but the other robot, okay, now we can, so we kind of could see that it fed one of these workpieces into the machine, and now the machine is continuing the step. So the machine actually does the manufacturing step, for example, assemble 2 pieces. But the machine does not know what the goal is, so the robot always needs to tell what it's supposed to do. So the machines can do a lot of things, but the robot always is the boss, so to say. The robot tells, put this ring onto this piece, and so on. And
are we coming to an end?
It's a good question. Let me check the time. I think we have a couple of more minutes, but I'm not sure. So what's also, I think, interesting, I guess, for most RoboCup competitions actually is like all the different things that the teams need to take care of. So they can't specialize on, for example, computer vision and just do computer vision. They actually need to do everything from electrical wiring and so on, which I have no idea about. So excuse my amateur comments. So for example, constructing this robot arm, which are all custom built. So we don't buy them. They are built by the teams. So this is already a huge engineering effort. But then you actually need the software to control of these things, and then you need software on top of that that kind of makes the high-level decisions. Okay, the next step should be that I'm moving to that machine to pick up the finished product so I can deliver it to the customer. And combining all these steps into one working robot is actually a huge challenge, but also I think what's so much fun about this.
Talking about fun, how is it to build a robot? Like from also a participant point of view, how was it? How do you start? Like, do you have any pieces that no, I cannot build a robot without this, or you can start wherever you want?
Yeah, so usually I think it's very useful to have at least a moving base like this Robotino that you can just use out of the box, and it kind of does its thing. But then you also need to decide which kind of sensors to use. So and here these robots have 2 LiDAR sensors. So basically it's using laser light to scan its environment, and it's using 2 so it can do a 360 scan, and that allows it to understand completely what's surrounding it. Yes, exactly. And so this is another important decision, which kind of sensors to use. And also, I think all of them also use cameras to detect where these workpieces are and where the machines are. So these are all the sensors that you need. And then also, on the other hand, you have actuators like this robot arm, but also the robot wheels themselves are also actuators, which require a lot of design decisions, I guess. And then there's one thing like coming up with a good design that works well in theory, but the other challenging thing is to actually make it work in practice, and that's actually most often the most difficult part, because
Does it happen to have an amazing idea? Oh, this would work. This will work with this, and now, and then you try and nothing works.
Yeah, exactly. That happens way too often way more often than you would want. So I think because of this, also very important to always have more experienced team members that have been participating for a couple of years, and then always having fresh minds that bring new ideas, but also don't know the common pitfalls yet. And if you have a team like that, then you can really exceed in participation.
And being prepared to get frustrated.
Yeah, that's the first thing that is true.
Great, really great. It seems really amazing. Like seeing all this engineering, everything just wires and it just happening. It's such a thing.
Yeah, and I guess for the participants, it's much more exciting because they know all the things that behind us. Here now, we just see a robot that moves around and picks up something and moves away. This doesn't seem particularly impressive, but if you know like all the small things that are behind this, then this is really already
so many things that could go wrong, right? So thank you, Till. Thank you very much. It was an amazing interview. I had a great time. Thank you. I've learned so much. I hope people at home also liked it. And I think we're going to the sponsors now.
Toda ideia nasce pequena, em uma sala silenciosa, num papel rabiscado, num sonho entre colegas. Assim nasceu o CEIA, não como estrutura, mas como desejo. Desejo de transformar ideias em impacto, ciência em solução, tecnologia em futuro. Em 5 anos, fomos muito além do que imaginamos. Criamos tecnologias, formamos talentos, aproximamos empresas e universidades. O futuro já começou. Ele está nas ideias que ainda nem surgiram, nas conexões que ainda vão acontecer, nos desafios que estamos prontos para resolver. E se o passado nos trouxe até aqui, é porque nunca estivemos sozinhos. E o que vem pela frente? Mais ciência, mais impacto, mais gente. CEIA, 5 anos de inteligência que transforma.
Hello everyone! So we're back again with a really special guest. So can you tell us a little bit more about yourself and your history in RoboCup?
Excellent. Hello, everyone. My name is Margot Edwards, and I'm one of the junior executives. So, one of the RoboCup Federation's executives representing RoboCup Junior. So, I'm part of a committee that is actually designed to actually run RoboCup. So, my background is actually in the on-stage competition, which we'll visit later in the week. But basically, I go across all of the junior leagues and can tell you a bit about what we actually do in RoboCup Junior. So, I'm a past participant. I'm from Australia, and I competed when I was in high school.
Really?
And, yeah, no.
That's awesome.
And then I came back and volunteered and came onto the committees, and now I'm here running RoboCup.
You're running?
Yes. So
Yeah.
I get to,
That's awesome.
my role in RoboCup is basically organize these events and then travel the world and see the robots actually work. So I'm really looking forward to showcasing that with everyone in the wider RoboCup and the world community to actually what we do in Junior.
That's awesome. So I think we can start asking, what is the junior league like? I know that it's a league that has a lot of leagues inside of it. Can you explain a little bit more of this organization and, you know, how everything works inside of junior?
Most definitely. So RoboCup Junior is basically, we have the 2050 goal. So the goal, you've probably heard a lot about how we, in 2050, we will be building the soccer competition with the humanoids to win against the human world champions. But the people who started RoboCup realized they're not going to be the people who actually build those robots in 2050. It's going to be the children and grandchildren of those first roboticists that are actually going to be building the robots in 2050.
That makes sense.
We need to actually have a opportunity for young children and students to actually be able to get there to build the robots of the researchers to learn and bring the education into RoboCup. So that's the basis of what we do in RoboCup Junior, is basically provides a very simplified version, you know, RoboCup Soccer, we have RoboCup Rescue, and we have a RoboCup Onstage, which is a really special league that's just for, it's actually talking about the technology. It's an open platform, and I'm sure I'll explain it to you many a times over the next hour, but it's basically a league where you can bring lots of different robots and through performance and dance actually, and show off technology that's
awesome.
used in all the different leagues. So, but really what we're going to be looking at today is the traditional rescue and soccer leagues, which were based on the same goal, but at an age level and a competition level that actually high school students can actually compete at, and that teachers can actually teach. Because RoboCup Junior, it doesn't happen in universities, it happens in schools all around the world, and we see the best ones here today at the international level.
This is so special because I was streaming at OBR, that is the Brazilian robotics.
Yes.
And we were looking at it and seeing this. So it's so special that we see high school students participating of this event. That is a huge event. And as you said, we need to teach them, because it's not us, it's them who's gonna be winning, you know?
Well, I have it very easy. I will be 50 in 2050, so it always works very easy. But there's so many students who, you know, the researchers today, they're going to be the gods of robotics in 2050.
That's right.
You know, now, so RoboCup Junior is actually celebrating its 25th birthday this year.
Really?
So RoboCup actually started for Junior not in 96, but actually a few years later, when the teachers actually realized we could do this too.
Yeah.
Around the world, multiple groups around the world realized we could do what they're doing at university level. And so they actually came and was able to build RoboCup Junior. And the first one happened in Melbourne, in Australia.
Really?
Yes.
Oh my God,
in 2000. So this year, and there was a bit of build up in 1999. So depending on the exact date, you have to ask the different people. But certainly for the 25 years of RoboCup Junior, this is it. And you can see I'm wearing all my badges. So we're celebrating.
God, that's so...
We have a special 25-year logo for all the teams. So these are our badges that we've created. So to actually celebrate 25 years of RoboCup Junior.
That's a lot of years of history, of how can I say, more technology year over year, right?
Yes.
So you are working with Junior. How long have you been working with Junior?
So I've been working with RoboCup Junior. I was a competitor when I was at school in Australia, and then I started. So that was about 2014. But I really started my international journey when RoboCup actually visited Sydney in Australia in 2019, and I took my 1 hour flight to fly from. I live in Brisbane and then came down to Sydney. And I was just like these students here today, just blown away by what RoboCup at the international level is like, seeing the major robots, seeing the highest level of competition at the senior level. And just being able to see that was so inspiring that I had to be involved. And luckily enough, the RoboCup organisation was happy to have me. And
my God.
My first actual competition was during COVID years. So we had the hybrid, we had hybrid competitions and worldwide virtual competitions. And then after COVID, then we came back. And now I get to organise we've been to Thailand, in Bangkok, we then went to Bordeaux in France, and last year we went to Eindhoven in the Netherlands.
That's awesome.
And now I get to come here.
To Brazil, Salvador.
And Salvador. And, thinking about it as an Australian, to travel the world, South America wasn't even something that I considered. But look at what the opportunities that RoboCup have provided, not just for me as a participant to see your beautiful country and the robots that you have here, but also for the competitors who, are school students who get to come to Brazil and see and learn from the Brazilian robotics community, because you actually are the biggest RoboCup Junior region.
Really?
Yes, you are.
Oh my God, I'm so proud of that right now.
No, so you actually have a wonderful program where you are part of schools. You actually have it in the curriculum, and it's actually I would say the benchmark for actually how RoboCup could be worldwide. So it's really exciting to showcase what you as an organisation in Brazil we can learn for the rest of the world. So I'm really looking forward to sharing that, not only with what we do at the international level, but how other regions could learn and grow from just being here in Brazil. It's amazing to see.
I mean, I'm very happy to hear that, because once I was a high school student who was participating of the junior, not RoboCup, as I said, OBR here in Brazil. So that's amazing. I'm really happy to hear that from you, really, really. And can you explain a little bit more about rescue? We just saw some field. It's not a field, right? How you call it? And can you explain a little bit more about it and the challenges of it?
So rescue it's a challenge where you're trying to it's like the major rescue. Have you been to major rescue yet?
No,
not yet. Okay, I'll explain the context a little bit then.
No, wait. Yes, the major rescue.
The major rescue
is the wood.
The wood and the big courses.
Yeah.
So basically, the whole idea of RoboCup rescue really came out of the natural disasters, particularly in Japan, where robots were actually used in tsunami and earthquake rescue situations where you've got a disaster situation and you have to actually rescue people or resources from a disaster zone. And so what we have here is RoboCup Rescue Line. So Rescue Line is actually, it's one of our first international level competitions where it's actually it's mapping out a course, think of like a road that you have to follow the line and there's obstacles along the way that you have to avoid. There's also intersections where you actually, the little green indicators where you actually have to turn the right direction. And as we see as this robot comes into the final arena, you then have to go and actually find some people to actually save. So you can see here we actually have some balls. So those balls are both the silver, and they are actually people who are alive in a little capsule that they need to be saved into a safe environment, which is the green capture zone.
Oh, the green.
And the green for good. And then unfortunately there's some dead victims that, we don't want to put them in the same place as the people that need to be saved, so we put them in the red bucket. So you see the robots actually are this round's just getting started again. And so they've just attempted to go through and actually get go into that arena. They've obviously failed, but they'll try again as soon.
Yeah.
So, no, that's really what rescue is all about. It's actually creating, so for the roboticists, it's about line following, so actually following the line, but not in the original form where, you have light sensors. So if anyone's familiar with the NXT or EV3 and the Lego Mindstorms, you might see the light sensors to do line following and just bang, bang, follow the line. These sensors, and they sort of wiggle along. These robots actually use cameras. So they're actually they're using deep learning models to actually work out what's the best way to actually follow the line and actually get the optimal path to follow that line to actually get to their goal, to get to rescue their victims.
To rescue the victims. That's
Here
awesome.
they go again. So you can see that the robot is designed really to follow those lines, but also it's got a very boxy shape. It's like a big box because it has to be able to navigate around tight obstacles. So you can see that the yellow obstacle at the top, but also things like seesaws. So it actually has a tipping seesaw, and there's a ramp as well. So it's quite the challenge, but it's quite exciting to see when the robots go.
Definitely, I remember watching it, and I was doing the streaming, so I couldn't be partial.
There we go. You can see the ramp from here now.
It's impossible not to cheer up for the robot.
Most definitely. And I must say, the rescue committee, and they're all very busy working in there right now. They have some very interesting challenges. You can see this one. It's a zigzag. It's actually a line that's trying to trick the robot. But you can see, and it made it over. And now it's trying to go and keep following the line. Oh no, it misses it. And so it'll go back to what's called a checkpoint. So they don't have to, go all the way back to the start if they make a mistake.
Awesome.
They keep sort of going through and making their way across.
So where is the checkpoint that you said?
So the checkpoint are these orange little blocks they're basically like a little point that everyone's agreed is that this is the start of the next section of the program.
Like to the next level.
Yes,
right?
it is. It's basically like a maze, like a video game where you've got to get to the next level, and then you get on to the next level, and finally you get to the final challenge, which is that final rescue.
That rescue.
It's always very exciting to see how it all works.
awesome. And we are seeing some comments. I don't know if you noticed. And Jorge, he's probably Brazilian, and he wanted to see rescue, so that's why we are showing now and commenting. So people that are watching us for all over the world, you can comment in English if it's possible, right?
If possible, yes.
If possible, but we can work with the Spanish maybe.
We can work with. Well, the thing is, RoboCup is everywhere.
Everywhere, that's right.
And so we were just saying before coming on, there's so many languages involved in the RoboCup community. So RoboCup Junior in particular has over nearly 50 regions around the world. So we don't
That's
talk
awesome.
in countries, we're talking regions. But think of them like countries or areas that form a region, so that that they can actually join and have their own RoboCup community. So all around the world there are people doing RoboCup, and so many languages as well. So you know, every year our rules get translated into Japanese, German, Portuguese, Spanish, Chinese, every single, Slovakian, all different types of languages, and to the small ones, to French, all over the world, because there's so many people who recognize that robotics is important in schools, and particularly having some sort of challenge where that you can actually integrate it into the classroom or as a co-curricular activity, so people do it outside of their classrooms. And we also have a lot of students who actually do it as their final project for their high school.
Really?
So, yes, in their computer science courses or their engineering courses, so they can actually use it to graduate and then come into the wider RoboCup community as well, in terms of actually taking that next step of, once they've graduated, going on to the major leagues and doing the big rescue, and the soccer teams can keep doing soccer. So it's a wonderful progression from the junior, where they learn all the skills, and particularly for RoboCup is special because it's not just the technical skills of how to build a robot. But there's, we have teams of 2 to 4 students here. So actually getting them to work together, to project manage, to communicate, that's a big one, because you have to integrate both your hardware and how you design it mechanically and electrically, but also the software and the logic involved, and actually how to all do that.
The strategy,
the strategy as well. So
exactly.
There's a lot that goes into actually having RoboCup, and though I would always say that the people who do RoboCup come out to be some of the best engineers when they go to industry.
Definitely, and the best leaders as
most
well.
Definitely. And you can see that. We have RoboCuppers from all over the world who have gone into industry now, 25 years. Think of all the people who've been touched by RoboCup now working in Google and Amazon and Boston Dynamics and all your big robotics and technology, Amazon, all these different teams and students who have been able to do RoboCup that are now out in industry, and being able to showcase where they got started to the world. And we can, they might be watching here and go, I remember when I was a student doing that challenge. It might look slightly different, but I certainly remember it back in the day.
I mean, still following the line.
Still following the line. Oh, this one's a very tricky challenge.
I can't even imagine it. Like,
so
the robot needs to be...
Yes, it has to actually sort of line follow. Oh, look, they're trying to catch it so it doesn't fall. Oh, there it goes. Near safe. I always say that robots should be able to be drop tested. You don't want you want to make sure that your robot can fall from a...
Can fall.
You don't want it to be delicate enough to just break at the if it falls down a little bit, but certainly this one's a very tricky course. I will have to have a talk to the rescue committee. They're being very challenging today with their robots, but these are the best in the world. They are quite the amazing robots. So
I think the level of how challenging it is, it only shows how good these teams are, and
Most
how
definitely.
and how brilliant the solutions and the robots are. Do you know?
And this is really the top, because RoboCup isn't just for these, international teams that are working at this. This is the top teams in the world. But what we also offer is entry league. So for teams to actually get to this stage, so if they're younger, so we have two divisions that really work as. So these competitors are between the ages of 14 and 19 years old. But we also offer competitions for those who are younger, so under 14, so they can actually work up to this international level. So we have our international competition, which is our yearly event as part of RoboCup, the international RoboCup. But we also have super regional competitions, so that they can actually have the juniors and the senior students can actually have more opportunities to work to go internationally
to be
in
here
their
today,
regions.
right?
Yes, and then also in our regions as well. So like Brazil, like Australia, where they have the opportunity to compete and actually get to the chance where they can be at this international level. So it's all about actually getting all the students from that first idea of how can I be part of robotics and take this as a career and have some play. I always say the best, or every single RoboCupper. Now, did you like playing with Lego as a child?
Yes,
Every
definitely.
single RoboCupper loves to play with Lego. So if you
Yeah.
are someone watching who loves playing with Lego and building things, it's a perfect start for getting into RoboCup.
Yeah, definitely. I totally agree with you. And now we are seeing the soccer.
Yes, so
right?
this is our
And
soccer.
This is I think the robot reminds me of SSL.
Yes.
You know?
Mm-hmm. So our RoboCup Soccer League is actually, there's two different sub-leagues associated with
Really?
RoboCup Soccer. Yes. So here we're actually seeing our open competition. So we have two types of balls that work with RoboCup Junior. Firstly is our lightweight league, which uses an IR ball. So basically, the sensors that are in your TV remote, they emit a light called infrared light.
Yeah.
We can't see it, but the robots can. So they can actually track the ball by actually sensing that light. We can't see it, but they can.
But they
so that's
can.
the bigger ball that we might see later from the scenes inside. But this one is our open competition. So this is our so these robots actually see the orange golf ball, just like small size league. And they have, they actually use vision. So they use cameras, like we
Really?
use our eyes, to actually see the ball. So they can actually see it. That orange golf ball is basically the ball that they play with. So it's very exciting to see. Hopefully we get some games soon. They're getting ready for their games, but it's quite exciting to see how they're actually planning and getting ready for their competitions.
And as you said, you are representing the junior league, and I want to know how is the vibe of the participants. Like, this can be very stressful for them. Like, it's too much. They are under pressure. They are nervous, but I want to know if they are having fun as well.
Oh, most definitely. I mean, RoboCup is so special because, robotics is such a special activity.
Yeah.
You put so much effort into actually building your robots and getting them all ready. And because they're autonomous, because they don't have any human involvement, you have no idea. You can hope for the best that they will do what they've been told to do.
Yeah,
but
exactly.
you have no idea if they're actually going to do that. So really, RoboCup is it's the combination of, the regional to the national to the international competition, that they've grown these robots from idea all the way to an actual robot. And so really, the first 2 days, they're a bit nervous, a bit stressed. There's not much sleep involved in RoboCup.
Yes, and in a new country,
in a new country,
culture.
You know, a lot of the participants have travelled a long way to get here.
Definitely.
Especially the Australians, I should know.
Yeah, definitely.
But certainly they've had they're having the journey of a lifetime. But even if the robots don't work, and unfortunately, you know, even my robots didn't work perfectly on competition day, but certainly they've had the experience and seeing other teams from around the world and how they do things. Because they learn from each other. So RoboCup Junior is really special because we actually force the teams to work together. So we have a concept called super teams.
Oh, yeah.
So that's going to happen late in the week. So spoiler alert for later in the week. But they actually have to work together. So they have robots that they, rather than having each of them playing against each other, they have to work with each other. And it's a really great learning opportunity to actually get them to speak, to learn, and you make friendships that last forever around the world. So it's amazing to see actually how you can see they're all congratulating each other, you know, the good shaking hands after a game, because
this is so awesome.
They have that sportsmanship, and it's so nice to see them learning from each other. And that's what RoboCup Junior is all about. It's that learning opportunity. It's that competitive learning.
Yeah,
there's
that's really
some
awesome.
Fun to it. You know, there's I recognize these.
Really? They're Brazilian.
Yes, this team's a Brazilian team.
And one thing that I think it's awesome, like how they really put effort on communicating, like inside the team, because as we said, sometimes no sleeping, so stressful situation, but they all with a smile on their faces.
Most definitely.
Yeah, and how they communicate with another person, like maybe they don't know their languages, but you will see they will be friends, you know.
They most definitely will be. And communication isn't just those who are communicating between the teams, but also the really important part of RoboCup as well is actually the documentations, that learning. So we have the teams that actually create technical documentation associated with their robots,
like articles.
So we have what's called a technical description paper, which is basically like a little document that goes through and describes exactly what the robot is, how they built it, and then they also make a poster. So later in the week as well, we're going to have a poster presentation, and every team has created a A1 poster of their explaining their robots. So something that the general public can actually go and see, and that the other teams can learn from each other and see what it's all about. So RoboCup Junior is all about that innovation of actually taking the latest technology that you can find randomly on the internet and saying, it could work for this, new purpose, or
let's try
it out. Yeah. Because, the researchers downstairs, they're very constricted by, they've got their research to do, and they, finding new sensors, they're very expensive. But Junior really is a playground where you can just try out what sort of sensors should work. We've got teams that are using technology that's only really came out onto the market 6 to 8 months ago, and they're already here bringing and demonstrating how this technology could change the RoboCup and how we could actually build the community and build different aspects of it. It's amazing to see.
It's amazing, yes. And I would like to tell me more about how many teams do we have in each junior league.
So our RoboCup leagues, we have we've looked at Rescue Line at the moment.
Yeah.
So we have I think it's about 25 teams represented here. So 25 for that. We also have Rescue Maze as well, which is solving a maze. I don't know if we'll see that later on as well. But our Rescue Maze, and then there's about another 20 teams, and then we also have our Simulation League as well, which is actually doing the simulation of what you saw of the robot. So using that to actually build the to build robots virtually to test out new ideas of how to solve mazes. And then, so there's about 15 teams, I think, for that one as well. And then we also have, for our soccer leagues, we've got our two leagues.
Yeah.
And we have about 25 teams represented here. But that's just a very small number of our participants. So unfortunately, some couldn't travel this year because, which was very sad because we'd love to welcome everyone to come to RoboCup and to come here especially because it's so unique to come here. To South America especially, but certainly we've got a great representation from all over the world. So I think we've got about 40 different regions represented, across RoboCup Junior at the international level, and probably about I'd say about 35 of those represented here. So
that's
all
really
over
awesome.
the world.
Yes, that's really awesome. And now we are seeing the soccer, right?
Ah, yes, they're going.
They are. Can you explain me, because I'm seeing two robots? Can you explain a little bit more about the rules of it?
Yes.
Maybe faults, penalties.
Most definitely.
How does it work?
Well, I was actually refereeing these games this morning,
so I think you might know.
I might know a little bit about what's going on. So basically, we have like a game of soccer. We have 10-minute halves with a 5-minute break in between, and the teams they come to the field and they choose via a coin toss sort of situation who's going to get the kick off to actually kick off the game, and which side you're going to go for. So it's very much like a proper soccer game.
Yeah.
And then the robots, they actually have which is new this year, a special it's what we call a communication module on them. So rather than the teams actually needing to start their robots, we give them a little it's a little PCB. So it's a little electronic device which they put on their robots, which actually allows us as the referee to start and stop their robots. So we have an app that our wonderful soccer committee has created so that we can actually start and stop the robots and actually control how they work in the field so that we can quickly stop and start the robots, because the last thing you want is for the robots to be going crazy and you have to try and catch them. So that's a really big innovation for this year that we're really excited to bring and to showcase for the first time here for our competitors. So what's happening so you can see the ball starts in the middle and they get ready to have the kickoff and where they're going to start. And then there's two robots in the field. Seems like one of them's damaged at the moment. But basically, it's a game of soccer. And there are certain rules. You can't... there's the white line, so that's a penalty area. So you can't go into the penalty area. So you can see the robots all stop. Oh, let's tell our volunteers to get our referees to get out of the way so we can see. Hopefully someone inside is watching who can tell them to get
Tell them, let me just, I will need to use the Portuguese here.
Most definitely.
Gente, por favor, se alguém da produção conseguir pedir pra moça, não sei se ela pode dar licença ou mudar a câmera para que a gente possa assistir. Okay, they will ask them.
Perfect.
Just use my Portuguese now.
Excellent. Well, we won't disrupt the referees because they're doing a very important job.
Yeah,
but
definitely.
Hopefully we can see a little bit more of the gameplay, because it's really exciting when the robots actually go, because they can't go into the penalty areas.
Yeah.
But they actually control the ball, so they have dribblers, so they're able to dribble the ball really fast. So what they do is they have a bar that spins and actually sucks in the ball, so it actually spins really quickly, so they can actually capture the ball and actually move with it to different parts of the field. So we've got a different angle here. How wonderful. So you can actually see the robots going around. So
they're very fast.
They are. So what they are is these are called omnidirectional robots. So they omni, meaning many, omnidirectional, many directions. So that's why they actually have 4 motors and they're actually at set angles so that actually you can actually move in any direction. So that the algorithms that the teams have written actually allow them to go to the ball. So they chase the ball. So you'll see definitely when they're about to, I think they're about to actually start a game. This is very exciting to see. We'll get to see the start of a game. But they'll actually go through and they'll go and chase the balls. They're just testing their communication modules right now. But to actually go through, and they have different parts, including they've got their dribblers, but they've also got kickers as well. So they have using things like it's a technology called solenoids. So a solenoid is basically a very quick release. So it's basically a sharp motion, that a rod that actually spits out and can kick the ball. So they actually can kick. They can actually score goals from the very other end of the field and bang into the opposite goal. It's quite exciting to watch. So that's one of the different challenges. So they've got the dribblers, they've got the kickers, but a lot of different robots, they don't have any, so unlike things like the small size league where they have the overhead cameras, you would have heard all about.
Another type of communication.
Yes. These robots actually see everything from on the actual robot. So the robot that's closest to us, that is actually using a technology called a catadioptric omnidirectional camera. So instead of the actual camera facing forward, it actually points straight up. And it's a mirror, so you can see it's a clear tunnel, and at the top is actually a mirror that actually provides a 360-degree view. So you can see they're actually programming it now, so they can actually see all around the robot. So they can see the ball wherever it is on the field. It's quite amazing to see how they actually can be using such a simple thing as a mirror they can actually design to see certain areas. That's what they can do with these robots now.
I'm speechless again. Like, that's really awesome. And they are high school students?
And these are all high school students.
I'm just speechless because this is so special. Like, we really need this. And as you said, I just saw the women smiling.
Yes.
You know, this is so important. Like, they're having fun. And I think this is the most important thing. So probably had a little bit of issue, or do you think it's just calibrating the robot?
I think they're just finished their game, and they're going through and going through and seeing what worked, what didn't work. You know, doing a bit of a debrief. Because these soccer robots, they are very temperamental. You know, they have their off games, just like soccer players. You know, they have their off days. They get injured. These robots get injured too. So you can see that they do a lot of testing and actually going through and seeing how can they improve what's going on. So you can see there's another robot that's just come on, so they have to have a handle on top of their robot. So when we're refereeing, we can catch the robot.
So this is something that this is in the rules. Robots must have
a handle. Because you don't want to accidentally pull out a wire from when a robot is spinning around in circles. You want to be able to grab it quickly. So certainly it's quite interesting to see when they go spinning off and you can just have to go catch them and then pass them back to the team for them to go make sure it doesn't do that again.
Stop it.
Stop it. And
take a deep breath. Let's try again.
Take it a minute off. They go out of bounds. It's called it's called out of bounds, and they get damaged. And it's basically like in soccer where you've got the sin bin.
Yeah.
But our sin bin is a minute. So they have to go off the field for a minute, and then they wait, and then they can change the program or debrief and think about what's going on, and then go back on the field and try again and hopefully score that goal
in a minute. So just to clarify, The participants can change the hardware or programming once the game started.
Most definitely. So all that what happens is on the field. So it's really quite exciting to see when you they can, some sensor might be slightly broken, or the one that I always like is when I like, because I understand their pain, was when you accidentally put something like one number wrong in your program, and then you go, aha, I can fix that, and you quickly type in there and upload the program, and then you get it all sorted, and then it just works. And
Perfectly
it's beautiful to see
fine.
when it just works perfectly.
Yes, I mean it's very hard to see and not cheer up. Like we are back in the rescue line, right? The rescue league. I'm so sorry. And can you explain me a little bit more of like this robot?
Yes, we're actually doing the final rescue at the moment. So
Oh, really?
Yes, this is the area where we were talking about trying to find the ball. So I think it has just dropped a ball into the final area. So
And I don't see any victims. So maybe.
no, so maybe they actually got them all. So you can see here they actually dropped. We may have just missed it, but they actually dropped a rescue, hopefully a live one, in the alive green bucket.
But I just got curious. I'm sorry.
Oh, yes.
We have an obstacle
Yes.
in the rescue part. Like how this works.
Well, think about a disaster zone.
Yeah.
You don't know where you are. You don't know what's there. There could be, think about all the natural disasters that we've had recently where people have been having to pull debris and big blocks of building rubble away to actually find and rescue people. So the same thing here is the big obstacle in the actual final arena.
Yeah.
So it becomes an extra challenge because the teams can't have to avoid it to actually find the victims around it, and because they're using vision to actually try and find it, there could be a victim hidden behind it that they might miss.
Yeah.
So it's really important for them to actually be able to investigate and see this whole area. So you can see they're trying. Oh, is that a ball there?
Yeah.
I think it is.
We have
oh,
two
here we go.
victims in there.
Here we go.
This is so.
It picked it up.
Oh my god. Oh
There
my
we go.
god.
Yes, it's a live one.
It's a live one, and I think it's just preparing to go to the green. Oh.
Oh, is it going to find some other?
Yeah.
So they often look around for other victims while they're in an area. But also you can see it's very hard to see, but on the actual floor as well, there are white obstacles. So there's little like speed bumps that the robot has to navigate around. Oh, it's found the arena. Is it going to?
No.
No. They're alive.
Okay.
They're alive. Okay.
Oh.
Oh, volunteer. Okay. Okay. It's going and searching again for the green bucket, I think.
Yes.
We have to hope. Let's all hope that it actually finds the green bucket.
The green bucket. So you.
Here it goes.
Okay, I think it will.
Thank you, volunteers.
Oh, they're trying to find the best.
The best angle to watch.
Angle, yeah.
Oh, we're moving so that obstacle is free. So it can move anywhere. So
Oh, that's awesome, because we have some obstacles that are not free, right?
No, yes. So
that
like
you
the speed
cannot
bumps.
move.
Yes, you can't move.
But that one.
Yep, that one can move, so it can go anywhere. Oh, I think they ran out of time.
But they did great.
They did do really, really well, because it was really interesting to see how, it wasn't the first time that they went. They didn't get the final rescue, but they came back into the area and tried again. So they get 8 minutes to solve each one of these mazes. So they start at this entry point, which is in the top corner, and then they come all the way through, do the final rescue, but also they sometimes can actually do more they might have an exit point. So that red line the red line is actually the exit. So that's like the evacuation pad or the helicopter pad where they can then go and be free and take their robot can survive this situation. They've done their job and they've rescued their victims, and then they can go back and actually escape from that red line point. So they start at one end, they go through and do the rescue, and then they get right to the end. So I would like to point out for our audience especially those who are going, this looks really hard. I would like to point out that this is our international competition. So if you search up RoboCup, our courses, these ones are the tricky ones. So these ones, especially at the national and at the super regional level, the standard is a little bit lower, so we make a little bit easier courses. So there's a lot of challenges associated with this one. So
definitely,
this is the top level.
The top level, like it's the best of all countries, right?
Most
all
definitely.
around the world. And now this ball looks different.
Yes, so this is the ball that I was talking about, the one that has the TV sensors in it. So this is our infrared ball.
No way.
So we won't be able to see it, but actually sometimes when you look at your mobile phone, say in a mirror, you might see a purple light that flashes.
Yeah, that flashes.
That's the light.
Really?
That's the light that these balls actually that's the light that you can see. So we see it when we take a photo of it, but that's the light that these balls are emitting. So they glow when you actually put them under a camera. So you use your phone.
You can see it.
If you have a phone with a sensor, you can actually see that light that comes out of the balls.
So awesome.
Especially if you turn out the lights as well. So these robots actually are more of so they don't have as much software in terms of actually being able to see the balls, but they do have cameras as well to see the goals. So they know which goal to go for, because we have a blue goal and we also have a yellow goal as well. So
each team
has
a color to follow, right?
To follow. And then they swap at half time as well, just like in a normal football game.
Really?
So they swap at half
and
time.
Switch up?
Yes.
That's so interesting.
So this is actually our final year at the international level of using these the big balls, so the ones that you see, because we're actually going to a very special new ball that our community has developed. So our soccer community, so our committee members, and also the community have built a new open source ball, so you can make it as 3D printed that you can make your own soccer ball at home, or you can buy them as well. To actually make, and rather than being that dark grey color, it's orange, so that you can actually play both with a robot that's in the open division that has a color. But also you can see it using that infrared light. So we're actually going to be able to play junior lightweight versus junior open games in the future. But not only that, we have a special... This is actually a spoiler. I shouldn't be spoiling all these events of the future in the week. But
I think you should. You must. Okay.
Well, we're going to actually have a very special challenge because, as you can see, we have the best junior competitors in the world here.
Definitely.
The best.
The best.
The best. So, what happens when we put them against their major competitor robots? The major...
Like the high school students?
The high school students versus, what was the similar league that you noted? The small size league robots. So...
No way.
So probably something to really... If you're going to watch anything, and I mean anything, out of this entire live stream, this is what you should be coming to. And I think I'll be back to commentate the match, so I'm really excited.
Please.
Is actually our junior soccer versus small size league technical challenge. So this is actually a challenge for the majors to be able to convert their robots to play against the junior teams. And the junior teams actually put the markers on top of their robots so that they can see.
They can see.
So they can play against each
This
other.
is so smart.
So it's very much because these are high school students.
Yeah.
They're about to go out into the world of university. But they don't want to stop doing RoboCup.
No.
They want to go and actually be able to continue doing what they've been doing at high school, at
Year after
university,
year.
after year, and doing their bachelors and then doing...
Yeah.
and that's when they go and join their RoboCup team at their university, or they choose their university based on what RoboCup team is available. That's
Yeah.
a big one. You know, we've got a lot of competitors who actually go from, I've done junior, I've done RoboCup, but I want to continue, so I'm going to go and do my engineering or my computer science degree, or even just another degree completely with the skills that they've learned by doing RoboCup,
definitely.
and actually go and do and join their teams or choose their universities based on that. So we grow our RoboCup community to actually be such a wide group of people who give so many different opportunities.
Yeah.
But also those who don't get that opportunity to do RoboCup at their universities, they actually come back and volunteer with us. So we
that's
actually
awesome.
have a group of about 35 volunteers who have actually travelled from around the world just to come and help us run RoboCup.
Really?
Because RoboCup is
That's
really
awesome.
special
Yeah.
because you know, with the majors teams, they can use adults to the team members. They're the ones that can run the competition. But RoboCup Junior, we can't ask the students to run the competition.
Yeah.
Would they be very fair? So we actually have a really big RoboCup community of ex-competitors, but also those who didn't get to compete in RoboCup that still love robotics
And want to help and want to
help
live
out.
this and want to be here.
Exactly. As well as a large group from Brazil. We've got such lovely
Yeah.
local volunteers as well who are ex-competitors who are giving up their time to actually build RoboCup and
Yeah.
to judge and to referee.
We have this year 700 volunteers.
Gosh, and we have a small selection of those actually helping us to actually run the competition, and they're a lovely group. And so, even if you see this and you will go, "Oh, I can't do RoboCup," you know, I'm at university, but we welcome and we do a call every year around the world. Come join RoboCup and come and we can't pay for you to be there, but if you want to go somewhere new on a holiday,
it's an experience,
and it's
like
such an experience,
such a great experience. Like everything with everyone I am talking to, it's amazing to know new people,
most definitely,
new cultures, and to help to run this amazing event.
It is such an amazing event, and our volunteers really are the champions of RoboCup, because they're the ones that actually could do RoboCup in the future, but also really are the ones that can, see and actually build on their own skills. So to get internships, to get jobs.
Yeah, definitely.
Think about how many opportunities, everyone who's doing a computer science degree or an engineering degree, they have
or
to
maybe
work
artificial intelligence
artificial
degree.
intelligence. They all need to work out in industry, and to have that. RoboCup has, especially now that we're growing through using things like our live stream, like our social media, which has been amazing, by the way. It's amazing to be here and have these, to be able to give these interviews. So it's amazing to be able to do this with you. Is to actually showcase, RoboCup is that challenge where you can learn and grow and actually go out into industry and be useful, because there's so many skills that RoboCuppers have. So that you can actually go anywhere. And they're the best problem solvers, and they're the best
leaders.
The best leaders, and they write good documentation, and they can communicate. They can tell you about what they're doing.
Yeah.
I always encourage anyone to go and talk to the teams about what they're doing and why did they choose what they chose to do. And then they can actually go through and actually see, oh, I could do that. Or, it looks so complicated, but it's actually really interesting. And that's across all of Junior. And I welcome anyone to come and look in our social media, but also our RoboCup Junior website. So we actually... We've just done a big revival of this website.
And it's so pretty.
That's been my job
really?
for this year.
Okay, you did a great job.
Many late nights, but to grow RoboCup. So if you're interested in being involved, it's robocupjunior.org. And you can learn all about RoboCup and how you could join and be part of this wonderful community. So it's amazing to see, and it's been such a great experience to be able to do it in schools, to actually see, and if you're a teacher, and teachers love RoboCup as well,
definitely,
so that they can actually have some sort of goal at the end of their computer science course. So I encourage anyone who was interested in being involved in RoboCup to definitely check us out.
Yeah, definitely.
Our RoboCup 2025 website, but also our RoboCup Junior website as well.
Yeah, definitely. So with I thank you very much. Okay, it was a really great interview. I mean, I just learned it a lot, and as you said, anyone who has a sort of interest or maybe is curious about it, you need to check the site or to watch the live. I promise you, it's very, very interesting. So I thank you so much for your participation.
That's right.
And now we are going to see, I'm going to invite another guest, and we're going to see the SPL, so Standard Platform League. Do you like it?
I do, because they're the really funny robots.
Yes,
the ones
definitely.
They are getting much, I must say, they are getting much better at kicking the ball and not falling over.
You're definitely
There's one
right.
video to watch. It's the RoboCup blooper reel of the humanoid robots.
Oh, okay.
It's a very funny one.
Very funny
so
one.
definitely search it up on YouTube. It's a good video to watch.
Thank you so
That's
much for your
right.
participation.
Thank you.
Yeah, SPL, right? Thank you so much for your participation. Okay.
That's right.
We will go back in minutes. Bye bye.
Bye.
Hi guys, we're back streaming the Standard Platform League with Josiah. Can you present yourself, please?
Yeah, hi, my name is Josiah Hanna. I'm the team leader of the Wistex United SPL team. I'm also a professor at the University of Wisconsin. The Wistex United is a joint team between University of Wisconsin and University of Texas at Austin in the United States. And I'm also on the executive committee of the Standard Platform League.
Okay. Oh, actually, they're playing right now. Can you say a bit about your league?
Yeah, so the main feature of the Standard Platform League is that you're going to see everybody is using the same robot. So we're using the Aldebaran Now robot, and what this means is that every robot is kind of equal to each other in terms of its physical capabilities. It sees the world the same, it has the same cameras, the same sensors, and it moves in the same way. It's got the same actuators, along the parts of its body. And what that really means is this competition is about who can program the robot the best. It's about the artificial intelligence which is driving the robot, and that's what this competition is about.
Right. We can see them playing. Do you know who are those teams?
Yeah, so on this team in the green we have Robo Irene, which is from Ireland, and then we have HDWK from the University of Leipzig in Germany here in the blue. There.
Yeah, you're from a team, right?
Yes, yes. I'm from the only U.S. team here, Wistex United.
Okay.
Yeah.
So, can you explain to us what's happening there?
Yeah, so right now it's we've had kickoff has happened and they're fighting for the ball in the middle there. These are two really good teams. They've been placing highly in the competition regularly. So you can see they're all kind of the ball's caught in a scrum, as it often is in these games, and they're just trying to push through and somehow clear it through all of that to get a clear shot on goal. The HDWK team, they do a lot of, really trying to just slowly and steadily advance the ball through dribbling. You often don't see a lot of real long kicks from them. The Irish team tends to do a bit more of that long kicking if they can just get it out of the scrum.
Get it. Fantastic. Oh, what did happen?
So throughout the game, there's different, penalties, just like there are in, in regular soccer. So, and robots can be taken off the field for a number of reasons. Whoa, yeah. All right. How about that? Yeah, it was a good shot.
It was beautiful.
Yes, very nice. So that was but what we saw just before that was the robot was penalized for, I think, pushing, which happens, and so removed from play. Yeah.
One question: in regular soccer, we do have positions for people. Is it also like this for robots?
Yeah, so I mean, there's a goalie that on each team. They also there's going to be some type of coordination. Like you don't want your whole team going for the ball at the same time. So some robots should go for the ball, others should take up positions strategically, and so yeah, they're playing different roles as they go.
So that means they are programmed differently.
Usually they each run the same code. Most teams do that, but then they kind of dynamically switch off what role they might be playing at any moment in time. So you kind of, you want the robot that's closest to the ball to go for the ball, but it's the same code being executed.
Amazing.
Yeah.
Amazing. And why is the category is called SPL Outdoor?
Right. So what we have here is the outdoor field in the competition. There's 4 other fields being played in another part of the convention center here. Now, it's not actually outside, but what it's really about is flooding the field with natural light because I guess not visible on the stream, but there's a lot of really large windows around us. And so that's letting in a lot of light. And even as for people, we're like, what's the big deal? But the robots are perceiving the world through cameras, and this really kind of changes the characteristics of the images they're seeing. And so it means you can't really rely on a lot of like color information in the image because what is green may look different with different lighting conditions. So this field is about kind of stress testing, how well they can see under different lighting conditions.
So the other category, which is not outdoor, they are more precise. Can we say it or no?
On the inside fields, that is, or
yeah, the inside fields.
Yeah, so in general on the inside fields, they're going to be able to see better. It's a more controlled condition, and so yeah, usually teams see that their best games are on the inside fields. Yeah.
And when did the competition started for SPL Outdoor?
Okay, yeah, so it's the SPL competition has been around for a long time, since close to the beginning of RoboCup. It used to be that they used the Sony Aibo robot, which was a dog-like robot. So, of course, it looks very different than this, but, kind of the same thing. Everyone uses the same platform. We focus on the artificial intelligence aspect. Now, there is the evolution of the league to the Now robot, which is obviously a much better, kind of more realistic choice, more like real soccer because it's played on 2 legs, just like people do. And so it's been with the Now robot for the past 17 years.
And I'm seeing, I saw this one, the hands were with tape.
Right, the hands behind its back, as it's walking. Yeah, so they do this walk with their hands behind the back a lot to kind of avoid pushing each other sometimes. Now some teams do that. They just do it all the time. They walk with their hands behind their back. Other teams kind of do it more dynamically. When they come close to another robot, they put their hands back there just to avoid accidentally pushing someone.
But is it okay to use the tape?
Yeah, I think the tape is to keep the robot's wrist steady. There's a little joint they can spin their wrist just like this, but that's not very useful in soccer, and so it just adds some stability to take that.
Right. And here, is it the first competition?
This is our first day of competition here. So we've had some games this morning, but now, this will be continuing into the evening. Yeah.
And along the rest of the days until the end of the competition, we're gonna have competitions every day.
Right, that's right. So we're doing it's a Swiss-style tournament where teams try to play each other and figure out who the best of all the teams is, and then at the end we'll have an elimination round. Starting with the quarterfinals, semifinals, and the finals.
Oh,
yeah,
amazing! How many teams we have? Do we have?
We have so there's 12 teams that made the trip to Brazil this year. Yeah.
Where are they from?
Yeah, so from all over the world. So we have, there's a U.S. team that I'm on. There's a Canadian team. And there's several German teams. The competition's very popular among German universities. Yeah, that looks like it hurt. There's a couple of Australian teams, and yeah, so from really all over the world.
Amazing.
Yeah.
It's fantastic to have all you guys here.
Yeah, it's great to be in Brazil. This has been a really nice place to, such a country that loves soccer so much, and
Thank you.
it's great to be here.
We see many robots falling. Is it
Yes.
normal? Is it a problem? Is that anything that cannot happen, like falling and staying there for some seconds?
Yeah, it's definitely something teams try to avoid. Of course, soccer is it's a rough game, and there's contact. Different robots wear down at different rates, so sometimes they become less stable walkers as the robots get older. Just like happened there as they went down. But teams generally try to keep the robots upright. That's really the best strategy.
Right. How many robots do you have each team in the field?
We've got teams of 5 robots. Now the elimination rounds are going to be played with teams of 7 robots. So one of the real exciting things about the standard platform league is that it's the league in RoboCup that plays with like the most humanoid robots on each side. So it's kind of the one which is trying to get as close as possible to actual human soccer.
Yeah. And it's even
He pulled him down.
But they get up faster than human.
Yeah, they don't lay around and ask the referee for anything. Yeah.
That's interesting. Right. How long does it take? Does the game take?
Right. So we're in the first. Actually, we just came to the end of the first half. There was a 10-minute half. We're going to have a 10-minute break and then another 10-minute half after that. It's kind of one of the challenges is making sure that your robots can play for the whole game. Now they don't get tired, but their joints can get a little worse as the game goes on. So they walk. They're more likely to fall over. They kick less precisely.
Interesting.
And you also have to manage battery power of them. So. The teams are going to grab up their robots right now. They're going to try to get them sitting down to take stress off their joints, and they're going to plug them in to make sure they have battery for the next half.
Right. Which makes me think about substitution. Like,
yes.
How does it work?
Yeah, teams can substitute robots. It's not a part of the main gameplay the way it is in human soccer, but certainly if a team has enough robots at the half, they might decide to just put in a new set to give fresh robots. Yeah.
Yeah, and they're with the same code, so they work the same.
Yes. Yeah.
Oh,
that's a little different
great.
than subs with humans.
And is it usual to change robots?
Yeah, different teams would do it. I think we tend not to. I think the newer robots tend to last, I think, for most of it. So it's not critical to change them. I think they do tend to work a little better if you do make a change. But yeah.
Got it. I saw if we walk around the event, especially the close to the desks of teams, they're all charging.
Yeah.
It's great to see.
Yeah. Well, it's really unfortunate when the game's about to start and then your robot just powers off. So, teams are trying to make sure that doesn't happen.
Yeah. And does it take long to recharge a robot?
Probably to get up to full power, yeah, it can take some time to. But fortunately, I think teams just try to, a big part of doing well at the competition is not just programming the robot, but managing the logistics. Making sure your robots are ready to go, making sure you don't. If you're too quickly changing your code last minute, you might introduce a bug that causes everything to go wrong when the game begins. So.
Actually, I saw many of them. Like you told me that teams play with 5 or 7, but I saw I would say more than 10. Does it have a number to bring to the competition, something like that?
Yeah, it's that's one thing where the number of robots a team brings depends on just how many they've purchased, really, and how many they're able to bring. Usually, teams travel with these in their checked bags on airlines. So, it's how many people you're sending. Are you able to send as many as possible? Yeah.
What's the main challenge of programming the robot?
There are so many really just like kind of fascinating artificial intelligence challenges with these robots. Yeah, I mean, it's like, how do you get? Some of this I think will be kind of obvious from watching it. You've got to, how do you get them to walk? How do you get them to kick? The motion control. How do you get them to perceive the world? For like just the computer vision problem. Like a camera just gives the robot a bunch of numbers telling it the light in the world, and it has to say, well, that corresponds to there being a ball there. So, and they have to do this really in real time, right? They're not just like, it's not just like a single computer image that you can process one time, but it's got to do it rapidly as the world changes. One thing which is maybe less appreciated by people is that they have to do what we call localize, which is that they have to identify where am I on the soccer field and kind of maintain a belief about where the ball is. And this is actually like a pretty hard robotics problem. I think people are really good at it, and so we take the ability to do it for granted. And then they've got to coordinate with one another. They have to know how to communicate over a noisy... They communicate wirelessly with one another, but oftentimes in these competition venues, the packets, the wireless traffic drops out. It's like not a good connection. So then you don't even know if like what one robot told another robot actually makes it to that robot, and then but overall the thing is like there's more challenges. I could keep going on and on about the research problems, but it's doing all of these things together. It's not just trying to like solve one research problem by itself. It's like, how do you build a complete system where like one robot is doing all of these things and they all work well together?
Is it usual to fix something and break another thing?
Absolutely. Yeah, I know just from working on this competition for a long time. Like even when I was in graduate school, I worked on it, and I did a lot of work on the motion control of the robots, and maybe we make the robot walk differently, and that's going to make the head jitter around, which makes the camera images more blurry. And then the people working on vision are like, no, you're breaking my stuff. And so, and that's I think one thing which makes it really fun is it is about building that whole system where it's not just like the best individual piece. It's like the sum of all the parts.
Great, amazing. They're really, really interesting how they work. When did you started to work with that, and why?
Yeah, I think it's that kind of last thing that I'm talking about is that there's a lot of work in artificial intelligence gets kind of, you just like break it up and you focus on some isolated problem, but and then kind of assume if everyone can do that, like divide and conquer, that'll solve the problem, and we'll have really capable robots that we can put out there in the world to help people in all sorts of ways. But I think that's really, you have to think about the integration problem, like how do all these different pieces fit together? And so, RoboCup is one of the kind of few, really big research platforms and competitions worldwide, which I think forces people to think about that integration piece, which is critical for getting robots, out of controlled factories and out of the lab and into our daily lives.
Great. What about the connection, like the team? Is it harder to the robot deal with its own team or with the other team?
Yeah, it's it's really fun that there's like both robots that are out there on the field that are cooperating with each other as well as trying to oppose each other. It's an adversarial problem. It's generally, of course, easier to deal with your teammates because you tend to know a bit better where they are. Yeah. They communicate with each other, so they they're saying like, okay, I'm here, and so at least you have like a better sense of like where they all are. Whereas with your opponents, you kind of are completely relying on your cameras to detect them. And I think in this competition, like the ability of the robots to detect each other through the computer vision is still kind of limited. And so you often are a bit more uncertain about robots that aren't on your team where they are. Not to mention, of course, that they're trying to, to stop you. So.
Got it. And what are the advantages of everyone using the same robot?
Yeah, so really the advantage is about we want to kind of focus the research that teams are doing on advancing the artificial intelligence and not it's given that we're going to all use the same platform, how do we make it as smart as possible for the purpose of playing soccer? There's another league, like the Humanoid League, where they actually build hardware. But then, it's the question is, well, if one team beats another, maybe it's because they just built a faster robot, right? It doesn't have to be very smart if it's 4 times as fast as your robot, right? Whereas when you constrain them and you say all of them are going to be the same robot, so generally teams can, walk as fast as one another, then you start thinking about, okay, well, if I'm going to beat my opponent, my robots had better pass better, better work together better.
Yeah. And one last question. What you said a bit about AI. What does the AI we know, the models we know, has to do with these robots? Are we talking about the same AI or nothing? It has nothing to do.
Yeah, it's very related in many ways. I think what's really popular right now when people talk about AI, and particularly Gen AI, is large language models. So there's not a lot of work of using large language models on these robots. I'm talking AI kind of in a broader sense of AI is anything that when we're working on programming a computer to do things which if a person could do them, we'd say that person was intelligent,
Yeah.
So that's the sense that I mean AI. Now, at the kind of cutting edge of research done by standard platform league teams, we are thinking about the same techniques, things like reinforcement learning, deep learning. These are the same cutting edge techniques which enable ChatGPT to work. They're also, teams are using them and they're saying, well, how can our robots, we don't just program them to play soccer, but we allow them to learn to play soccer. And certainly deep learning is a big part of how they perceive the world through computer vision.
Thank you. So thank you so much. We got to the end of the interview. I think we talked a lot. Thank you.
Yeah, thank you for having me. It's been great to chat about all of this. Yeah.
Yeah, so you guys can see, you can come here to Salvador too, if you're here, right?
Yeah.
And see it live. It's the field which we are seeing is actually by our side.
Yeah.
So it's really great to see. And thank you. Now we're calling Humanoid Kid Size, and we're gonna have another guest here. Thank you.
Right. Thank you.
And you're standing on the edge, face up, cause you're a natural. I'm feeling hard as stone. You gotta be strong to make it. Yeah, you're a natural. Living your life, bro. You gotta be so strong. Yeah, you're a natural.
Toda ideia nasce pequena. Em uma sala silenciosa, num papel rabiscado, num sonho entre colegas. Assim nasceu o CEIA. Não como estrutura, mas como desejo. Desejo de transformar ideias em impacto, ciência em solução, tecnologia em futuro. Em 5 anos, fomos muito além do que imaginamos. Criamos tecnologias, formamos talentos, aproximamos empresas e universidades. O futuro já começou. Ele está nas ideias que ainda nem surgiram, nas conexões que ainda vão acontecer, nos desafios que estamos prontos para resolver. E se o passado nos trouxe até aqui, é porque nunca estivemos sozinhos. E o que vem pela frente? Mais ciência, mais impacto, mais gente. CEIA, 5 anos de inteligência que transforma.
A Petrobras é líder na transição energética justa.
Porque a nossa energia já nasceu para abastecer o país.
Uma transição energética justa tem que criar oportunidades para que todos se desenvolvam.
Justa para o meu corre. E abraçar novas formas de energia?
Também é transição energética justa. Ela tem que ser justa para todos.
Justa para cada brasileiro.
Justa para você.
Petrobras. O Brasil é a nossa energia.
Justa, nosso presente é uma energia justa para cada um dos brasileiros. Justa, essa energia é a gente que faz. Justa, porque é bom para todo mundo. Fazer melhor é fazer junto. A gente sempre pode fazer mais.
A transição energética justa é aquela que chega na vida de cada brasileiro, com menos emissões, com projetos sociais, ambientais e sempre pensando no desenvolvimento sustentável do país.
Justa, nosso presente é uma energia justa para o Brasil dos brasileiros. Justa, essa energia é a gente que faz.
A Petrobras é líder na transição energética justa. Justa para todos, justa para você.
Petrobras. O Brasil é a nossa energia.
Justa. And you're standing on the edge.
Hi guys, we're back here presenting the Humanoid Kid Size League, and we have a special guest. Can you present yourself, please?
Yes, I'm Julien Alali from the University of Bordeaux, Bordeaux INP, and I'm the team leader of Rodan teams.
Where are you guys from?
We are from Bordeaux, but in our league there is 17 countries that is represented, and that's it.
Amazing. Oh, you have 17 leagues.
No, 17 countries.
Yeah.
In 17 team. Yeah.
I'm sorry. And can you tell us a bit about your league?
Yeah, so in our league there is 4 robots that plays autonomously, so there is no human intervention on robots during the game. And in kid size, robots have to be less than 1 meter of height.
Can you tell us what are they doing right now? Is that a play?
Yeah, I think it's a game, and we are seeing a new kind of robots that are coming to our league. That is boosters, robotics robots. They are quite fast and strong.
How many robots are meant to be in this field for a competition?
Normally there is 4 robots per team, so 8 at all. And here we can see there is 1 robot which is supposed to be the kicker. He's waiting, yeah, now he's kicking the ball. Yeah. And the second one is going to be the goalkeeper, I think.
Great. Are them all the same robots?
No, each team have different robots, which is not actually true. There is 2 teams with a booster, but all other teams are making robots themselves. So there is mechatronic, electronic, and computer science skills involved in your league.
Okay. So the other robots, will they come to?
So these robots are commercial robots built by Booster Robotics, but all other teams have made them robots themselves.
Okay. And this guy, this guy in the middle.
The guy that holds the ball is the referee. So actually he's from my team.
Oh.
And he's applying the rules. So when there is a fault or a goal or something like that, the referee tell what happened. Someone is clicking on the computer, and the information go to the robots by wireless connection. So the robots are supposed to respond to them, and if they don't, there is a fault, and they go to outside the game. Yeah.
Got it.
So here there is a goal that has been marked, and so they come back to their side of the field. If they don't, there is a penalty. Yeah. So they shift their role. Yeah.
Oh, great. So are they different, like very different from SPL League?
Yes, in SPL it's now robots. We are really small and not too fast. And adult size is the third part of our league, and robots are bigger. And we can see now robots that start to run on the field. So it's become quite impressive. But these robots are going fast, and they are really stable and quite heavy. So when they fall on another robot, it can create injuries.
Oh.
Yeah, they are 20 kilograms, this one.
Oh.
So it's quite heavy for our league. Usually robots in our league are less than 10 kilograms. So
got it.
It's a new evolution. It's just this year that this kind of robots are coming, and maybe it will become something standard for the next year. We'll see.
Got it. This field, how are the standards of this field?
In kid size league, it's 6 meter per 9 meter. So it's not too.
I'm sorry
large.
to ask again.
Yeah?
I think I didn't listen too well. There are 4 robots each team.
4 per team. Yeah.
Why there's only 2 in this case?
Oh, in this case, because as you can see, there is no player on the other side. So probably the robots from the other team are out. So they are playing alone, and the team decide. You see, there is a third one on the floor, on the back, on the right. So they decide to put only 2 robots, but they can win with 1 robot, and that's a special condition. As the competition will go on, this kind of situation will not happen. There is a robot on each side of the field.
So are they playing alone?
Yeah.
So it's an actual play. They're not training.
No, it's an actual play. It's a match, but it's quite hard to see this. But, they will win. I think they will make more than 10 goals during this game. Probably 15.
Have you had many competitions since the start of RoboCup 2025?
If we have
many plays. Is it the first play?
No. There was a game all the morning, and this afternoon also, and about I think 10 games per day.
Oh,
Yeah.
and how long does the game take?
It's two times 10 minutes. Yeah.
Does
and
it have
after that, if there is equality, there is an extension and strike on goal at the end.
Oh, yeah. Does it have a break?
Yeah, we have 5 minutes between each half time.
When this category started, and when? Oh, when and where? Sorry.
When this the kid size start?
Yeah.
Oh, I don't know.
No.
I'm
No
I'm
problem.
only participate from 2016, so I don't know all the history of the.
Almost 10 years on. That's a lot. You participate, you code, right?
You?
You code.
Yeah,
You're
yeah,
responsible
yeah. This
for the
is a
program.
great part of the job is to code, to program, and mostly it's become. I think it will be the most important part of the game because on standard platform like that, a booster, which is robots you buy. You don't make mechanical parts. You don't make electronic parts. So at the end, what you do, it's programming. Programming to see the ball, to see some stuff on the field, to know where you are on the field. It's not so easy. If you put someone on the field, how we know where we are on the field is by catching some part of the goals and the marker, and we have to make that in the computer that is inside the robot. We have to see the ball, and after that we have to program the walk, the strike, the stand. To be able to participate to this league, you have to prove that you make some stuff like walking, stand up, striking, etc. If you don't do this, you can't participate to the league.
How the team wins the game? It's only about the goal.
Yeah, it's only about the goal.
Well, what about the hardware, the cameras, the sensors? How
Yeah,
are they? Are they?
This is one part I didn't mention yet, but it's important. Our robots have to be humanoid. So you can't make, LiDAR. LiDAR is a kind of stuff you find in Tesla, for example. And it's forbidden because humans don't have LiDAR, which is based on laser. We have some constraint about the foot size, the size of the foot. If you make big foot, it's not fair because you are stable and you can't do that. So there is a lot of rule like that, and the purpose is to be close to human because, as you know, I suppose, the main purpose of RoboCup is to have robot teams that play against human teams in 2050. So we change the rule each year to go to this direction.
Are you positive about this assumption?
Yeah, since this year I'm quite positive. We see robots, in particularly in adult size, which are really impressive, and I think it will go faster. The main issue is that these robots are in metal, and if they go in a human, it can be quite a mess.
Yeah.
So maybe this will be the major concern if we make a match with human at the end, is how to make it safe.
Yeah, how to manage it.
Yeah.
Right. What about the rules? You mentioned that the rules change every year.
Yeah.
What do we have this year? What changes?
Maybe there is few change in the rules every year in the game rules, because we in our kid size and adult size we try to be close to the FIFA rules. So everything we have is copy or inspired by FIFA rules, and we have to define how is a fault. If a robot go into another robot, is this a fault? If he plays the ball, no, it's not a fault. But if there is no ball, yes, it's a fault. You see, that's kind of rules we have to set up, and which is quite tricky to implement in reality. So the referee has to be good, to know the rule well, to apply these rules well.
Got it. And since you started, what are the main changes?
There, when I start, for the example, the vision was done by the hand, by hand. So it's not clear for you, but we take one image and we try to process this image by making a lot of filter to find, for example, the ball or some stuff on the image. Now we do this only with IA. So we take a lot of pictures, we make identification of elements, we put this in a computer, after that the computer gives us an IA that is able to recognize everything on the field. So it's better and it's simpler to implement. This year in our team, for example, the walk has been completely changed and is done by EA, by a technique that is called reinforcement learning. What we do is we put a robot in a simulator and we ask an EA to make the robot walking. And this is done a lot of time. It's many thousands of experiments that is done virtually. At the end, we take the results and we put it in a robot. And mostly the robots do what it's supposed to do and to walk alone. So in a robot there is 4 different EAs that is running to make stand
At the
up,
same time.
to walk, to know where to put the feet and to find stuff on the camera.
What about the processing? They have a big capacity.
You mean the computer?
Yeah, the computer inside
no, it's
it.
not too expensive in your computer, and I think it's the same for other computer. It's like your laptop. It's Intel i5 computer. It's something you can have at your home.
Yeah.
It's not yeah. We have to deal with this kind of resource, which is limited. But it's not something that the league imposed to us. We can have more, but we have to do with the power, with the size, with the weight. So it's how it works for us.
Got it. When are the next competitions?
I heard, but I'm not sure. Normally, the next competition the land that makes the next competition is announced at the end. So I heard it's South Korea, but I'm not sure about this information. But I heard this, so it's South Korea, from what I heard.
Is it difficult to handle these robots? I mean, about if something breaks.
So in my team, I have 2 people that is just responsible of the mechanic part, and they have a lot of work. And I thank them actually, because we make hard. We are playing with robots, so we break them. After we put the robot and say, okay, fix it. So, in these robots, the one you see on the screen is quite different because these robots are commercial one. So you can't do anything. The robot is closed, and I don't know how they do if motor breaks. Actually, they are not breaking at all. They are really good, but I don't know how they do for mechanical parts. But all of the team have a lot of. If you go to the league and see the table, you will see
many of them.
Electronic, screwdriver,
parts,
everything, the
legs,
parts,
arms.
Exactly. And this was kind of the game until now.
How many robots did your team brought here?
For my team, we have 5 robots because we play with 4 players, but you are allowed to have 2 substitute players.
Oh, it's
so
also
you can
room.
come with 6 or more if you have a lot of money. Yeah. But we have 5.
How many people are in your team?
We are 10 this year.
10.
Yeah.
And does do we have a regular number of participants, or it depends?
Yeah, on the team it's more than 12 teams. Yeah, every year. Sometimes it's more. It can go up. This year we have some withdrawal, and I think it was because of visa issue.
Yeah,
But I'm not
yeah.
sure. Yeah.
Get it. So are mostly of them are students, graduation, master's degree?
I think in other teams a lot of students. In my team we have a mix of students, technical engineering, mechanical engineering, and researcher. Maybe this is a difference with other teams that we are some researcher in computer science.
Oh.
Yeah.
And people, which area are they from? Like
Most of the other teams, they are mechatronics and
Oh.
electronics.
Yeah.
And I think we are the team with the most computer scientists.
Yeah. And well, great. How the teams between themselves, do you talk with each other, or do you have no contact?
Yeah, so we are not allowed to touch the robots, but also to communicate with robots is forbidden. But inside a team, robots are allowed to speak with others. And in my team, this is how we choose a strategy. We have one player that is called the captain, and he decides which robot goes to which point on the field, which one is the handler that is going to kick the ball, which one is the goal that is supposed to defend the goal.
Oh.
So this is how our team works. I don't know from other team, but this is important because it's about playing football. So playing with other players, not just having one player that strike and go to the goal, but make pass and defend, and choosing the right position to be efficient. So stuff like that. Yeah.
Thank you.
Thanks to you.
We got to the end of the interview.
Okay.
Thank you so much. Hope to have you here again.
Yeah.
And now we're gonna call the at-home interview.
Okay.
Thank you so much.
Bye.
Bye.
Hi guys, so we're back again and I'm here with Wagner
Hi again.
and we'll be presenting a video from at home. And can you tell me what is the task right now?
Yeah, this is storing groceries. We will see this video a couple of minutes maybe. But the main goal here is the robots needed to pick some objects from the table and get these objects
Yeah.
to the cabinet. The cabinet has a door, so the robot can choose if he will ask the referee to open this door or open this door by yourself.
By yourself, yeah.
Yeah.
So can we put the video? I'm just seeing here. So it's nice so we can,
So
yeah.
this is a video
Perfect.
that you use it to explain to the audience what is happening. So this is storing groceries, the second task for today. So this is the main goal: move objects from the one table to the cabinet. There are some optional goals: moving tiny objects, move heavy objects, open the cabinet door by yourself. The robot also can take objects from a bag in the floor.
Yeah.
So the robot go to the table, take an object, for example, an apple, go to the cabinet, find what is the other object like this. So if the robot get the apple, they need to put the apple together with another fruit.
Yeah.
And do the same for another kind of objects that they have in the table. So if you have some cleaning items, if the robots take cleaning items, there will be some cleaning items in the cabinet, and the robots needed to put these objects together.
Awesome.
This is the main goal for this task, the second task for today. Tomorrow will be more 3 tasks.
Oh yeah.
Yeah.
3 tasks.
Yeah, every day we have 2 or 3 tasks different to the competition. So today is the first day, we have 2 tasks, and tomorrow we will have 3 tasks, and another day we will have 3 tasks again, and the big final in the last day.
The big final.
Yeah.
So how many tasks do you have in total?
So we have 4 tasks for the first stage. We are already in the first stage now. This is the second task. 4 tasks for the second stage, more difficult tasks, and the
Yeah.
final with the 2 or 3 best teams.
Oh, so in the first stage, everyone participates, right?
Yeah.
What about the second stage?
The second stage we have more difficult tasks.
Yeah.
So it's allowed to every robot to participate, but
Awesome.
sometimes you have a team that's not able to do this task. So
Yeah.
normally we have less teams in the second stage.
Oh, but it's not something that you're not classified, you know?
No,
Like
no. If you have much teams, probably we will cut some ones, but for
I got
now, everyone can participate. But I think there will be less in the second
Less.
stage. This
so
is
maybe
normal. Yeah.
really difficult tasks, right?
Yeah, the second stage we try to do really more difficult tasks. So we have in the first stage a task that we call GPSR. Is a general purpose robot task, and we make it 3. We do 3 commands to the robots. And the robots need to resolve this problem. We have the same task in the second stage, but more difficult. Your robot continue receiving a lot of commands and need to resolve these commands. So we have now storing groceries happening right now. We can see a robot. The robot already opened the cabinet. the robot is trying to find some object in the table. I
Yeah.
see he's find a can. I think it's a Fanta can, I guess.
In this stage, the robot is autonomous.
Yeah, it's fully autonomous.
Really?
Yeah. So the robot starts near to the referee,
Yeah.
and the robot can choose if he need help to open the cabinet or not. I think this robot open the cabinet alone by yourself.
I see that in the robot we have a microphone.
Yeah.
This is related to some task.
Yeah. In this task, we can give a command to the robot start the task, but we have another task that the robots need to interact with the people. So they need to hear the people and talk
Understand.
to the people. The focus of this task is not to talk with the people. It's just the manipulation, understanding the kind of object
environment,
that we have. The environment, the type of the object they need to get and put in the cabinet.
Awesome.
So this is the main objective here. It's not a human-robot interaction, but we have another task that the
That's
robot
awesome.
can interact with the human.
That's awesome. And I see something really, really funny, I think. That is
So the robot gets an object, put in the they put in the cabinet, but I see the second try. I don't see what object they take it, but he tried to put in the cabinet, and probably the robot stuck in the cabinet. So the referee just pushed the button, the emergency button, and the robot stops. This is a necessary requirement to the robot participate in the competition. The emergency button need to works. If you push this button, the robot needs to stop just in the same moment.
Oh, so that's what happened.
Yeah.
You can
So
see there is an apple on the ground, right?
The referee is taking the arena ready to the next team. So I think that this team makes some points to navigate to the table, to open the cabinet, pick one object correctly, place this object in the cabinet. I don't know how much points exactly, but I think it's a lot of points. Probably they will try again and try to make more points. Well, we have another team now.
Each team has 3 chances.
It's depend of the time. If you, for example, earlier in the first task, all the teams in the first, no, not all, but a lot of teams doesn't work very well. So the task was very fast. So in the last try, we will have more time. So you make another try.
Oh, okay.
I don't know if we will have time in this task because a lot of robots is doing something. But if you have time in the second try, after the second try, we will try another one. I tell you probably. Let's see.
That's awesome.
Probably this task will be until 7 p.m. I think. Because we have a lot of teams here.
Yeah.
For this league, the OPL will have 14 teams. So one team finished, then another team is coming, and they go back to the queue and try again.
I think it's really funny how in each country we have different products. Like I can see that we have some products that I can buy in the supermarket here, but I cannot buy out of the country. You know, so do you think maybe this is difficult to them? Like they need to see, or you think because they don't need only to see the object, they need to recognize the classification of the object?
Yeah, there's no problem. This product it's only from here. Actually, this is good because in the 2 first days here in the competition, it's it's the warm up. So the robots receive a list of all objects that we have in the arena,
nice.
so they can training, make a training for these objects. So then, when task is starting, they already know what object we have in the arena, and they can make it something. This is RoboPay, a team from Brazil, from São Paulo.
This robot is very
Something was wrong. They did something wrong. They crashing in the door. I think probably he'll try again. But this time, one time the referee pushed the button. The robot needed to finish and probably try again if you have more slots.
Oh, so when the referee stops, the robot is down automatically. Like,
yeah.
And the referee, it's a button. It's like how the referee controls it.
There's a button, a big red button in every robot. This is extremely necessary. So it's in the rules. The robot needs to have this emergency button. It's a big red one, and it's
very easy to find it.
Yeah. And the robots, and yesterday we make the evaluation about the procedures of the robot, so to check the safety of the robot. So we see if the button existed, if the button works, if there are no sharp edges in the robots. So we need to make clear that the safety first is working.
So the robot is safe.
Yeah.
Safety first, right?
Safety first, yeah.
Yeah, definitely.
The robot if the robot have some cable lost, you need to resolve this before the competition. So everything needs to pass this procedure to start the competition. If the robot don't pass in this procedure, they will not allow to participate.
No, so they try to solve it sometimes, a cable, but if they don't have the red button,
if you don't have the red button, you cannot participate. It's really necessary.
Okay, so this was the last, one of the last team that we saw, or it's another?
It's another one.
These robots are so big and so nice, it's so interesting.
Yeah, these have a commercial base, a commercial manipulator, but all the others extruder was made by the team. That's a really cool thing about this OPL league, because the team can made your robots as you wish.
That's awesome.
There's another league in the other arena that will have the same robots for the all teams, but this one, each team
it's free.
It's free. Yeah.
You can do whatever you feel like and whatever works.
If the robot can pass to the door, it's okay.
That's awesome. That's awesome. And one of the main objectives of this task is to recognize the object and what is the class of the object, right? And how do robots do that? Like, they don't see, right? Or they do?
They see. They have a camera. Yeah.
But like, when they see in the camera, how can the robot understand? How these things work?
Yeah, there is a process of training the robot. We have a amount of algorithms that make this thing happen. But mainly we use neural network, artificial neural networks to do this. There is a lot of algorithms to this kind of
Certainly.
stuff. But yeah, we have a camera, look to the objects, classify them, and just because the teams have access to all the objects in the first day, they can train the
Train
robots
it
to
to
recognize
recognize.
all the objects.
Oh, that's awesome. Probably the team will try again.
Probably, yeah. I think this is the first try. Yeah, you know.
The, the robot needs to open the door.
They can choose if you want to open or not. If the robots open the door by yourself, they get more points.
Oh, that's awesome.
Yeah, just like the door in the cabinet. If the
Oh.
robots open the door by yourself, they will get more points. We have a bag in the floor too with some objects. If the robots choose to take an object from this bag, also they will get more points. And we have a table with a lot of objects. That's more easy to grasp.
Yeah.
But the robot can choose the easy objects with less points, or the hard objects
More
with
point.
more points.
Okay, that's fine. So we just saw it at home. I really thank you for your participation again. At home, it's a really interesting league of it. I mean, I really wanted to have a robot in my home to grasp objects for me. You know?
We are really close to this.
Yeah, really close.
We have a big place to test robots that today is here, but tomorrow will be in your homes.
Yeah, I hope so. So thank you a lot. Okay, thank you for your participation, and it's just the beginning, just the first day, all right?
Yeah, we have a lot of things to do in the next day. So three tasks tomorrow, two tasks in another day, and the big final.
The big final. Thank you very much.
Pode ir lá, Rodrigo. Pode ajudar o Rodrigo lá, né? Pronto. Pede pra ele ajudar o Rodrigo. Foda. Foda. Minha câmera tá parada aqui.
Hi guys, we're back again, and unfortunately we are getting closer to the end of our first day of transmission.
Yeah. Many hours, since now it's it's dark.
It's dark outside, but it was so funny. Like, looks like we just started, right?
Yeah, we interviewed many special, amazing people.
Yeah.
People who has more than a decade
Of work.
of experience here with robots, with their leagues. So we hope you liked it.
Yeah.
And if you have any suggestion, anything you want to say, you can contact us.
Follow us, and remember to stay tuned on our socials. RoboCup 2025. We'll be posting every news, everything there, and comment down below what you want to see and what are you expecting of it. And stay tuned, right?
Yeah, we're gonna be here tomorrow. Actually, we're gonna be here every day until Sunday. Starting 10 a.m.
I think we are starting to become best friends.
Yeah.
You like me and you almost best friends, okay?
So much time together, right?
Yeah, of course. That is. So don't forget to leave a like here. At our live, this is very important, and don't forget to share to everyone you know, everyone that likes or not, or don't like robotics. Just share, because it will be amazing. This was just the first day, right?
Yeah, guys, thank you for everything. Hope you still here with us.
Stay tuned. Bye bye.
Bye bye.